Hey everybody, my name is Don Felker and welcome to the Kotlin programming language course. I'm going to be your instructor on this journey. You're watching a 9-hour plus long video of the Kotlin programming language. Now there are two ways to watch this. You can watch this 9-hour video if you prefer, or if you prefer to view this in a more playlist-like fashion with smaller bite-sized lessons, there is a playlist that's linked down below in the description. You can click that and watch the same exact content just broken apart into over 130 different lessons. The goal by the end of this course is that you'll be able to start providing value on any Kotlin project that's out there. We'll cover things such as learning variables, functions, scope, classes, how to work with generics, how to work with lists, manipulate lists, maps, various different data structures, arrays, and we'll even talk about Lambda expressions a little bit. We'll wrap up the course with you creating your first Kotlin project and being able to execute it locally on your machine. When you're done with this course, you should be able to walk into any Kotlin codebase and feel okay and familiar with the code enough to start providing value. Now there are things, of course, we won't be covering, such as very advanced topics, such as coroutines and flow and things like that. However, once you have the solid fundamentals covered that are in this course, you'll be able to hop right into those topics with ease. Now, there's one last thing that I want to let you know before we get going. The installation procedures of this can change drastically depending upon when you're watching this video, which means is when you install the Kotlin IntelliJ Community Edition, which is covered in the first few minutes of this video after my introduction here, it may look a little bit different. The web page will probably look different, the installation might look a little different, and the first page where you start creating a new project might be a little bit different. So what I recommend is once you get IntelliJ installed, following the instructions you see on the website, create a new project and make sure you just select Kotlin, and then from that point forward, everything should flow smoothly for you. Now, I look forward to seeing you at the end of the video to congratulate you. Until then, if you have any questions, feel free to reply below, and I'll see you at the end. Good luck. To get started with Kotlin development, you'll need an integrated development environment, also known as an IDE. You can get one for free at jetbrains.com by going to Tools, IntelliJ. Next, find the download link and click that. From here, you can download the Community Edition, which is free for the platform of your choice, from Windows, Mac OS, to Linux. I'll be using Mac OS in this course, so I'll download the Community Edition. Once the file is downloaded, you want to go back to the download page and follow the installation instructions for the platform that you're running. I'm not going to walk through all the installation instructions for each platform, as they do change from operating system to operating system, and at times, the installation instructions also change themselves. Which brings me to the website that you're viewing now on your screen may be different from the website that you visit in your browser. If that's the case, be sure that you just find IntelliJ IDEA, find the Community Edition, and find the installation instructions. Once the application is installed and you're ready to use IntelliJ, you can start developing with the Kotlin programming language. Once you have IntelliJ installed, you'll start the application, and you'll see a window that looks something like this. You'll click Create New Project, and you'll have a list of various different options on the left here. You want to go down to Kotlin, and select Kotlin JVM. Click Next. We'll go ahead and give it a name, so we'll call Caster Kotlin. You can give it any name that you would like. You can leave the project SDK, the libraries, and everything as default, and we'll click Finish. You can go ahead and hit close if you receive a tip of the day, and you can close these windows down here, these little notifications. On the left-hand side here, you'll see that you have what's known as the project structure window. So we can view the project, the packages, and various different things inside of this window. The first thing that you'll want to do is expand this folder. You'll see an SRC folder. This is where our code is going to go. So to get started, let's create our first file. Right-click on the folder. Go to New, Kotlin File Class, and let's just call it main.kt. KT is the extension for Kotlin files. Click OK. At this point, you're ready to start writing your first line of Kotlin. If you receive a notification like this, you can choose to install the new Kotlin plugin if you'd like. If you do not receive one of these new notifications, you can go ahead and disregard this part of the video. You will receive these types of notifications when new versions of Kotlin and a new version of Kotlin plugins have been released. You can go ahead and click Install. It'll download the new plugin in the background here, and it'll show you the progress here. This is the plugin that's for IntelliJ here. You actually see these plugins by going to Preferences, and then you go to Plugins. So if you go to Preferences, you type Plugins here. You can see all the various plugins that are installed inside of IntelliJ here. And you could search for Kotlin. And you'd see that we haven't just recently installed it, so we would need to restart the IDE, as you can also see through this window down here. After you click on the Restart button, IntelliJ will restart, and the new version of Kotlin will be loaded. We can close this window, and we're back in our main.kt file. At this point, the Kotlin plugin has been updated inside of IntelliJ, and you're ready to go. To create your first Hello World application in Kotlin, what you'll do is create a main function in your file. And that's just going to be fun main. You have open and close parentheses, and then open and close curly brackets. And anytime you type this code inside of IntelliJ in any Kotlin file, you're going to get this little play button here. And what this play button will do, allow you to run it, debug it, and so forth. And we'll talk about that here in a second. Now, if we were to run this here, we would get nothing on the screen. So what we want to do is we actually want to print something to the screen. We want to print the words Hello World. Now, the println function is actually built into Kotlin. This allows us to print a given message and a line separator to the standard output stream. The standard output stream at this point is just going to be inside of our run window down here. So if we go back to our main button, hit play and hit run main.kt, you're going to see that it compiles and it completes. It may do a little bit slower on your machine, depends on the performance of your machine. And then here in the output, you'll see Hello World. And with that, you've created your first Hello World in Kotlin. Variables are the underpinning of your applications. To create a variable in Kotlin, you'll use the var keyword, and then you'll provide the name of your variable. In this case, we'll call it full name, and then you set it equal to a value. Here, I'm setting it equal to a string value of Don Felker. We now have a variable called full name, and its contents are Don Felker. If we want to print this to the screen, we can use the println command, and then we can go up and run it from this play icon and hit run main.kt. It'll compile, as we can see down here, and the output will show as Don Felker. If I run this, we can see Don Felker and John Felker. We can also set this value to a variable that's empty and print this out as well. Even though we're not really going to see anything with a full name that's empty, we hit run here, we'll see just kind of an extra line break down here. Instead of one, see there's now 2 line breaks because we have an empty one here. And also working with variables, once we have access to them, we can start accessing properties of these variables. So let's say that we wanted to inspect some properties of the full name and we wanted to see if it was empty. We can say is empty, and that's a method that's on this property. So we can check to see if the full name's empty. I'm going to hit Command B to go to the declaration, and we can see that this method, which is called isEmpty, returns true if the char sequence is empty. So a char sequence, a string. If this is empty, it's going to return true, otherwise false. So if we run this, we'll get Don Felker, John Felker, a blank line, and then we're going to see the word true. So we'll run that here. And then you can see in the window down here that we see Don Felker, John Felker, blank line, and true. The key thing to remember with variables that use the word var is if you need to change them, if you need to change your variables at any time, you'll want to use a var. So if we can set age equals 32, we can reset it and there's not going to be any problems whatsoever. Now notice one additional thing. If I were to type the word var again on age, we'd get a red squiggly line. And what this says is there's conflicting declarations, meaning we cannot define the variable age twice within the same scope here, which is inside this main function. So if I wanted to reassign it, I wouldn't say var again. I would just simply say age equals 32, and then I can reassign it. I can also print this out to the console as well and type in age, and we'll see that the age is going to print to 32. We initialized it with 30, reset it to 32, and now it's going to show as 32. One final note is that the age variable was also implicit to an integer. So again, we did not specify a type. compiler was able to determine, based upon what we set this to, that the value is an integer. You can create mutable variables in Kotlin with the var keyword, but if you'd like to create read-only variables in Kotlin, you need to use the val keyword. And so let's try the same thing that we did before. We're going to create a new variable, but this time we're going to use the val keyword, and we're going to set it to Don Felker, like we saw before. And we're going to print this to the screen. And at this point, nothing has really changed. The output's going to be the same. We've created a variable called full name. It contains the contents Don Felker, and when we run it, we get Don Felker down here at the bottom. However, the big difference here is when we use the val keyword, we're creating a read-only variable, which means I can only assign it once. Therefore, if I want to assign the variable again, or I attempt to, I'll change this to John Felker. And then we automatically get a red squiggly in IntelliJ because IntelliJ's Kotlin plugin realizes there's a problem. And what it's saying is the val cannot be reassigned. So even if I say, hey, you know what, I'm going to ignore the IDE, I want it to run and compile it. I try to compile this, we're going to get a compiler error. And it's going to say, hey, look, we couldn't compile this because there's an error. Vals cannot be reassigned here, and it's on line number 5. So we go over here to line number 5, and there's our problem. Full name cannot be reassigned. So once we have a variable that's created with the val keyword, we cannot reassign it. And the same goes for other types too. So if we were to use age and say 32, that's fine. You can print that to the screen as well. And then if we tried again to reassign val, we could say that's 42 now. We could see that this is not going to work. And again, to verify it, we'll run, which will fire off the compiler. And we'll say, hey, that the val cannot be reassigned. We're on line 8 right here. That's what this first number is, the line number. And we're on line 8, and its value is 42, cannot be reassigned. So we cannot reassign vals. So these are read-only variables. These are great for things that you do not want to change in your application. You don't ever expect them to change, and you'd like to verify that and enforce that through the compiler. Up until now, all variables have been implicitly declared. Therefore, if we have a variable and we call it full name and we set it equal to a string equivalent to Don Felker, the type is going to be a string. And we can actually verify that by doing a little bit of inspection here on the actual type. So I print the full name and do : and tell it, hey, what class does this full name actually belong to? And if we run it, we can actually see that it comes back as a Kotlin string. So we're working with a string here. Now, there are times that you would like to specify the type of the variable explicitly. And you can do that by providing a colon after the name of the variable, and then providing the type. So here would be string. I would see Don Felker. If perhaps I put the wrong type here, perhaps I typed integer, and then I set it equal to Don Felker, we get actually an error. And it says, well, the type is mismatched. We require an int because the full name variable is an int. So you're trying to set a string. That's just not going to work. And if we try to compile it by skipping the IDE, it's going to say the same thing. The inferred type is string, but the actual int was expected. So either we have to change the explicit type, or we need to change their value here. So for example, if we wanted a age, we wanted to explicitly provide the type, we would provide the type here. So anytime you like to provide the type for either a val or a var, you just have to type the variable name, colon, and then the type that's going to equal to explicitly provide the type to your variables. Kotlin has many built-in types. Let's go ahead and explore the number types. The lowest number type is a byte. So I'm going to create a variable called myByte, and it's of type byte. And I'm going to set it to a value of 8. Bytes are equivalent to 8-bit signed integers. The next one up is a short. So I'll call this one myShort, and we'll explicitly provide the value of short. And I'm going to set this one value to equal to 16. And this is a 16-bit signed integer. So as you can see, as we move up, the numbers are going to get bigger, meaning that the values that they can store are going to be bigger, which brings us to the most popular probably in regards to programming that you see, and that's going to be the integer value. And this is going to be equivalent to a 32-bit signed integer. Next up, we have a long. Now, a long is a very long number, so it's kind of a good name for it. It's a long number that you could use. And that's going to be equivalent to a 64-bit signed integer. Now, these are going to be the most common types that you use when you're working with numbers. So you're going to be using these. And most often, you're going to probably be using an integer value, as it will cover 90% of your use cases. If you need to use a long number, which is very long, then you want to use a long. And there's times when you do want to use that. Perhaps you're storing numerical values that that are very lengthy. However, there are also times when you do need to store decimal values. So if you do need to store decimal values, there's also something known as a float. And so we'll say like this, a float. And we're going to say this one is equal to 32.00. And I'll put an F here because that means in literal terms that this is a float. And what this thing is equivalent to is a 32-bit floating point number. So this is a smaller decimal we can use. Now, if you need to use a larger decimal, you're going to use a double. And that's going to be called double, and that's equivalent to 64. And that's going to be a 64-bit floating point number. So these are kind of the basic numbers that you're going to use inside of your day-to-day application development. Now, there's something interesting about each one of these. If we go to the definition of any of these, and I'll start with byte, we can see that byte extends number. We can also go back to the previous file, short, and we'll look at that. It also extends number. And as we walk down each one of these, you're going to notice that every one of them, from integer to long to a float to double, etc., all of them implement the number abstract class. So let's go take a look at that again. What does that look like? If we go to the number implementation, we'll see that it has a bunch of functions on here that we can access, which is interesting, which means if we go talk about this for a second, that every type, every object, everything in Kotlin is an object. So even this integer value is an object. This long is an object. This byte is an object, which means that we can call methods and properties on these. So if I want to print ln my byte dot, perhaps I want to perform division operation. There's a bunch of math operations you can perform on here. These are built into there from the various different types. If I want to say to double, I could say to double, and that would turn my byte into a double. And this actually comes from the number class. Remember, if we go to the parent declaration, which was command U, we can see that this came from to double. And so it returns a double. And so it would take this byte and turn it into now a double. So if we were to print this, and let's get the type information by providing : class, and then running it, you would see that it does return a double. Now, if we were to come over here, we could actually change this to a long. We could run it again, and you would see that it returns a long. So there we go, 8. And we forgot to provide the values there. Say class, run it again, and we'll see that we now have class kotlin.long. When working with certain numbers, such as longs, we can take and we can use the literals, and we can say big long. We can say this is a long value, and then we can actually do some cool syntax. And so what this does is it's built-in syntax to Kotlin that makes it easier to read. So this is equivalent to 1 million. So if I were to print line, and we were to print this big long in here and run it, we would actually see that this is just going to print out as 1 million. But it makes it just a lot easier. These underscores do, because you can read it. This is very valuable if you have a constant in your application that you know is always going to be 1 million, or it's always going to be 1,000 or something like that. You can make this a lot easier to read, because let's say you're going to go for 1 billion. This is much easier to read than this, because you're not sure by looking at this if is that 1 billion or is that 100 million. It's really hard to tell, but just by adding these simple separators, we can actually tell real easily that that would be 1 billion. One of the additional things that we can do with numbers is we can, of course, add them together. So we could say my int, we'll say new int equals my int plus 12, and that would equal 44, but we can print that to the screen, and say new int. And when we run this, we'll see down here in the bottom that we're going to get 44 right there. But we can also do an additional thing by using the built-in methods. Plus, we can say 12. Now we could run that here. So there's some nice syntactic sugar to say plus. We're going to get 44. We can also do minus. We can run this, and you'll see that we also get 44. And there's a bunch of other math operations that we can inspect inside of here by simply providing the dot to get the code completion and implement them. And so if you're not familiar with much of these, you can hop into there. And let's say, for example, you're not too familiar with the word and is. You could take Command B and go to that and say it would perform a bitwise and operation between these two values. So if you want to do bitwise math, you can do that with the and. You could add plus. You could do multiply times. And then you could run that. So 32 times 12. It's going to run here. We'll have 384. And so these are the basic types from smallest to largest. You're going to start with byte, short, int, long. And then when we get to decimals, you have float and you have double. These are the built-in number types in Kotlin. In Kotlin, strings are also known as objects. So if we stick with our traditional example of full name, and we explicitly define the type of string and set it to Don Felker, we now have an object known as full name that contains a value Don Felker. We can call different methods and properties on the full name variable by typing dot to get perhaps the length. This will provide us the length here. I'm going to duplicate this line by pressing Command D. I can also get the actual characters in it, which are going to provide us a stream of characters. I can do a whole bunch of different other things on side of here as well. So, for example, I can decapitalize it. So let's do decapitalize. And if I were to run these, we're going to see that we have Don Felker, and then decapitalize was decapitalizing this if this was a sentence. So I could say, hello world. And if I were to run it again, we would see that the sentence hello world is decapitalized by decapitalizing the first letter. If I realized I wanted everything to be lowercase, I'd say to lowercase. And I could set run, and then that would actually allow me to create this as all lowercase. Now, strings are built inside of Kotlin with double quotes. So we could say first name is Don, and that's a double quote. There's also another type. Anytime we're working with like characters, we can then use what's known as a char. So I could say val c, and that could be a type char equals x. But hold on a second. Here's a weird thing. It's only a single character. Why is it complaining? That's because in Kotlin, if you want to define a character, you have to define it with single tick quotes. So single quotes allows you to implement a char, which is a single character representation. Now there are some things that are some caveats to this. So there's also characters such as the tab character that you have to escape with a /t. There's the n for the new line, and of course the double slash for backslash, and various other different types of escapes that you're going to try to do. In Kotlin, a char represents a 16-bit Unicode character. So anytime you need to use a single character, you're going to want to use char. Now this doesn't limit you from also using a single character string if you would like to. You could say string foo equals y. And this would still work. You could still work with a value of string. However, a string is going to be larger in memory than a character, but you could still use a string if you'd like to. However, if you know that you're only going to be working with single characters, then you would use the char type. Sometimes when you're declaring your strings, you need to declare them in multiple lines. So I might say that I have a message here, and this message would be hello, and I would put a new line here. My name is Don Felker. How are you? Then I would print this to the screen. And then once this ran, we'd see a nice little message here. Hello, my name's Don Felker. How are you? However, sometimes this gets kind of ugly, and there is actually a better way to do this in Kotlin. And you can actually use the triple quotes here. And you say, hello, my name is Don Felker. How are you? And then I'm just going to run this again. And I'm using the shortcut key to run it, which if you see here is actually just going to be Control-Shift-R on a Mac. And you'll notice the same thing came out here. Hello, my name is Don Felker. But what is this trim indent thing? What is going on here? This is basically a raw string triple quoted. And then we have the trim indent function, which basically, if we look at it, it detects the minimal indentation of the input lines and removes it from every line. So if I remove this line, what you're going to see down here is this is actually going to be indented. It's actually going to have a new line, and then it's going to be indented. So let's watch this. We'll run this again. And you can see there's a line above, and it's all been indented. So if I put the trim indent back, what it basically is doing is it's removing all of this and the new line that's up here. I'll rerun it, and it shoves it back in there. Now I can also do something called replace indent. Like, for example, if I know that maybe I'm building some string and I'm kind of building this stuff up manually, I can replace that indent with something that looks like ABC, and some maybe a pipe symbol or whatever like that. And now if I run this, it'll replace that indent, which was all those things, with these on each line. So ABC hyphen pipe hyphen, which is kind of cool. So if I'm building something, I can actually kind of provide these pre-formatted things there. I can also say my trim margin, and I can provide a prefix. So maybe I've decided that I already know that I just want that prefix to be these 3 arrows. So I'll run that, and it will run. And it says, all right, well, I didn't trim anything because I didn't find these 3 arrows. So what this means is these 3 arrows would need to be right here. Let's say for whatever reason that string had these 3 arrows, right? We'll run that. And there we go. Now it's not going to print those. If I remove this, we'll actually see it print with those 3 arrows and this area here. Now by default, trim margin defaults itself to pipes, which means I could set this to a pipe. I could run that. There we go. It's just going to replace those pipes. By default, it checks for pipes. So you can do a nice string here, multi-line string with triple quotes. Another thing you can do is, let's assume that you have a name, and we'll just call it Don. And sometimes you want to print a message like we have here. Let's print this message. Don, let's say we want to say hello to Don. We'll say hello. Traditionally, in most languages, you just do string concatenation, which works fine. We hit enter, and it says hello, Don. That works fine. Now notice something. There's a little squiggly here. It says convert concatenation to template. So you can actually use string interpolation into templates. So I hit Alt, enter there, and it gave me this pop-up, and I hit enter again, and it automatically converted this code for me. And this does the same exact thing. And now what this does is it actually prints hello Don. So it's actually one big string. And then we could actually have one here to say age, and we'll just say 32. And then we'd say hello Don, hello name. Your age is, and we put this thing in here, so age. And it would print the age inside of here. And now one other thing that we can also do that's cool inside of these things is say something like this. So hello name, your age is, and your name is, we would say $. And we put open curly braces because now I need to call a property or a method, and I'd say name dot, so name dot length. And so what this says is, it would say, hello, Don, your age is 32, and your name is, what would that be, 4 characters long. So let's run that. So hello, Don, your age is 32, and your name is 4 characters long. So now instead of using a very complicated replacement or anything else like that, I can use string interpolation and interpolate these variables. If you're not going to be calling into the object graph at all, so you're not doing this dot anything, then you can just call $ variable name. Otherwise, you'll need to do $ open curly bracket, put your code and your expression inside of here, and close curly bracket, and that's it. Last but certainly not least is the Boolean value, and we could specify one like this. So we could say is blank. It would provide us a true or false value, and we'll just initialize it to false. And so this just basically has 2 options, and that's true or false. When we go to the implementation, again, everything in Kotlin is an object. And so there's some other built-in operators here. So we could do the inverse of that. So if we wanted to know, for example, let's just print this. Print ln is blank. And then we could just do print ln is blank and then not. And this will print the inverse of it if we run it again. We see here in our output window, of course, we had false and then we have true. So we initialize it to false and then true. We can also initialize it, of course, using other variables such as a string. So we'll say is blank. And then we can use a string. So we go blank dot is blank. So this is just a function is blank on a string. So this is a char sequence function that checks to see if the length is 0 and it returns a Boolean value. And if it's 0, then it's going to return true. So we could print this off here. I'm just going to copy this. And then we could see the value true or false. So we'll run this. And of course, it's blank. Of course, if we change this to first name Don and we run it, it's going to end up false. Then again, we'll say false. Of course, we did the inverse, which is not. And there's many other functions on this Kotlin object that you can also inspect that you can do, which is going to be or, XOR, etc., and a bunch of other ones inside there. You can check them out by navigating to the Boolean section there. But if you need something that represents a true or false condition, you'll want to use Boolean. Working with conditionals is a very common thing that you'll do in the Kotlin language. Let's assume that you're building an application which will track your calories. And let's assume we start with 2,500 calories. And these would be the calories that we consumed already or that a user has consumed and they're tracking for their diet purposes. Now let's assume that we had a requirement that says if the calories that have been consumed are over 2,000, then we have to print a message to the viewer or the end user to let them know that they've eaten enough, they've consumed all of their calories for the day. So here we see that they've consumed all their calories for a day. Now if we run this, you're going to see down here in the bottom window that we can see that they've consumed all their calories for the day down here at the bottom. Now if we were to change this, let's say to 1900, we're going to notice that the line of code here on line 4 does not get run because the calories are less than 2,000. So that means we're not going to print this line. So let's say for some reason we wanted to check to see, otherwise if they haven't eaten all 2,000, we can say something else like, okay, you still have some calories left. So we'll say print line. And if we were to run this, we would see now that you still have some calories left. So we know that, again, this is a conditional, this is an if conditional, and this is the else portion. So if there are over 2,000 calories consumed, this line of code is going to be printed. Otherwise, else, we're going to print this. So any other types of, if it does not match this condition, so anything less than 2,000 is going to show up here. So we even just put this to 2001 and rerun this. You're going to see that we have consumed all of our calories for the day. Now let's assume that you're working with someone and they decide, or you decide in your app that you would like to make sure that if they've consumed over 1,500, then what you would like to do is give them a little bit of motivation and to let them know they have a little bit of room to have like a snack or something. And so you can say if calories is is greater than 1,500. So here, perhaps it's 2,000. So if the calories are greater than 1,500, we can say println and say you have a few more calories left to eat. And so if we run this, again, what we're going to see here is still the top line. You've consumed all of your calories for the day. Let's go ahead and make an adjustment saying we've eaten 1,750 and we're running our program. And the program will now say, you have a few more calories to eat, as we can see down here in the bottom. And then if for some reason we even set this to 1499, which means this condition will be false, and then it checks this condition will be false, which means anything in the else block would now be printed. So let's run that, and we can see that you still have some calories left, which is pretty cool. So you can keep adding on these various different else ifs. So if we wanted to add another one here, we could add another else if as well. And we could say something else like calories is greater than 1,200. And perhaps we would just want to give another message here like this. And then if you were to run this and you were to set this at, let's say 1,400, and we were to run this, you could see down here at the bottom, you have some room for snacks. So we can keep adjusting this and play with this. And there's no limit to the amount of else ifs that you can throw in here. So if you have many conditions, so if you only have, one condition, it may just equate to be something like this. It's very simple, your if or else. You do not have to have an else either. If you don't want to have an else, and you just need to perform some type of action only if one value is true here, then you go ahead and print this. So a else is not required. The else ifs are not required if you're using an if statement. So again, just an if statement, or you continually add else ifs, and we can continue to add these if we wanted to. So we could add another one here, and we could say calories are greater than 1,000. And you could say you have plenty of calories left, etc. And as we go down, so again, if we were to go to 1,100, that line would now print, you have plenty of calories left. And if again, we dropped it down to, let's say 800, and we ran it, which one do you think would run here? It's actually going to be the bottom one here, because the calories is not greater than 2,000. It's not greater than 1,500. It's not greater than 1,200. It's not greater than 1,000. So therefore, the final condition is going to run. And this is a very simple if-else conditional that you can use. These are going to be the most traditional type of if-elses that you see in your programs. In Kotlin, you can also omit the closing parentheses and open parentheses of a condition if it's a one-liner. So let's say if the age is greater than 10, you can actually just write println is greater than 10. So let's go ahead and change this actually to 11, and we run it. We're going to see that the output in the window down here is the age is greater than 10. Now, if for some reason we change this to 9, notice how this still runs, yet we don't get an error, but we don't see that the age is greater than 10, because a single line if statement can now just be printed without parentheses. However, this should be often avoided, as it can be confusing even if I were to do something like this. If I were just to type this, just based upon the indentation, you would think that hello there would not be printed. But however, hello there is not part of the if condition. The highlighted area you see here is part of the if condition. This print line hello there is not part of the if condition. So if you know that you're going to have code here, it can be very confusing. So it's usually often better to just go ahead and provide the braces, as it's much more readable. And when you're writing code, you should be trying to write code that you can understand in the future. Now, one thing I did mention for a quick second was the word one-liner, or words one-liner. What that means is you can actually put this all in the same line here. Now, if I were to run this, it'll compile and everything, and we'll just see the words hello there. And that's because hello there, that's because the age is 9, and we're looking for age greater than 10. So let's change this to 11. And then if we were to run this single line of code is actually pretty easy to read. So now if you're just going to write a single line, this is very readable, and we know that this line below it, hello there, is not going to get executed. So if you're just writing a single line, it's very often you'll see this, and you can remove the parentheses, the brackets, as I've done here. And if we're going to run this, we're going to see the two things here. The age is greater than 10. You drop this to 9, and we're only going to see the words hello there, because the if condition has not been met. Now you can also take this a step further. If you know that your if-else condition might be very short, you can actually all do this on one line. So print line, and we could say the age is less than 10. And so we can actually have the entire if-else condition right here on a line. And it's very small, it's very easy to read. And so if we're to run this, again, we're now going to see down at the bottom, the age is less than 10, and then the words hello there. If I change this to 17 and we run it again, we're now going to see that the age is greater than 10. And of course, we're still going to see the words hello there, because it's printing its own statement. So you can definitely create if-else statements on a single line, and it's advised to do it only when they're a single line. It's also good to mention if your else statement becomes very, very long and you have to continually scroll and there's just a lot of text over here. So if I were to say my content went way over here, and in the editor, I had to kind of look over, you'll see this little gray line here. This gray line is kind of the recommended line break. So if you had a bunch of text, and I'm just going to type a bunch of garbage in here. If I had this line that went beyond here, this recommended line is where your line break should be. So if it goes past that line, you should probably consider breaking this into a traditional if-else statement, which we can just put brackets there and the IDE will apply them for us. Now it's much easier to read. It doesn't require that I do any horizontal scrolling and makes it easier to understand the code by just looking at it. A fundamental understanding of truth tables will help you understand what's going on inside of your if statement and if it will evaluate to true or if it will evaluate to false and execute this line down here. So let's hop over and take a look at some simple truth tables. Here I have created two truth tables, one on the left, which is the logical conjunction and, which we'll talk about first, and then we'll move on to the logical conjunction or. A logical conjunction and states that we have two variables, P and Q. And this is read on the right-hand side, P and Q. So you'd have P, the up arrow, Q, and it's read as P and Q, and that's what it evaluates to. So if P is true and Q is true, then if we were to combine them, P and Q would be true. If we have a P that is true, but a Q that is false, well then that would equate to a false representation in this truth table. So if the first expression, so if we go back to our code, if our first expression was true, yet our second expression was false, and we're using a logical and, this is an and operator, the ampersand means logical and, then the false would be executed because the second item here is false. We can move on to the third line. If the first item is false, and the second item is true, it's still going to be false because in order to get a true value, we need both of them to be true. So back to the code, this one at this point would be false and this one would be true. If we were to AND these together, it would not equate to true, so we would be executing the else statement down here. And lastly, if both the items are false, then of course, if we logically AND them together, we're going to get a false statement. So back in the code, if both of these are false up here, this is false, and this statement is false, then of course it's going to execute down here. Now on the other side of the fence, we have a logical conjunction or. Now this is operated in code. Let's go back to the code here. And we change a or to be with two lines. And so that's going to be a logical or. So what this says is here is this statement has to be true or this statement has to be true. And if either one of these are true, if this one's true or this one's true, then it's okay to continue on and execute this line of code. However, if both of them are false, well then it's going to execute this false statement down here in the else. And so let's take a look at them. Again, we're using P and Q, and it's read as P or Q, and that's that little V thing there is supposed to be a down arrow. And so if P is true or Q is true, then of course the resulting truth would be true. If P is true and Q is false, well, we're still saying, hey, either one of these is fine, so let's go ahead and move forward. And that would be basically like saying, if this is true, then okay, we can continue. Or if this is true, that's okay, let's continue. Same thing here. If the first item in the evaluation is false, so P is false and Q is true, then our logical or conjunction would equate to true, meaning that, back into the code, that if this is false, so this equates to false, so false, it's going to go to the next item over here, and it's going to return true. So it says, oh, I found a true here, which means I'm going to execute this line here. And lastly, we have the false or false. So if both of them are false, back in the code, so if this is false, or this is false, which means they're both false, means neither one of them are true, then it's going to execute the else statement. There's one thing important to note is that these conditionals, when we use the logical operation or the logical operation and, are known as short circuiting, which means that if this operation here is false, it's just going to skip this together. It's just going to, what will happen is Kotlin will say, oh, you want me to AND these together, so I'm going to need this value, and I'm going to need this value. What it's going to do is at runtime, it'll check, say, hey, is this false? Okay, I already know this is false, which means this whole statement's going to be is going to equate to false because the first one's already false, and you're asking me to have both of them be true. So what you would then do is, Kotlin would then do is say, all right, well, I'm just going to go ahead and skip this. I'm going to short circuit this because I know that there's no way and no reason for me to even run this code over here because I've already determined that this first piece is false, and we need both of them to be true in order to continue. On the opposite side of the spectrum, we have or this could be short-circuited here. So for example, let's assume that this was true. So we're basically saying, if this is true or this is true, print this statement right here. So what this would mean is Kotlin would short circuit. If this was true, it wouldn't even bother checking to see if this was true at all. So it would short circuit this entire operation. So, all right, this is true. All right, cool. I'm not even going to worry about executing this statement over here. However, if this was false right here, it would say, okay, this is false. So I need to go check the next one because I'm going to logically OR them. And I'll check to see if this one is true. And it says, oh, this one's true. Okay, I'm going to use this. Now this could continue on as well. If you had, for example, we could have another condition here. We might say my age equals my name dot length. And so we can actually have three conditions here. So this one right here might equate to false. This one might equate to true. And if it does equate to true, it's going to skip the rest of the conditional here because we've already found a true. And Kotlin knows, hey, we're just trying to OR all of these together. And so understanding basic truth tables is a humongous help in understanding what's going to happen in your conditional statements. In Kotlin, there are two types of equality, structural and referential. Let's assume that we have two string variables by the name of name1 and name2, both containing different strings. We could compare them and see if they're the same by using the structural equivalent operator, which is the equals sign, to say, hey, is name1 equal to name2? And if we were to run this, it would output to the terminal window saying that it's false, that name1 does not equal name2. Now this is very similar to other languages such as Java's equals method, which you can also use. And you'll see this here. And if we run this, we'll also get false here as well. Notice this squiggly line here. If you put your cursor there and you hit Alt-Enter, you'll get a pop-up. Otherwise, you can just click on the little light bulb and say replace with equals. This is the more idiomatic way to do it in Kotlin. So this says, hey, is name1 equal to name2? Now there's also, if we were to change this, so let's say that this was change name2 to Dawn, this would then evaluate the true because the structure of the contents are the same. So they are the same types and the same contents. So structural equality is true. And so if we return this back to 2char and we say, hey, I want to see if these are different, we can use what's known as structural inequality. And that's going to be with the exclamation and equal sign. Now, if we run this, we're going to see that we have a true, that Dawn does not equal 2char. Now, if I change the second one to Dawn again, what do we think is going to happen here? Dawn does not equal Dawn. Well, that's going to be false because these two are exactly the same. So that is the way that you can use structural equalities inside of Kotlin. You're going to get the first one, which is equals is the regular equality, and exclamation equals is inequality. The other type of equality checking is referential equalities, and we can determine those using a different operator. So let's assume that we have one variable that's equal to 12 named A, and another variable that's equal to 12 is B. And now since everything in Kotlin is an object, these you would think would be different objects. So if we were to run this, we're going to use referential equality with the three equal signs, which is referential equality, saying, hey, is A equal to the same object as B? We're going to get true, which if you know about references in memory, this was not make any sense, except there is a caveat in Kotlin, and that is numbers, characters, and booleans. So numbers and booleans all have a special internal representation, and they're represented as primitives at runtime. But to users, they look like ordinary classes. Therefore, the triples equals is the same effective thing as the double equals when we're using primitives. So let's get rid of these primitives here, and let's go ahead and we're going to jump ahead real quick, and we're going to create a class. And this is a very simple class with a user who has a name that is a string. And let's set person A equal to person, and we'll give them the name Dawn, and then person B will also have the same name Dawn. And then what we'll do is we'll do referential a referential equality check here, run the program to see if object A equals object B. And as it runs down here, we have false, which means that object A does not equal object B, meaning that it does not share the same object. It's not the same object whatsoever. We could also change these things around and do referential inequality. So we would do exclamation equal equals. That would say object A does not equal object B. So they're not pointing at the same place in memory. So if we were to run this, you would see that we now get back true. And we're getting back true because person A is a completely different object than person B. They're stored in completely different parts of memory. So for referential integrity, we have the triple equals, which is equality. And then we have exclamation equals equals, which is inequality. One of the goals of Kotlin's type system is to eliminate null reference exceptions. So if you were to take this existing name variable and set it equal to null, you would notice that you would not be allowed to do that. And the reason being is this string is known as a non-null reference. If you wanted to create a nullable reference, you would still say string, but you would add the question mark at the end. This would allow the name 2 to be reassigned to null. The same goes for other types as well, such as age. We might say this is int, and we put 32. However, if we tried to assign age to null, this would not be allowed either. So anytime we would like to make maybe age or any other type, we need to remember to add the question mark at the end, which then would allow us to set the type to null. Even if we had a simple class, such as a person class, we could say var person equals person. That would work fine, but if we were to reassign person to a null, this would not be allowed because we are guaranteeing that this is a non-nullable reference. However, if we did want a null reference, we could say person2. We would need to provide the type here because it's going to be a nullable type, and then we could say equals person foo. Now I could set person2 equal to null. When working with non-nullable references as the first name variable here, if we wanted to see the length of the first name, we would simply say firstname.length. This would give us the length. There's no need to check to see if first name is null because we're using a non-nullable reference and Kotlin guarantees that that will not be null. When we are using a non-nullable reference, if we attempt to do the same thing, and we get the last name.length, you'll notice that we have a red squiggly here. So what we have to do is introduce what's known as a safe call. This basically says, if the last name is null, then go ahead and make this null. Otherwise, give it the length. So this variable could be equivalent to one of two things, either null or the number 6, because there's 6 characters in the word Felker. So if the last name is null, it would return null. Otherwise, it would return length. You could do the same thing with an if statement as well in one line. So you could say if last name does not equal null, then you could say last name.length, else we'll say 0. Now what this is doing is saying last name, we're checking to see if last name is not null, then we're going to get the length. Now notice how I did not use the safe call operator here. The reason is Kotlin recognizes in this if statement we are checking to see if last name is null. Therefore, I don't have to check for null here because it was already taken care of in this step. However, if for some reason last name is null, then we'll just go ahead and return a value of 0. So either way, the answer here would be we're either going to get 6 or we're going to get 0. Now, of course, you could change this to null if you would like. That would essentially do the same thing as the above, but most likely you probably want some type of value in your code. So you can do this with a single line if. Now you can also chain these safe calls together. So let's say that we wanted the first 2 letters of the last name, and then we wanted the length of the last name. Notice how we would need, so say length 4. So last name says it needs a safe call. And notice now the next one needs a safe call. So what this one will do is says, hey, if last name is null, then just go ahead and return null. If last name is not null, go ahead and pull the substring off of that. So grab the first 2 characters. And if for some reason that's null, go ahead and return null. Otherwise, go ahead and return length. Now you may have in other languages seen something very similar to this. If last name does not equal null and last name dot length is greater than 1, then you might want to continue off there and get, then you could have your if statement to say that your length or whatever is, to check to make sure it's not null. So this would be very common in other languages such as Java, but here you can start chaining these calls together. You could even take this even further by saying last name dot substring would say 05, so we get the first 5 characters. Then we could say something different like drop the last 2 characters, then we could get another substring of those, and then we would say we want the second one to the third one, and then we would say length. And so we could say length 5 equals this. Now, because this could be null all the way across, we would need to use safe calls. So every time all the way across, we need to use these safe calls, meaning that if any of these were to return null, length 5 will be null. Otherwise, it will be the length. When working with nullable types, it's often to want to retrieve a value. So let's say the length again of a certain, maybe the last name string. You want to get the length of that. And so you need to perform some type of safe operation to get that value. However, this is going to leave us in a certain situation where we could either have null or the length of the string last name, which is 6. So we could get either one. Let's say for whatever reason, we determined that we know we wanted a non-null reference. So in that case, we're going to get an error because last name.length is going to return us a null. So how would we fix that? You could fix that with a simple if statement. So what we could do is we could just check to see if the last name does not equal null, then give us a length, otherwise give us 0. And we can get rid of the safe call here because, again, this null has already been checked. So what this will return is a non-null reference of length, either the length of the actual string variable, otherwise 0. Now this can also be short-circuited as well. So we'll say length 2 int, and this can be short-circuited using what's known as the Elvis operator. And the Elvis operator looks like this. It's a question mark, colon, and then a value. And what this means is, the Elvis operator means is, if anything on the left-hand side of this Elvis operator is null, then return this value. So if last name is null, then return it. We could even go a step further and chain some things together. So we could actually say 0, 2. We could do multiple safe calls in order. So if last name is null or this substring is null, then return 0. Otherwise, return us the length here. And this will give us a non-null reference. Now you may be wondering, why is this called the Elvis operator? Well, if we turn it sideways and zoom in and have this image here, you can see that it looks like Elvis Presley's hair, and that's why it's called the Elvis operator. To create a function in Kotlin, what you'll need to do is use the keyword fun and then the name of your function. So we could create one called hello world, and you'll have open and close parentheses, and then open and close brackets here will give you a function that you can call. Now, if we were to call hello world from somewhere, to call that, again, our main function is going to be called because we have a little run button here. If we want to execute whatever is inside of the hello world function, we would need to call the hello world function, and we do that by just typing the word hello world, the name of the function here, with the open and close parentheses. Now, if I were to run this, you would see that nothing is going to happen because inside of this function, we're not really telling Kotlin to do anything at all. And you see it, the program exited. If we wanted to do something in here, what we could say is we could say print line, and what we could say is hello world inside of here with double quotes. And then up here, when we now run it, we'll see Kotlin will compile it and we'll print hello world right here to the screen. Now we could change this function name to something else. So let's call it something fancy like purple cow. So we have purple cow here, and I'm going to go ahead and copy and paste that name there, purple cow. Anytime I call purple cow, it's going to print hello world. Again, we'll just double check that here to make sure. And there we go. We see hello world here. Now, the cool thing about functions is you can call them over and over. So I'm going to copy this, go to a new line. I'm going to paste it again and again and again. So if you're wondering what's going to happen is, due to the procedural nature of Kotlin, it's going to execute this code, which means it's going to walk into this function and it's going to run whatever's inside of here. Now it's going to, and then after that, it's going to come into this function and call into whatever is inside of here. So basically it's going to call this purple cow function 1, 2, 3, 4 times. So we should see print line of hello world 4 times down in here in our run window, which we do. We see hello world. Now, the cool thing about functions is that we can actually change what's inside of them, and it will change anytime you call it. So if I realize I have in my application purple cow called 4 times, and I want to change this to say, oops, you know what? This should actually say hello purple cow. I can just change it here. Now when I run it, we should see down here hello purple cow 4 times. So we'll see hello world purple cow. There we go. It shows up 4 times. Now I can also do other things inside of this function. So a function is just a place where we can put other code that we would like to call it over and over and over. So it's kind of like a reusable piece of application code that you can use over. So if I were to do something else, I could say print line, hello there. And now what we're going to see is hello purple cow, and then it's going to print hello there, but it's going to print that 4 times. So if we run this here, you're going to see that it's going to call hello purple cow, hello there, hello purple cow, hello there. Because what's happening is each time this line of purple cow is called, 2 things are being executed inside of here. Now, functions can also call other functions. So this just kind of makes sense because inside of the main function here, we're calling another function called purple cow, but also inside of purple cow, we could also call another function called moo. And maybe this function might just say moo, and we'll call a function called moo. And inside of here, we'll do println moo. Now what will happen is when purple cow is called, we'll see hello purple cow. Then we're going to see print line is going to be called, hello there is going to be called. So hello purple cow, hello there. And then the purple cow function is going to call the moo function. And the moo function is going to say moo. And so if we were to run this here, you would see that it's going to call, here we go, hello purple cow, hello there, moo. Hello purple cow, hello there, moo. So now I can actually change this around if I decide, hey, you know what, I want to move this up here, and I wanted to change this to say, hello pink cow. Or let's do blue. Let's do hello blue cow, and we'll do moo. Now if I hit run again, we're going to see, what do you think was going to happen? We're going to see hello purple cow, moo, hello blue cow, moo. And so we just see moo between each one of these because that's all that moo is doing. And then we could add something to this if we want, of course, to say moo moo buckaroo. And if I were to run this again, we would see all different types of stuff here. So it kind of makes sense. Hello purple cow, moo, moo moo buckaroo. Hello blue cow, moo, moo moo buckaroo. Say that 10 times fast. So as you can see, these are just very simple functions, but the functions allow you to reuse code. Now I can also come up here and say, I could say I want to do moo right here, and I don't really want to have it here. So I can kind of use these reusable chunks here. In this case, we're just going to say purple cow once, we'll do the moo routine, and then we'll just print purple cow. And so, like I said, each one of these functions allows us to have reusable chunks of code. So we started off with hello purple cow, hello blue cow, and then we did the moo, moo moo buckaroo, and then it went back and executed the purple cow function 3 or 4 times. So this is how you create a very simple function. This function has, as you currently see, no return type specified. And because we don't have any return type specified, what is actually returned is a unit type. And we'll talk about that here in a second. But if we leave it off there, by default, any function that does not specify a particular return type will return a unit. So we'll get to that in a second. By default, all functions in Kotlin have a return type of unit. So if we create a function called say hi, that's just going to print out some text to the screen, such as hello world, and we can call it here, it doesn't have a return type. And then to specify a return type in Kotlin's functions, you're just going to, after the parentheses here, you'll put a colon, and then the type that this function is going to return. So if it returns something back, you could say it's going to return back a unit. So you'll notice at this point in time, I don't have any type of statement to tell it to return a unit or anything like that. I could do this and it would work just fine. But by default, all functions that don't have a return type return unit, which if you see the IDE, IntelliJ is saying that the unit is redundant, so I can Alt Enter, or I can click on this little light bulb and say remove the explicit type declaration. So I've done that. Now to prove that this does return a unit, I can actually just create a variable, and I'm going to print this variable to the screen. So whatever X is here, because again, say hi is going to return something, and because this function does not have a return type specified, by default, it's actually just going to be a unit. We'll just leave that off to show you that. And since it's returning something, I can set it equal to a value. So it's also valid to call this just like this and have it execute the function. I don't have to do anything with the return type, but if I would like to, I could actually take that, stuff it into a variable, as I'm doing here, into the to variable x, and I'm gonna print it to the screen. Now, once we run this here, say hi is gonna execute, it's gonna return a unit, and you can see it printed the hello world text, and then it printed the type, which is Kotlin.unit. So that is the unit type. And so again, if I just specify it here, unit, again, I'm not having to specify a return statement because just by default, if it's a function like this, it will return a unit. And there we go. As you can see, it returns a unit here. Now, let's say for whatever reason, we wanted to return a string though. And so you'll see here, as soon as I did that, I've got a squiggly line here. Now what that's saying is we haven't returned any string here. So let's say I want to return something. So let's say hello, let's just return the word hello world. So instead of printing it, let's just return it here. And it's going to return the value hello world. And then when we print it to the screen, we could say hello world, and it did go ahead and print to the screen, because what happened here is the say hi function is now returning hello world. We're going to stuff that value into this variable x, and then we're going to print the variable x to the screen with the println statement. So now something interesting happens. You may be thinking, well, let's just call say hi a few times here, and let's see what happens. And if I run this, you'll notice that we're just going to get on the screen hello world one time. And the reason why we're only getting hello world to the screen one time is because, remember, say hi is returning something. It's returning a string. So it's not doing anything in here but saying, hey, I'm going to have this value and I'm going to return hello world. And then at that point, you can do whatever you want with it. And in that case, we are just assigning it to a variable x and printing it to the screen. Now, these last three aren't doing anything. It's calling this and it's returning hello world, but we're not doing anything with the result. So if I did val y equals this, and I did val x, actually already have x, then we do z equals this, and val a equals this. Those variables would then be set, and I could actually print them to the screen as well. So we'll change these from y to z to a. And if we were to run this again, you're going to see that all the values are running and printed to the screen. So hello world, hello world, hello world. Because we have to actually do something with those return values. Now, if I get rid of this right here, we're going to see that we have an error on the screen simply because those variables have not been declared. So that's just not going to work. It won't even compile. So this is a return type. If we want to change the return type to something else, we can say int. So it's going to return int. And by default, this will not work. It'll say, hey, there's a problem here. And so I can return the value of 32 or something like that. And if we run this again, we can then execute it. Now, of course, because this is a function, we can say something, we could put some if statements inside of here or whatever we wanted to, even if we wanted to return this as a string. But we only had a integer in here. I could say .toString. And that would then print 32 as a string to the screen. So now whatever your return types are, which could be any of the built-in types that you've already learned, could be here. So it could be a Boolean value. It could be a long. It could be a double. It can be any float, whatever you're working with at that point in time. You'll need to return that. So in this case, it'd say return true, and it would return that value. So you need to return whatever the value is. And of course, as we know, if we don't return anything at all, it's going to return a unit, which even if the function does nothing whatsoever, it's still going to return a unit, which then we print to the screen here. Functions inside of Kotlin are first class. So if we have a function that says say hi, we might have something that says look like this. And inside of here, we might say hello. And if we were to call this function, of course, we just call it in the main function, and it's just going to print hello to the screen. However, one of the other cool things that you can also do inside of Kotlin with functions, since they are first-class citizens and technically objects, which we will get to, is you can create another function inside of another function. So we could say by, and that would look something like this. So now I'm creating a function inside of another function. And this one's just going to be by. Now, if I want to call this function, if I go up here and I try to say by, you'll notice I can't call this up here because this function is not found. It's because the scope of this function is within say hi. So the only place I can call say by is within the say hi function. So this won't work. So if I want to call it, I can come in here and call it. But if I try it right here, you'll notice again, it's red, which means it can't be found. And the reason why Kotlin can't find it is because it has not been declared yet. So by the time the code gets here, you'll have no idea what say by means because it's been declared below. So we can go underneath the function and call it. And so say by. And if we were to run this now, what we would see is say hi and then bye. If we run it, we would see hello and bye. Now, of course, we should probably rename this to something else, to say hi and bye. And that was a simple rename, which is done with a shortcut key, or you could just do refactor rename. So I used Shift F6 here on a Mac. So Shift F6 gave me the highlight to change it. So say hi and bye, and it will say hello, and then it will say goodbye or just bye. And then that function inside of there had a function. You can also put another function inside of something in here. So you could say moo like a cow. It would say println, and this could say moo. Now, of course, I need to call moo after I've declared it. So at this point, I'm going to call say hi and bye, which will then print hello. This function will be declared. Then we'll call say bye, which then we'll hop into here. It'll say bye. We'll declare moo. Then moo will be called, which will print inside of here. So all different kinds of stuff happening. We're going here to here to here, kind of jumping around all over. And if we were to run this again, we're going to see hello, bye, moo, as we see on the output here. Now there are, again, functions inside of functions. This can get really squirrely looking and look real nasty after a period of time. So I advise that you be very careful with declaring functions inside of functions and make sure that's the proper right thing to do, because it can make the code very hard to read. So unless you have a really good idea for making a function inside of a function, then you might want to steer clear of it until you have a good grasp on when you might want to do it, which there are various different implementations that are beyond the scope of this video. Functions in Kotlin typically look something like this. In this function called say hi, what we'll actually have is a print line statement that says hi. And so if I were to call this from the main function, we're going to go ahead and see hi printed down here to the output screen. It says hi. Now, unfortunately, with a lot of languages, this bracket and this bracket is kind of verbose for just this simple statement. Now, of course, this function could have multiple different things in here, but let's just assume it did one thing for now. So Kotlin actually has a concept known as a single expression function. So we could do this here, say hi, is equivalent to what we had before. What this means is I have a function, its name is say hi, it doesn't have any parameters, and its body of the function is equivalent to this stuff over here, which is on the right-hand side of the equals sign. So inside of the body of the function is just going to be print line. So if I run this, we'll see the same exact thing here. So we can actually see hi. Since Kotlin supports functions inside of functions, because functions are actually objects, we can actually declare a function inside of another function, which you could decide to do or not. And we'd say do work. Let's say we had a variable here called age equals 32. And then it said if age is less than 32, less than 21, we would go ahead and print out that the whatever person or whoever is less than 21. And otherwise, they are, say, eligible for whatever reason. Maybe you have some reason someone has to be over 21. Okay, so now if we were to call do work, if I were to try to, of course, type it here, do work has not been declared yet, so I can't call it. So I'm going to call it from down here. And if I run this, we're going to see say hi, and then we'll see eligible, because the person is eligible. Let's set this to 12 and run it. And you're going to see that it says less than 21. Now we can also perform, this is kind of, multi-line statement, but since we can use single line if statements, we can also turn this into a single line expression. So what I'm going to do is I'm going to get rid of these brackets here, basically all of them. And what we'll do is kind of line this stuff up here and turn this into a single line expression. And so again, the age is 12. If it's less than 21, it'll print line here, else it'll print this other thing. If we run it, we can actually see less than 21. And of course, if I change this to 32, run it again, you'll see that the output is eligible, which is the other part of the statement here. So you can clean up a lot of your code by using single line expressions. There is a heuristic that you should follow though. Let's close this window over here. And you'll notice the right-hand margin with this little gray line here. If you find your code approaching this over here, so let's just go ahead and type eligible a couple of times. If for whatever reason eligible, you typed a bunch of stuff here, goes beyond the right margin, it's usually advisable that you turn this, instead of this, into an old-fashioned multi-line function, just so that it's more readable. So here you'd want to go ahead and, of course, add your brackets, and you'd kind of do this thing right here. And as we've kind of seen before, and we'll put this down here. Oops. We'll clean this up a little bit. So there we go. So now if the age is less than 21, we're going to print line. Otherwise, we're going to print eligible. Again, now the reason is because it's the right-hand margin. It's just a common coding practice. If your code goes beyond that right-hand margin, you should figure out a way to break it into a new line. And usually if you're using a single line expression, you'll want to go ahead, and that's usually an indicator that you should probably use a regular function body instead of a single line expression. Functions in Kotlin without any parameters are going to look just like this with an open and closed parentheses. So the parameters are going to be in between the parentheses here, and there are no parameters here. So if we were to call do work, of course, nothing would happen. We could say print the line, work is happening. And then if we were to run it, of course, we'll do that. Now, a parameter is something that we can pass into a function to do work with it. We can perform some type of value. So what I would like to do maybe is I would like to provide some type of value here. I want to type in the value of 32 into this function. So what I'll do is take the value 32 and say, hey, do work. You need to do something with this 32 value. But in order to do that, I need to provide a parameter inside of the function declaration. And so to do that, what I'm going to do is type the word age and its type. So here, age is going to be an integer, and its value up here is going to be 32. So now what I can do is I can say age is, and of course I'm going to use string interpolation here and say age is age, and whatever it is, or let's just do it so it reads a little better. You are blank. And so it'd say you are 32 in this case. So if I were to run this, we would see that do work function says you are 32, which is great. Now, if I call this function with another value, let's say 12, we're going to see two different values returned here. You are 32 and you are 12. So what the parameter allows you to do is allows you to pass in values to your function. So you say you are 32. Now, I could also provide other additional values here. So I could put name, and I could say it's going to be a string. So I need to provide the variable argument name and the argument type, which is string for both of them. So again, this is the argument name, argument type, comma. So I need another one in there. Argument name, argument type. Now you'll see that we have a red squiggly up here. That is because IntelliJ says, hey, you're missing a additional value. So I'm going to type in Dawn, and instead of saying, I could say string interpolation again, name, comma, and we'll have proper punctuation here, period. And if we hit run here, what we'll see is 32, and Dawn, it says, Dawn, you are 32. Now, if I were to change this around, I could say something else like 12, and I could put Jonas, and Jonas might be 12 for whatever reason. And if we print that out here, well, I'll have your 12. Now, the cool thing you can do with this thing inside of the do work function is now you can start working with these values inside here. So maybe you might have an if statement. If the age is less than 21, you might want to say something different, like you want to cut this out here, and we'll say the name, you are not old enough. Now, for whatever reason, perhaps you have some logic that states that for someone to use this application, they have to be over the age of 21 for whatever reason. And we want to put, you're not old enough, you are blank, let's say age. Let's just say, Don, you are, say, far too old at the ripe age of, and then we'll put the age in here. And so now as I run this, we'll get two different values that we're working with here. So we'll see the first one is Don, and then the next one is Jonas. So Don, far too old at the ripe age of 32. Jonas, you are not old enough. You are 12. And so I can continue down this road here. Now, if I wanted to start having, if I call this function all over the place, let's say I have a 71-year-old and her name is Evelyn, and Evelyn's using the app too, and she types in her age and we run it. We'll see now that Evelyn also has an entry. Evelyn, far too old at the ripe age of 71. Sorry, Evelyn, if you're really not 71. So we can actually start providing various different values in here. They can be any different types here. You can provide one that's a Boolean value. So you could say is happy, and you could type in a Boolean value. And of course, because everybody's happy, we'll just put true here. And we'll say true. And you see IntelliJ is giving us some nice little hints here of what the actual, this is not something I typed here, is happy or age or name. That's IntelliJ saying, hey, by the way, the name of this parameter is happy. And then we'll put true here because, hey, Evelyn, everybody's happy. And then we can hit run. And then of course, we're going to run it again. Don, you are far too old, age right 32. You notice, hey, we didn't do anything with that value. So we might need to do something with it, which says you are happy. And then we could put something like this. We could actually put some other type of code in here. We'd say boom is happy. And then we'll run it again. And of course, now we're going to see each one of them for Don, Jonas, and Evelyn. You are happy, true. You are happy, true. You are happy, true. If for some reason today I was not happy, maybe I stubbed my toe, and I were to run it again, we would see that Don is not happy because he stubbed his toe. Jonas and Evelyn, though, are still happy, and so forth. So this is how we can start adding in various different parameters. Again, if you need another one, you're going to put a comma in here and you're going to add another one. So we could say foo is going to be of type long. For whatever reason, you may need some different types here. And of course, IntelliJ is going to say, hey, that's not going to work because you need to provide that value up top. So this is how you provide arguments to a function. Let's assume we have a function called print user info. It takes a bunch of arguments such as the first name, last name, age, if the user is sunburned, if they like movies, and if they love popcorn. And if you would like to do something with this, and perhaps we just want to print it to the screen, we could provide some implementation that looks like this, that uses string literals and prints it to the screen. Fair enough. Now, if we want to call it, we are going to call it like this. We'll say print user info, and then we have to start providing all of the information, such as Don Felker, and then we have to provide the age, and then we say, is he sunburned? No, he's not sunburned. He loves movies or likes movies. True. And he loves popcorn. Of course, why not? So this now, fairly simple. We've covered this before, but now we have these nice little IDE hints in here that say, hey, this is what this argument is. It's sunburn. Now this works great, except until it goes outside of the IDE, because IntelliJ and other IDEs that are from IntelliJ and JetBrains do this for us. But once we get online or into another IDE, we don't get the same feature. So let's hop over into another IDE. Okay, we're inside of Visual Studio Code. I'm going to paste the code in here, and you'll notice that we don't get those nice little previews like we see over here. So we have first name, last name, age, sunburned, etc. If we go back to Visual Studio Code, we don't have those values over here. That's a feature of the IntelliJ IDE. So at this point, when we're reading this code, and this will be the case if you're doing a pull request or viewing the source code online through a web browser, you're not going to understand what this false even means, especially a couple months down the road. You're not going to understand what true means. True here, we have no idea what print user info is, and most likely this method is somewhere, perhaps in another file, perhaps further down where I can't see it unless I scroll for it and find it. And it just makes it more difficult, and I have to do a lot of context switching to find it. Now, the interesting thing here is that we can fix this inside of Kotlin. We're going to go back to IntelliJ, and what we can do is actually provide the name parameters here. So I'm going to type first name. So this is what is known as a named parameter. I'm using the name of the parameter, and at the call site, I'm actually providing the name here. So is sunburned, that was false. And then we could say it likes movies, true, and loves popcorn is true. Now, I'm going to copy and paste this code again, go back to Visual Studio Code, delete this code here and paste it. You'll see we actually get those name parameters over. By default, Kotlin will still compile this code. So back inside of IntelliJ, it will still compile this code right here. And if we were to run it, we would see this says Don Felker is of age 32, sunburned, false, likes movies, true, loves popcorn, true. So these things all run, and which is really nice. Now, the other great thing about named parameters is they're also positional based. So let's get rid of this one down here just so you can see what I'm talking about. We get a little squiggly here. It says mixing named and positioned arguments is not allowed, meaning that we're using a positional based argument right now. This is a positional based argument. It's the last one here in the list of arguments. I could also undo this and say, hey, let's get rid of the age one here. And I'd get the same thing here. I'd say, hey, this is basically the third item in the argument list. Kotlin says, I don't know what you're trying to do. You want to use name parameters, but now you're using one that's positional based. Decide what you want to do, but it won't compile. So if you're going to use one named, you need to provide the name for all of them, which is much more readable. Now, because we're using name parameters, I can actually move these around, which is very cool. So the print user info method takes the first name, last name, age. Those are the parameter order. So in traditional languages that you're used to working with otherwise, you always have to provide the values in that order. However, with Kotlin, you can provide a named argument. So it says, hey, age is 32. Kotlin will know to map this value here over into this age parameter. Now, if I want to move is sunburned up maybe a little bit closer because for whatever reason in my program, it makes more sense, I can do that here. And Kotlin will know to map this parameter value, which is second in the list in the positional sense, map it over here because we're using the actual named parameter. So we're using the name parameter to map it over. And that's how you can use name parameters in Kotlin. In Kotlin, there's a concept known as a default argument. Now, every time I call this print user function, so let's say I had to call it a few times, I have to change this from every time, of course, these values are going to change to some other types of thing. And it's going to say 31 and 37 and 12 and all these different types of things. And this person is sunburned, etc. But perhaps the majority of the time, I always know that these people are not sunburned. And maybe because these people are my family, they like movies and I know that they love popcorn. But having to repeat these things many times is troublesome. So we can actually use the power of default arguments. And to do so, we can specify a default value for an argument. So let's say the user loves popcorn. So we're going to set it to true here. Now, if loves popcorn is not provided, we can actually remove it from this call site. It will just default to true. So I can actually remove it from these other ones as well. And I can provide a default argument for maybe likes movies. And we're going to default that to true because everybody should like movies, I think. And then again, I can remove this from the call site. And because I'm removing it, the default value of likes movies is going to be true. And of course, it's not often that everyone is sunburned, so let's go ahead and set this to false. And it's pretty easy to do, so I'll say false. Now we can go ahead and remove this from here. Now this cleans up the call site of these three functions quite a bit. We can actually see the only relevant information that is changed in each print user info function. And if we were to run these here, let's run it. You're going to see it's printed 3 times and we see sunburned false, likes movies true, loves popcorn true. Now, if for some reason that I know that this time, perhaps I've just eaten a lot of popcorn and I'm just not really fond of it lately. I'm just going to say loves popcorn false. And maybe I know that Bob this week is sunburned because he just got back from the beach here over in New Jersey on the Jersey Shore. And perhaps Sarah, for whatever reason, just does not like movies. And we're going to put false there. So actually, Bob is sunburned. So make that true. So now what will happen is when we call the print user function, all these values are set. Now, loves popcorn, which is traditionally true, is going to be set to false for this function call. For the next function call, print user info, it's going to be true because I haven't provided it up here because it's using the default value. However, I'm saying, hey, is sunburned. This time, don't use the false value, use true because Bob is actually sunburned. And then finally, we have the print user function down here at the bottom for Sarah. And she actually doesn't like movies, so we're not going to default it to true. We're going to set it to false. And if we run this again, we're going to see that these values actually render correctly here. So Don loves popcorn is false. Okay. The Bob Felker here is sunburned, true, and Sarah Felker likes movies, false. So these are all of your default values that you can have inside of Kotlin. Now, if there is a string, for example, we could say that a string, let's make a string here at the end. We'll say favorite color, and it could be a string, and we'll just say that it's going to be blue. And if you provide that favorite color, then Up here, you can override it. Otherwise, it will just default to blue. So you can do any of these things. If it's could be a built-in primitive type, could be a class, anything like that, you can set it to a default value. Now, traditionally, the default arguments are usually placed at the end of the method call. Now, this is not a steadfast rule. You can actually place them in the middle. So if you would like to say, well, the last name is actually supposed to be defaulting to Smith because we are working with the Smith family, but for whatever reason, we realized we gave Sarah the wrong last name. Now, if we were to run that again, we could run it and we'd see Bob Felker, Don Felker, and Sarah Smith here. So we've used a default argument right inside of the middle of the call site here. So right in the middle of the definition of the method. Now, but age has not been specified, so you do need to provide that. So if we do leave off age, we're going to get an error here. And we'll see that no value passed for a parameter age. And because we're using named values, I can do that up here. Say, oh, age is 32. And I can move these around anywhere that I would like because we are using the name parameters. And that's how you can use default arguments, parameters inside of Kotlin. A common pattern in Kotlin is once your column length for your code exceeds the right-hand margin length, which is this right-hand line, it's common to start placing values on the next line, such as we're doing here. It makes it much more easy to read. Now, this can get quite old pretty fast and can become very slow and error prone. Now, thankfully, if you're using an IDE such as IntelliJ, Android Studio, or anything like that, this is built into the platform. So put your cursor on the left-hand side of the open parenthesis, hit Alt and Enter, and then you can say put arguments on separate lines. And now it'll put it on separate lines, which is great. So it saves you a lot of time really quickly. So anytime you want to do that, you can use that little shortcut. Now, we do get these nice names here that are built in from the platform. Again, this is the IDE giving us these names. So if we copy these into another IDE such as Visual Studio Code, we don't get those values back. So how do we add those named values, those those argument names? You can go back to IntelliJ, Android Studio, whatever, and start adding them by hand. Again, this is going to take a lot of time if you're doing this over and over and over. Thankfully, again, place your cursor on the left-hand side of the open parenthesis and select the Add Names to Call Arguments. And boom, all of a sudden, you have now cleaned up your code by placing each of the arguments on a separate line, making it much more readable, as well as adding the names of the arguments to each of the parameters, which makes it even more readable and saves you time at the end of the day. Let's assume you have a function called print_book_info that prints the title of a book and the author. Here we have green eggs and ham, and if we were to run it, we would see that it's just going to print green eggs and ham, and the author is Dr. Seuss. Now, however, if we had the instance where we knew that we needed to have an additional author, because sometimes books have co-authors, we would have to maybe create an overload of this function. And we'd say this would be author 2. So we'd have author and author 2, and then perhaps we might change it to say authors, and then we'd have another comma with another string interpolation here, and we'd put author 2. Now, if the book has 3 authors, we'd have to create another function, and 4, and 5, and 6, and you can see where this is going. So thankfully, Kotlin has a way for us to do that without having to write extra code, really. And so what we can do is take this last parameter and turn this into a var arg, and that's the keyword var arg, which means variable argument. And then I'm just going to change this to authors, which means that this value could take 0 to many values. So there could be many authors here. And since this is going to be an array, if we were to print this now, let's go ahead and just add another person in here. Say maybe I was the co-author, which we know I'm not, but this is hypothetical. We'll run this here, and you can see that we actually have an open bracket, and it's starting to print the information. This is now an array, and so this is printing the information about the array. If we actually want to print the contents of the array, we're going to hop into a little bit of an advanced concept here, and we'll use a lambda expression, and we'll print it to the screen, and it is the key word, so we print line. And if we were to run it now, we would see also this array value here, which we could get rid of and clean it up a little bit and run it again, and you would see that we have green eggs and ham, and the author, which should say authors, would be Dr. Seuss and Don Felker, as it's now rendering here. Now we could also take this and add additional ones. So if we had Jane Doe, and we had John Doe, and we had all kinds of other ones, we could keep adding them in there. Now the other cool thing is too, we could also have the situation where for whatever reason, this book just doesn't have an author and it's unknown. We could run this as well, and we would see that there's no values returned. So if you need to have a function that takes in multiple inputs of a particular type, you'll want to make sure that the var arg is the last argument in the function. Slap on the var arg keyword, and then you can pass multiple values in. So such as we're doing here. So it's like X, Y, and Z, and then all these values would then be stuffed into this authors array, and you could loop over it using either a lambda expression or any other array manipulation or iteration techniques. Let's assume we had a function called print user info, and it just printed a name. So very simple. We're just going to take the name and print it, and it says name Don Felker. Now, let's say for whatever reason, I also need to have it take, sometimes it only needs the name, sometimes it only needs the age. So I'll say, you know what, I actually kind of needed another print user info function, and this one's going to have age, and this one is going to be int. And so this time I can actually say, all right, well, I'm going to call this new one. It's going to be a new user, and this one's called Jane Doe, and I'm going to make her age 37. So now this one, print user info, is going to, if we go to the definition of it, it's going to go to this function, and this one is going to go to this function. This is called function overloading. We're overloading the term print user info. So it has has the same name, but it's taking different arguments here. Now, if I were to remove this argument, you'd see we get some errors here because we have the exact same definition here. This is the exact same function name and function parameters right here that are right here, and that's going to be a problem. So because we have a different parameter here, age, it's now considered a different signature to Kotlin and say, all right, well, you can overload that function. And then of course, we're probably going to have some information in here that's a little bit different. Now, again, we could say, well, now I also want their favorite color to be inside of here. So I'd say, favorite color, and that might just be a string for simplicity. Now I have 3 overloads. So what we could do here is I say print user info. And you see I have 3 different options. So one takes a string, one takes an integer, string and an integer, and one takes string, integer, and favorite color. And so, of course, then we'd want to change this. So it said favorite color, and this would say, using string interpolation again, their favorite color. So then I could print this user info, and I would say Frank Bendo, and we would say that his age is 22 and his favorite color is purple. And at that point in time, if we were to run these, each one of these are going to run a different function. So the top one's going to run the top one here, the second one's going to run this one here, and the third one's going to run this one here. Now, if you're already familiar with Kotlin and also its named parameters and its default values, well, then I'm sure you can already imagine that, well, we could actually kind of clean this up a little bit. And to clean this up, you could actually kind of get rid of this and say, hey, you know what? Well, age is going to be an integer. And if they don't provide it, I want it to default to 0. And a favorite color is going to be a string, of course. And if they don't provide it, we'll default to purple. And so we'll do that. Actually, no, we can actually default it to an empty string if we would like. And then what it allows us to do is get rid of this. See how we have this here? It says, hey, there's a conflicting overload because we have this up here with the same values. Now, if I get rid of this, all these still work because we're using the named parameters. Now, of course, I would want to say age like this and fav color. So we could actually render the stuff and it would be there. So if I don't provide a favorite color, it's just going to be blank. If I don't provide an age, it'll be 0. And now I've kind of cleaned it up, and I still have this function overload options here, which I could say print user info. And then it's going to give me the option of, hey, do I want to use the default values? And that's how you can overload a function in Kotlin. In Kotlin, you can create a class by using the class keyword and give it a name, such as user. And we'll do open and close parentheses. Now, if you're not familiar with what a class is a reusable template. So we could actually have various different variables here. So I say variable user equals user, and then I could have another one. So var friend equals user, and they're now their own different instances. So friend is a user, and this user object is a user. They're 2 different instances stored in memory. Now, this class, this template per se, is not doing anything. It doesn't do anything for us right now. So what we can do is actually define a couple of fields here. So we'll say a couple of properties. We'll say field, call this one first name, and this one's going to be a string. We'll just initialize it to an empty string. Var last name, And we'll go ahead and initialize this one as well to a empty string. And now we have first name and last name. So if on the user I would like to set that, I can say user dot, and that will allow me to access the two properties, last name and first name. So I'll set the first name to Dawn and the user dot last name to Felker. Now let's say we have another user. Let's say it's friend, of course. This one also has a first and last name. We'll set the first name here to Jane and the friend dot last name equal to Doe. So we have two different instances. Just because I've set the last name Doe here does not mean it overwrites here. These are two different things in memory. Now a class again has it's a kind of a template, so you can it can provide functionality as well. So we can actually put functions inside of this user class that are scoped to the user class. So what I might want to say is print full name, and then it'll just be a regular function, and it's not going to do anything, but it will print line to the screen or to the output, which would be the first name and the last name. We can have another one in here that says print with a prefix, which then would maybe take in a prefix of some sort, and we could just call that prefix, and that would be a string. And then when we call this function, we can do the same thing here. We would just say prefix, and then we have perhaps a last name. Now, the way we would use this is up here, we might just call user.print full name. And if we go down here and do the same thing with friend dot print full name, we'll actually hit two different pieces of output. So let's run this real quick. And what's going to happen is we'll have two things printed to the screen. One is Don Felker, and that's called by the print full name function here. The next one is Jane Doe, and that's called from the print full name function as well here. Again, they're two different instances. The contents of the objects, which are basically instances of the class, are being printed to the screen with the print line function. Now we do have the print with prefix, so we'll get to that in a second, but let's also do something different here. So let's say we have a function called update name, and this update name takes in a new name, and it's a string. And what this is going to do is actually update their first name. And so we'll say first name, and we're going to set that to new name. And then what we'll have here is a way to update their name. So let's come back up here and say, you know what, maybe I messed up. I want to update their name, and this is hypothetical, and we'll call this one Bob. And then at the same time, I'd like to user.print full name. And so if we run this again, what we'll see here is that the first object is Don Felker. Then we update the update name function, which goes down here, sets the name to the new name. And then we call print full name again. That says Bob Felker. And then we go into the next user, and this following the line sequentially, procedurally, we see Jane Doe here. Now the same thing we can do, we can say user.print with prefix, and maybe I'll say Mr. And then in this one, I might actually say friend.print with prefix, and this one might be Miss. And if we are to run this now, what we're going to see is, of course, Don Felker, Bob Felker, and then we'll say Mr. Felker. And then we'll see Jane Doe and Miss Doe here, because we're actually just printing with the values in here. So now this class is basically a template that we can use inside of our application. Now everything is stored inside the same file here. Now what you can do is you don't have to have this in the same file at all. So what we can do is I'm going to open up the project window over here, and you see we just have our main file. What I can actually do is create a file manually. I can say new Kotlin. I can say user.kt. And then what I can do is I can come over here and I can cut and paste this code into user.kt. If we go back to the main, you're going to see that everything still works because we're in the same package. So it knows that it's going to look in the same package, and it found the user class. Now this allows us to start cleaning up the code a lot, because now I basically have a template called the user class here in a different file to do that for me. Now, what I'm going to do actually is I'm going to undo this. I'm going to go back to main here. I'm going to undo this as well, and come here and get rid of that Kotlin class. So we're going to go back to how we were before. There's actually a shortcut that you can use. When you put your cursor over the class name here, you'll see this little bulb. You can click on it, and you can say create test, rename the file, or you can say move user to a separate file. Say, yeah, I'd like to do that. So right out of the box, by default, we were given this nice little thing that allows us to create a file. And what that did is it created the file for us and moved all the contents of that user class over there for us. So let's go a little bit further here and make one more method. And this method might print the length of the first name. So we say function first name length. And what we do is we're just going to print something to the screen. And then what we're going to do here is we'll just take the first name and say first name dot length. And that's going to print the length of the first name. So if we, again, this is kind of like a template. It's a class. Go back to main KT and let's print the length of the friend's first name. Friend dot print, length, first name length. There we go. And if we run this now, Kotlin will find the user class, include it here for us. So we're running with that user class. Run the existing code, which we've seen already, Mr. Felker, Bob Felker, etc. And then we're going to call the friend.first name length, and it's going to return 4 because that's the number of characters in the first name, which is Jane. Now, so this is a very simple class, but this is how you can create a class here in Kotlin. Let's assume that I have a class called user with first and last name and a couple of functions inside of it. If I'd like to use a constructor, what I can actually do is use the keyword constructor. Now, I can actually bring these properties into the constructor. So let's actually get rid of these. And I actually say first name. And I can say this is a string. And last name, this is a string. Now, usually you want to default everything to vowels because it's going to help you with immutability and help you not make as many mistakes. But we can try that here, but we notice that there's actually a problem here. So we have the update name method actually updates the first name. And if it's a vowel, we can't do that. So let's just change these to vars. So they're properties that can be mutated, which means they can be changed. So now we have a constructor for our user class, which takes in the first name and last name. And if we go back to our main file, we're actually using it, you can actually see a couple of things here. First, we have in the user class, you can actually see when we type user, open close parenthesis, we have a string for a first name and a last name as well. So we can put Don and Felker. And so I can, now if I would like to rewrite these, I could easily do that with this properties right here on line 6 and 7. I can change these to perhaps it should have been Jason Smith. I can reset those here. So I can actually change those, or I can actually just get rid of them because I don't need them anymore. And then here I'd actually do Jane. We'll change this to Doe. I can get rid of the property setting here. And if I were to run this again, you'll notice that we're going to get the same result that we got before. This time we've just used a constructor with the parameters and properties inside of here. So these parameters are turned into properties, which are you can use inside of your class. So you can see that down here. Now you can also, as you can probably imagine, put your cursor here and you can add the names to the call argument. So you can actually see that that's actually the first name and that's actually the last name. So you can actually see what these values are as you pass them in. Furthermore, in the user class, if the constructor does not have any modifiers on it, such as the internal keyword, which we'll cover later, you can actually, so if it doesn't have any of these annotations or modifiers, you can actually get rid of the constructor word, and this will be the primary constructor. So now we've actually cleaned up the code a little bit more. We have the user class, which takes in a first name and a last name. So we can see that here. We have first name, last name. Works just fine. We don't have to have the constructor keyword on there, though if you could still use it if you'd like to, but it's very common if you have a primary constructor and that's it, you just remove the constructor word. Now, if you wanted to have perhaps this to only be for internal and you want to have constructor and you tried to get rid of the constructor word, you would see that this is not going to work. Use constructor keyword after any modifiers of a primary constructor. So we need to put constructor here if we were to restrict the visibility of the user class's constructor. But we're not doing that here, so this is a basic class with a primary constructor. One of the additional things you can do inside of a constructor is also set default values. So we could set this to be a blank string, and perhaps we knew we were always going to be working with the Smith family for whatever reason. We could just say this is Smith. And so if I'd like to, back inside of our main file, I could actually get rid of the last name if I didn't want that there. If I wanted to override it here to be Doe, I could do that. And so now this is just going to say Don Smith and Mr. Smith and Jane Doe and Miss Doe, because we're using the default values inside of this primary constructor. A class can have more than one constructor. This is a primary constructor up top here. we can also have a secondary constructor. To create a secondary constructor, use the constructor keyword, and then you want to pass in some additional values. But first, let's get that set up. Let's assume that this user can be of a particular type. And so we'll say is platinum. And this would be perhaps a platinum user for a particular, you could say it's a financial institution. And so we want to create another constructor. So sometimes we want to be able to provide, instead of the first name and the last name, we already know by default they're not platinum. So what we can do is we can call this constructor here. Now, this constructor will take the first and last name, but then what we need to do is call into the original version. So we're going to say the first name, I'm going to pass it in. So this first name value is coming from here, and then the last name. And then we'll say is platinum, we can say false. Now what you're going to see here is we no longer have any red squigglies. What this means is I can use this new constructor. Now I don't have to provide a body for this here, but if I would like to, I can also provide a body. Maybe I want to do something in here like print line. I could say is platinum is false by default. So if I use this one, if I use this constructor, this line of code will get run. So let's go back to our example and let's change this one here. So by default, both of these are going to call into this here. Now, of course, we have not provided a last name, so let's provide a last name here. And it's going to be Felker. And then we'll say is platinum is true. Now I'm a platinum user, but this user down here is not a platinum user. So now if we were to run this, on the second call down here, we're going to see is platinum is false by default. That's because when we go here, I go to the implementation, it's using this secondary constructor. Now we can even go even further and say if we want another constructor, so multiple constructors, you can keep going here. So I might say first name, and then I might just skip that and say, all right, this, which means, hey, call another one of these instructors. And this one is going to call in first name, and this time I don't know what the last name is going to do. So I'm going to call unknown. And perhaps just for completion's sake, we'll say, hey, in the third constructor. Now if I go back to the screen here, and let's go ahead and create another one. var, let's say it's your cousin, and we'll say it's a user, and we'll say first name is, Nick. And then what we'll say, we're not going to do anything here because if we look at this implementation, it's using the third constructor here, which is going to say, hey, I'm in the third constructor. But look, something else is going to happen. And what's going to happen is when this third constructor is called, the word Nick is going to be put into the first name, and then it's going to call into this. It's going to pass this first name value into this, and it's going to give an unknown last name. Now, this is actually going to call this constructor, which is going to say, boom, all right, now it's unknown, and then it's going to print is platinum by default. So let's actually see that run, and then all the values, of course, are then passed into the root constructor here, and then we can actually see everything. So if we run this now, what you'll notice is something interesting is going to happen here. Now, there's a lot of stuff going on here, so let's clean this up a bit. So let's go ahead and just kind of get rid of all this stuff here. We just want to see when one of the constructors is called, and so we have those methods inside of there that's going to call print line when a constructor is called. So if we run it now, we'll see is platinum is false by default. And we see the same thing again, and then I'm in a third constructor. So if we were to go to this first one here, this first one uses the primary constructor. Nothing happens here. We just set up an object, and that's the end. The second one uses a constructor here that uses the first name and the last name, and then defaults the platinum field to false, and it says is platinum is false by default. Now the third one is interesting, because the third one we say, hey, the first name is Nick, and then it calls into the other constructor here, so it's, hey, the first name is Nick, last name is unknown, and then what happens is this constructor will call into the root constructor. So it's going to go, this executes first, this line, then this line is going to execute, which calls in up to the primary constructor. After that is complete, which is this line here, which calls the primary constructor up here, then it will procedurally call this one, and then now that this whole method is done running, which is right here, then it will run this. So what we're seeing here is this is being called first because, again, this gets called, which goes into here. Nothing happens up here. That's complete. Then it runs this, whatever's in this constructor. which is this call here. It says, okay, that's done now. Now run finally what's in your constructor. And so these three things are happening. So if we really want to make it simple, let's go ahead and say, so third, just to really make it kind of obvious, second, and there we go. I'm going to go back and we're going to just comment out this one. And what that'll do is we're just going to run this one here and we see second, then third. So first thing that happened is it printed second because it hit this constructor first from kind of walking this call chain. And then it went to the third one. Now we could actually get around this here and say, hey, this one here, we'll just say is platinum is false. And we could even say true if we want to, doesn't really matter. But let's just leave it false for, let's do it true actually. So if we call this and we pass in a first name, we'll give it an unknown last name and they're a platinum user. Now when we run this, you're just going to see third being printed to the screen because it's only calling the third instructor, because by default, what happens is this constructor will be instantiated. In turn, it takes its first name value and calls the primary constructor. So this right here is the primary constructor because it has 3 parameters. If we then took this, this one out, last one, it's now going to call the second constructor. So let's assume this wasn't here. So let's comment it out. That's not going to run. Now you'll see that we don't have a constructor that matches this signature, which is a string and another string. We have a constructor with 2 strings and a Boolean. So that's why we're seeing multiple different versions here. And again, if we can come in here, this time we run it, we're going to see second and then third. Now you can have multiple different constructors inside of here. So you can keep creating different types of constructors. You could set them to platinum, etc. Now, of course, some of these things may not even need to happen. So we can say, hey, perhaps we don't even need this. We can use some default parameters here as well. So if the last name is not known, let's use unknown. And then if it's, by default, we're going to set this to false. So now if I come back here, I can still do this exact same thing. Even this would work. And it's still going to work because it's using default parameters and the named arguments, the default argument values. And so then we can see everything, how it should be. So each of the objects is going to be created. Memory is going to be allocated, etc. And then we kind of get all that safety right here and the various different constructors. However, if you do need different constructors for whatever reason, or you need to perform some type of different values, you can call different functions, do different, run all different types of code in here and run different code in here, you can do that. Just provide a different constructor using the constructor keyword and you're off to the races. Now, additionally, you can also restrict some of the constructors using modifiers such as protected, or you could call internal, etc. So you can actually lock down who can call into a constructor based upon a modifier. We have a user class, and inside of a user class, you can also have what are known as initializer blocks. And these initializer blocks are created with the init keyword and an open and close curly brace. So this would be perhaps somewhere where you could perform some type of initialization for your class. Initializer blocks are called after the primary constructor has been invoked. So again, this is the primary constructor up here. So after the primary constructor has been invoked, the initializer block will be called. So something interesting that we can do is we can just go back to our main file here and we'll create an instance of our user class. And then we'll just say Don Felker here for the first and the last name. And we're going to run it. Now we're not putting it into the screen here, but notice how we do see hello1 is output down here in the run window. The reason for that is because in the user class inside the initializer block, I'm printing out hello1. Now there's also something interesting you can do with initializer blocks as well. You can have multiple initializer blocks, and this initializer blocks will then operate in the order in which they are defined within the class. So what will happen is the primary constructor will be called, first and last name, and then we'll get hello1 called and then hello2. So if we go back and rerun this here, what we're going to see instead of hello1, we'll see hello1 and hello2 as we see down here. If we go back to the user class just to demonstrate this and we move this below hello2 and we rerun this, what we'll then notice is we'll see hello2 show up before hello1. Now, one last thing here too, just to demonstrate that the initializer blocks are called right after the primary constructor. Let's go ahead and create another constructor that just perhaps provides the first name, which is a string. and then it's just going to default the last name for us. So we're going to call into this, pass in the first name, and then the last name will just default to Felker here. And if I go back to this here, I'll get rid of my last name, which will then use that second constructor here, which we can see here. Now what's going to happen is we can actually provide a block here so we can do something after this constructor is called. So let's do that here. Say constructor, second constructor call. So we'll say here. So our expected output at this time when we create a new class, you might think would be, okay, we're going to call the second constructor called. And then of course it's going to be the primary constructor, and then we'll get basically hello 1 and hello 2 because that's the order they show up in. However, what you'll notice if we run this, that's not the case. And as you can see here, it's actually a little backwards. We have hello 1, hello 2, and then second constructor called. So it seems kind of backwards, but when you think about the execution of the actual class, this here is called immediately. So as soon as this constructor is called, immediately those values are passed into the primary constructor. And then after the primary constructor is called, the initializer blocks are then called. After those are called, then execution will return to inside of the whatever constructor you're in, which is the second one here, into that block there, and it'll execute that, which is why we see hello 1, hello 2, and then finally the second constructor is called. Now you can use the initializer blocks to perform some type of initialization for your class, perhaps some basic setup of the class, some initialization type of tasks are a great place to put it inside the init block. In classes, you can also create properties in line here. So I will type a property called full name, and then I can initialize it with the values that are being provided to me through the constructor. So we can use the first name property, and I can use the last name property to create a full name here. Now, if I go back to the main class and I decide I would like to print that, I can say println, and I would say user.fullname, and you see that I have access here to it because it's in the same package, and so I have access. And if I were to run this, we would just see that Don Felker is printed. Now you also see that we have an init block that's been printed here as well. So we have the init block. So one of the nice things too is we can also, let's go back to the main class, we can also change this value. So since this is a property, it means it's mutable, and we've, of course, because we set it to be a var type here. And so what I can do here is say user.fullname, and I can actually reassign this value and just say hello world. And it's going to completely overwrite that value. And then what I'll do here is I will say print line, and then we'll put user.fullname again. And when we run it this time, what we're going to see is the init block, then we will see Don Felker, and then we will see hello world. Now, back inside of the class, there's an interesting thing that we can do as well. Inside of the init block, I have access to this property. So if I were to type something inside of here for the init block, perhaps I just wanted to print something to the screen, I'd say this class is for user, and then I could say full name, right? Now what you're gonna notice is I get a red squiggly here. And what that red squiggly is telling me is that it's not initialized, but as we can tell, it is initialized. But here's what we need to do. We need to actually take that and move the initialization up a little bit higher. Now, based upon the file format and how everything's organized, the init block can now see that full name is there. If I come back and run this, we're gonna see that the init block runs. It says, hey, I'm in the init block, and this is class, or this is class for user Don Felker. That's really bad English. So this is the class for user Don Felker. And if, of course, we rerun that because we don't want typos, we'll see this is the class for user Don Felker. And of course, here we're going to print the full name. It shows Don Felker. Next, we reassign it, and then it shows full name. Now, each one of these, you can have multiple of these if you'd want. They don't have to be initialized from a particular instance variable. You can actually just set it to something like this. Say it's int 0. It can be of any type that you want your proper to be. And I can actually come here and say user.age equals, let's say 22, which I'm not 22, but that would be fun. And then I can then print it or do something with it at that point in time. So that's how you can work with properties using accessors and mutators inside of Kotlin. You can also define read-only properties inside of your class. So you might want to know the full name length and decide to store that as an integer inside of your class. And so you can say full name.length. Now we'll have a full name length read-only property that we can use inside of our main.kt file. So if we say user.fullname length, we can actually get access to it. We can print it to the screen. However, if we attempt to reassign it to, say, 12, we'll get a little error message saying that the val cannot be reassigned. So these values have been assigned based upon the other properties. You could also perform this off of a property directly off of the constructor. You can also decide to set this initially, such as 12 or something like this. And if you'd like, you can provide the type as well. Now let's assume inside of your user class, you wanted to decide that anytime someone requested the full name property, you wanted to make sure it was prefixed with the word name. We can do that very easily by providing an override of the accessor for the full name property. Now what we can do here is we can actually type in name, and then what we can actually type in here is the word field. And what the word field means is this field right here, whatever is stored in this property, go ahead and we're going to use that right here. So anytime someone calls a get on this, which is by default, anytime we call something like this, it's actually calling the get, it's going to return name colon field. So in this instance, if we were to run this, we're going to see something like John Franks, but instead of that, we'll see name John Franks. Now, if I were to leave this off or comment it out, and we were to rerun this again, we would see that the name is just John Franks because it's just printing out the field which has been stored by default and is initialized with the first and last name. Now here I was able to override the get implementation. So I can say, anytime someone requests the first or last name, then we're going to go ahead and say name colon John Franks. Now it would probably make more sense if we just said full name, so it wouldn't match the variable name there. And then once we run it, we'll see full name John Franks. And one important thing to note, this field is actually the backing field for this full name property. So this is what contains the contents of the full name property. So this is known as the backing field. Now I can also override the setter, also known as the mutator. So I can say set, and by default, the value that's passed in to the full name when it's changed is going to be called value. So if I were to say something like this, user.fullname equals John, like this, let's just go lowercase Jon without the H, then what would happen is this Jon would be shoved into full name, which then would call this code block here, and what would be inside of this value variable would be these three letters, Jon. Now I can actually do some stuff, anything I'd like to do in here. So I can actually say if value starts with, maybe I want to know if it starts with something. I say, hey, if it starts with John, Jon, then what I want this field to be equal to is going to be John Doe. So if anyone sets this to John, and then I were to print a line, anything else for the user's full name, it should now say John Doe. So if we run this, what will happen here is we'll see John Franks. Of course, we're printing that the first time. We've reset this to say, hey, the full name is actually John, which we know is not the real case. But if we look at the mutator, the setter here, we're saying, hey, if the first name is John, then go ahead and actually set the backing field to actually equal John Doe for whatever reason. Maybe we have some business requirement that states that we need to do that. And then once I print the full name, of course, it's going to say full name and then print that backing field, which has now been turned to John Doe. Now we do have a problem here actually. If I were to attempt to reassign full name to something else such as, let's say, Jane Sparks, and if I were to try to print that to the screen as well, what we would end up seeing immediately is something we probably wouldn't expect, which is we're still going to see John Doe printed. But hold on, I set it to Jane Sparks. Why isn't that working? The reason that it's not working is because the full name property, we have overridden the setter. We're checking the value that was set to that backed field. If it started with John Doe, then we set it to John Doe. But what we didn't take into account is, hey, what about the else condition here? So we need to do an else condition. If this value starts with this, starts with John, then set to John Doe. Otherwise, set the field equal to the value that was passed in. So now if we come back here and we were to run this, we'll now see that we have John Franks, John Doe, and Jane Sparks that are returned. So you want to make sure that you handle all of the various different types of scenarios you can have. This could very well be a valid scenario for your application. You may only want to decide that only you can change that value to certain, values, or there's some type of logic for the setter that you need to adhere to. However, if you need an else condition, be sure to also implement that so that your property does act like a normal property, which can be have the properties read and have them set. Let's assume that you want to have multiple properties in a class. You can easily do that. So of course we have these properties up here, but let's assume that you also want another property in your class called age, and you're going to default that to 0. And then perhaps you have a favorite color, and that's a string, and you're going to default that to blue. So you can have multiple of these inside of your application, and they can easily be accessed and modified through the property accessors and mutators, which are default. So we say first name, age, like say age equals 30, and I can say user.favorite color equals green. And so these are all possible. You can have as many of these properties as you would like inside of your application, inside of your class. Just like functions, you can have more functions than you like. You say hi, and this could just be a simple little print line that just says hi. And so of course, we could say user.say hi, and that would print to the screen. I could come in here and change that, of course, to hi full name, and then it would say hi Don Felker in this case. So you can easily put multiple properties here. If you wanted to add another one, we can do that here, etc., 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 and put as many there as you would like. You can also add functions to your classes, and you just go inside of your class definition and start typing your function name. So we'll create a function called full name, which will return a string. And then inside of here, we'll just use some string interpolation. It'll say first name, and then we'll say last name with the dollar bracket syntax there, and that will return us the full name of the user. Now you may be noticing I'm not using the brackets around here. If I need to use the brackets, we can, only time we would is if we're using some property off of this. So maybe I wanted to get the length, and you'll notice how IntelliJ added those brackets there for me. Anytime I am doing anything off of this main expression here, it's going to require we put it in brackets. Now, if I do remove this, I can still have brackets here. This will compile and this will work, but notice there's a little gray squiggly here. It's kind of hard to see. If I put that there, I'll get a little light bulb. I can click on it or hit Alt-Enter, and we'll see remove curly braces. And if I do that, it'll just automatically remove them because we don't need them here. Now, this could also be cleaned up a little bit further as well. So we could kind of turn this into a single line function really easily. And we could just go ahead and get rid of this and make it equal that. And we can make it a very small, succinct little function. Now to call this, we would go back to our main file here. We say user.fullName. So we'd actually see that it's a function here. And of course, if we now run it, we will see that we have the name, first name John, last name Franks, and it just puts out John Franks. And again, if we wanted to, again, do something different, we could do .length, and for whatever reason, it would say John, and then the length of the actual last name, which we'd see here as soon as it compiles, John 6, because the word Franks has 6 characters in it. And so you can continually keep adding different functions here. So you could even add a different function here, say full name length. And this one could be very similar. Again, this one might return an int this time, and we could either do it on a single line expression or multi-line like we're doing here. And we could do something, even have one function call another function and say, hey, let me see, get the length of that. And then we can also print this here. And I'll go ahead and go to full name length. And when we run this again, we're going to see that we get the John 6 again, because we did the full name. Let's fix that real fast because we don't want the length anymore on the last name. We just wanted to say John Franks as the actual output. And then we want to actually show the length of the name. And so we're doing that here. So we say John Franks, and then the full name length is 11. So we have one function here. It's calling another function. We don't have to do this. I could replicate this functionality down here by doing this. I'm going to comment this out. And I could say return this dot length, and it would give us the same exact thing. But at this point, we have some code duplication, and that's just usually not a good thing, because if for some reason I decide that I want the full name to have a hyphen in it, well, now this length here is not going to be the same as the full name length. Now it kind of depends on what kind of app you're building and if you need that functionality. So I usually recommend, okay, if you already have a function that provides that value, just go ahead and call that function and then it will be updated. So in this case, it's going to add us 2 additional characters here because we have an additional space and a hyphen. So instead of the 11, we should get back a 13 as we have here. And that's how you add just very basic functions to your actual class. And you can continually adding as many as you would like inside of the class body here. They can reference the members. They can perform different operations. They can even alter the members as well. So if we wanted to do that, we'd say fun, update full name for whatever reason with suffix. And we might have pass in a suffix of some sort, and that suffix might be a string. And we might do something like this. So first name equals, let's say suffix, and then we'd say first name. And then what we would do here is we'd go back to this area here on our main file, and we want to say user.update full name with suffix, and then we'll say Mr. And then as this prints, it should say Mr. John, which sounds a little weird, but that's how it's going to look. And we see Mr. John down here in the output. And that's how you can add and continually add additional functions inside of your class. To create a companion object, what you'll do is inside of your class, you'll type companion object. And then you can start typing the name of your function. So in this case, let's create a function called create user. It will return a new user. In order to do that, we'll actually need the first name and a last name. So we'll need that provided to us. That's not what we want. First name, and then we'll have last name. And then of course, what we'll do is we'll have this return a new user. And it's very simple. We'll just kind of new up the user with the first name and the last name. Now, a companion object is a function or property that's going to be tied directly to the class, or rather than to its exact instances. And it's very much like a static method you would see inside of something like Java. And a companion object is a singleton, so meaning that it's tied to the actual class itself. So what does that mean? Let's go take a look at this implementation here. You can do is here say user.createUser, foo, and then we'll say bar, and we'll say val user. And then what we can do here is we can just print line in the user. They'll say print the user. And what we've done here is we've actually created basically a static type of method attached to the user class. So now you notice how I didn't create an instance of user. I just called a method that was directly on the user class. And that is going to be the create user method. So let's see, create user. And we could treat this like a factory to create objects for us. Now we could go a little bit further too as well. And let's say that we had maybe you want to create a way to create a bunch of users. So I say create users. And then what we can do inside of here is say how many users we would like to create. We'll need to pass in a value. And what we're going to do is return a list of users. So in order to do that, let's go ahead and create basically a class level singleton variable. So we'll say val users equals a mutable list of users. Now, we'll be able to access that via the class. And what we could say here is for I in 0 to the count, which meaning count from 0 up to the number provided count here, we want to add an item to the users list, and we'll go ahead and say user, and we'll just kind of do something first name, and then we'll provide some type of value such as the index here. And then we'll do the same thing here, last name, and then we'll do something like the index as well. And as you can see here, it says we can remove the curly braces, so we can do that here and here because we're just doing a very simple expression. And then of course we'll return the users, which is just the member variable. So let's go take a look at how we would use this. So let's go over here, val users equals, and we could say user.createUsers. So maybe you want to have this to create a number of users or objects or one out of whatever type. And then we can say print line, and then we'll actually print those users out. And when we run this, what we're going to notice is that we see all of them printed on one line. And the reason for that is this is basically Kotlin's way of showing us, hey, this looks like some type of collection because we have a square bracket and a closed square bracket over here, open and closed square brackets. And this is the first element inside of our list. So 0, 1, 2, 3, 4, 5. So actually, if we're to make this a little bit easier to read, we can actually use one of the collection helper methods called for each, and it basically iterates over each item. And then inside of there, we can print off the item, which will be, it's called it by default. And if we run this, we'll see that we actually have them printed on each individual line. But now the interesting thing is we said, let's create 5 users. 1, 2, 3, 4, 5, 6. Now, the reason why we have 6 is because this range is starting from 0. So we could change this to count -1, or we could just kind of make it simple, saying, hey, go from 1 up to the count. So now if we run this again, we'll see that we only have 1, 2, 3, 4, 5. Now, we could count this up to 15, which is great. And we can go ahead and create 15 different users, and it's all pretty simple to do. Now, also the cool thing is here as well, let's go ahead and comment this out, is that we've now created our users, but perhaps we could say, users 2. So we'll create a new variable here. I'll say user.users. Remember, this is a property. It's a singleton property that's on the user class. So this method, create users, actually modified this list here by adding to it. Now, again, back here, we're not doing anything with the users. We're just kind of leaving it there. So technically I could just kind of get rid of it if I wanted to. And then I could say users, and then I could say print line. Let's actually just go ahead and copy this up here to make it easier. We'll say users 2. And of course that's not there. So we'll say users 2, print line. And if we run this, what we'll notice is that the users object, of course, was populated via the create users. So now if I were to come up here and say 0, so don't create any users, it's going to see like we have an empty basic list. We see foobar, that's this one up here. So if we were to, get rid of this guy up here, we wouldn't have that. And then we're not going to have anything output to the output of the window because we don't have it there. So that's how you would build a companion object inside of your Kotlin class. You use the companion object keywords, open and close curly braces, and any functions and properties that are inside of here are class level, and it's basically singleton scoped. Let's say that you would like to keep track of a user's favorite food, or even just a favorite food for your application. Let's assume that it has some ingredients, and those ingredients are a mutable list of string. And let's also assume that there is a name of a favorite food here. Let's actually make this one mutable as well. And this one's going to be a string, and we can go ahead and default this to unknown because maybe you want to change it later. Now, with a singleton in software development, we only want one instance of this to be created at any time. So if I have one favorite food, I can't have multiple. I mean, I could have multiple favorite foods, but let's say my most favorite food in the whole world is X, Y, and Z. I only want one instance of this to be created. But however, if I were to set this up once, I say favorite food, I can create one instance of it here. I can create another instance here. And how would we do that? Now in so as you can see, I have multiple of these instances. And I only want to be able to restrict the user from creating basically one instance of this. So how would I go about doing that? Well, in other languages, what you would do is you would mark the constructor private and say private constructor. And now, of course, we're not going to have the ability to create this. But now what we need is some type of helper method to create this. So maybe we have a companion object, and this companion object has a new method called instance. And this instance just basically creates a favorite food for us. So it's basically a private method that creates a favorite food for us. But now, even then, we're going to keep getting new instances here. So even if we did this, so let's undo those things. We can say favorite food at instance. We're still going to get multiple different instances of this food. So what we'd have to do is inside of this, we'd have to kind of lock this down. We'll say, all right, it's going to return a favorite food. And then inside of here, we're going to have to possibly need a, let's say val instance equals favorite food. And we start getting into a lot of code here to kind of start managing this. You can kind of start to see that we're going to start getting out of control. We need to, start handling, create the new instance here, etc. Now, thankfully in Kotlin, this is a lot easier. We don't even need to do all this. This is already handled for us. And to create a singleton in Kotlin, it's actually really easy. So I'm going to delete this private constructor. All we have to do is change this from class to object. Now at this time, we only have one instance of favorite food at any time. So now if I go favorite food, favorite food dot name, I can say print line of this favorite food dot name, and we're going to see unknown. So if we run this, we'll see unknown. Of course, this will say unknown. Now if I were to change this, let's say favorite food dot name equals, maybe you love, I know I do, I love watermelon. So I'd say watermelon. And I were to run it again, we'd see still unknown because we didn't print it here. So let's print it again. If I print it now, it'll say watermelon. So I've just only have one instance of this at all. So now even if I were to create a function, so I'll say fun, and let's just call it do stuff. And then do stuff is going to do something. And so I'm going to say, hey, favorite food dot name is, maybe it's chicken now. Now, if I come back up here, I'm just going to say call do stuff. Oops. Say do stuff. Actually, we need to define it before I call it. So I'm actually going to take this and move this outside of our method here. So there we go. Say do stuff. It's going to call do stuff, and then I'm going to say print line. I want you to print my favorite food.name again. So what we should see here is we should see unknown, then we should print watermelon, and then by the time we get here, it should say chicken. So even though we're calling, inside of the do stuff method, we're calling favorite food inside of a different scope. Right now we're in the main function scope, but here we're in the do stuff method scope. What we're going to see here is that this is treated as a singleton because there's only one instance of it lying around. So once we run it, we should see unknown, watermelon, and chicken as we do here. So the same thing can go inside of here. For example, if we wanted to, let's do this right here. So favorite food dot ingredients dot add. Let's just say salt. Everyone loves salt. And then I could actually print here. So print line, how many ingredients are in here? Or just print the first one. So favorite food.ingredients.first. It'll print the first one here. And then maybe inside of do so, let's actually run that to see what that looks like. So we'll see that the salt is the first ingredient that's printed there. And now inside of do stuff, again, just to demonstrate this, let's just go ahead and say favorite food.ingredients.clear. So we're going to clear out that list. And now I want to print this, so we'll kind of put that so it's a little more obvious. And there we go. Kind of break them apart. And if we run this again, what we'll see here now is that the ingredients have been cleared, and we'll see that this list is empty. So now we get an exception here on main line 14 because I'm calling first. So what I could do here is something different, like first or null, and that would actually give me a null value. Should print null there, which it does. So we can say print null. And so there's nothing in that list at this point in time. So this is one way that you can create a singleton inside of Kotlin very easily. So you're just going to replace the class keyword with object. And then of course you can also put methods inside of here as well. So you can say fun, you can say number of ingredients. And this can be a very simple method that just returns the ingredients dot size. And of course, we could just call that from up here as well. So print line. We could say favorite food dot number of ingredients. And if we run that, we should see 0 at the end. Oops, it's asking us for a return type that I did not specify. So I want to say int. So if I run this here, it's 0. If we come back up top here, where I added an ingredient, we should see 1 right after we see salt. So we'll see 1, then chicken. Of course, it was cleared out inside of the do stuff method, the ingredients were. And then of course, we printed the number of ingredients too. So we can have a singleton, we can have properties, we can have various different items in here, we can have functions, but this is now treated as a singleton. I cannot create multiple instances of it. And if I were to print off, if I have 2, println, favorite food equals favorite food, what do we think would happen here? Hey, are these two is this equal to itself? Is this the same instance? Let's take a look here, and we'll see down here we have a true. So these are actually the same exact objects that are stored in memory, and that's how you can create a singleton in Kotlin. To create a constant inside of Kotlin, there are a few ways to do it. The first is a local constant. Now there is actually, let me see, there's a const keyword for helping define a constant, but what you'll see here is the val is only allowed on top level. Excuse me, if we get rid of val here, we'll see that const is not applicable for a member function or properties in that case. So we'll need to get rid of that. Now constants are usually defined in uppercase and separated with underscores. It's kind of the de facto standard for many JVM-based languages. But let's say that we have a constant that's a max age of 18. Perhaps this is a application for a children's application and we want the max age to be 18 for whatever reason. Now I can use this inside of here. I can say max age and I can do something with it. And so forth. It's a val. It can't be changed, so it's immutable. Now, if I'm back inside of the main function, I can still access this though. So I can say user, if I still want it to be locked down, I would have to actually provide some level of modifier on it. See, because we can access max age right here. If I didn't want to access max age, what I would need to do is throw a visibility modifier on there saying, hey, this is private, which is private to just the scope of this class. Now main, you'll see here, we don't have access to it. It says, can I access max age? It's private inside of user. So that's the first way that you can do it. Now you can also create, this again is scoped to the instance of the class. So if we were to see max age over here, we'll say user.maxAge, this max age is scoped to the instance of this user here. So it's instance of this user. So if you wanted to be a more appropriate constant, as you see in other languages, you would think to do this. But what we'd actually need here is a companion object. Inside the companion object, we'd say, I want to say const val max age equals 18. Now inside of here, again, we can access max age very easily inside of our actual class. It's local to the class. We have access to it. But however, if we say user max age, you'll notice that we don't have a max age on user, but we can access it because it's actually because it's inside of a companion object. It's scoped to be a singleton as part of the user class here. It's kind of a singleton scoped for the value. So we say user.maxAge, and there we go. Now we can actually view the max age, which means that we can use it outside of in various different locations. So it's basically users almost treated as some type of namespace. Almost, you could see it as that way for max age. So again, we have the local type, we have inside of the companion object. Now also, a lot of times you'll notice in applications, many people prefer to put their constants in maybe to a new file, and they'll call it constants. So constants.kt, and then what they'll do is they'll actually create an object, and they'll call it constants. And you remember, when we use the object keyword, that's a singleton. And so what we can say inside of here is const val max age equals 18. And then we might want to say const val, we have a minimum age requirement is 5 for whatever reason. And then back inside of our main class, with that, we can then use that as we've seen in other languages. So constants.maxAge, we have constants.minAge that we can also access as well. Now these all don't have to be inside of objects or classes or anything. They can be also at a top level. So they can just kind of be floating on their own in their own files. So maybe we want to have a implementation that looks like this. We say const val max age equals 18. Now this could be reference over here. There's max ages in the root of the file. I could be over here instead of user. I could say something like this, max age. Now this is, again, I'm going to go to implementation. It's going to this root level file over here. Now, which one should you use? I prefer to keep any of the constants that are applicable to the user inside of the user class. So I would have a companion object for me, and I would put const val max age if this was only pertinent to the user. If I have a constant that is going to be shared across many different parts of the application, at that time I might create a constants file where it's an object, and I call it constants, and then I have const val, etc., ABC, whatever the value is, and it could be foo or whatever. And then I could access that from anywhere inside of my application using the constants as kind of a default standard there. So that's the way that I would do it. If you're going to need constants, I prefer to scope them to the class that they have. Again, if I don't need this constant on the outside, I don't need it visible on the outside of this, then what you can also do is just go ahead and, you don't even have to use the companion object if you don't want to. And you can just mark this as a private, and it can be just stored as a max age. Now, what you can also think about is if you want to, this is going to be stored around as a class, part of the class as well. So if you don't want that as part of the class, you can just put it inside the companion object, and you can mark this as private inside the companion object. It will still be visible inside of your class. So max age here, but if we go back to the main implementation and we say user, we create a new user again, and I try to access that user max age, we'll notice that it's not available because I've marked it as private. So now if I remove private and I go back to here, we'll see we have access user.maxAge. If we go here, private user.maxAge is not, we can't even access it inside of here, even though it's scoped to the class via the companion object. I don't have access because we've slapped the private modifier in there. So again, just to recap, if you want to have your constants, I prefer to keep them scoped locally to the class that they belong to. If they can be accessed and are usable by many classes and have kind of cross-cutting concerns, I will then usually put them in some type of constants file. I rarely will ever use them at a root level, such as this const val foo or whatever equals bar. These are things that I don't do. Simply because these are kind of just randomly floating around in some unknown space and don't seem to be scoped too well to keep things organized in my application. So depends on what your use case is, but that's how you can create a constant in Kotlin. Let's say you're building a wizard to create a new user through some type of screen, and you know that you want to store the favorite city of a particular user in a variable. And so you could say it's a string, right? Now, by default, if we can't just leave this uninitialized, we're going to get an error here that says the property must be initialized. And so we could say empty string. Now that would work. So what we could say here is when we print this to the screen, we might want to say, so say Don Felker's favorite city is, and then we'd print the favorite city and so forth. We could print the favorite city. So let's go back to the main file here, and inside of here what we could say is user. We'll create the new user and we'll print the user to the screen, and when we print it we'll see Don Felker's favorite city is blank. But now, however, this isn't really useful. Kotlin does provide us with the ability to say like, hey, I know I'm going to need a variable, and I know that I need it populated, but I kind of know that it's not going to be populated just yet. So just go ahead and trust me. I'm going to initialize this thing. But I'm not going to do it right away. So basically, as soon as this variable, its property has been declared, it's not ready to use, and I'm telling Kotlin, hey, that's okay because I'm going to initialize it later at some point. But let's assume for some reason that I don't initialize it. So what's going to happen here when we call the toString method? Let's go back to the main file. So we haven't told Kotlin about the favorite city at all. Now, if we run this again, what we're going to notice is we're going to get Kotlin blows up here, and it throws an uninitialized property access exception. And it says that the late init property for my favorite city has not been initialized. So Kotlin's basically letting us know like, hey, you told me that you were going to initialize favorite city at some point before you used it. However, you tried to use it down here on user line 8, which we're on here. You used it down here and it wasn't initialized. We're not allowing that to happen. We're going to blow up, and Kotlin throws the uninitialized property access exception. So now the nice thing here is it's easy to fix. So this allows me some safety to know that my application is working correctly, that I've actually initialized this, because I do need a favorite city. I do need it populated, and I want it to blow up if it doesn't. So now I can say user.favorite city, and I could say, let's go ahead and go with it. Newark is a great place. So let's put Newark. And then we'll hit run. And that's not really my favorite city, but we have Don Felker's favorite city is Newark. Now we don't get it blowing up anymore. So I could even set this to an empty string. That's fine as well. But now at least that's been initialized. I've told Kotlin like, hey, I could say Minneapolis, which is one of my favorite cities, and we'll print off here. So we'll see Minneapolis, and we'll see it's populated. So that's one way that you can do it with a late initialized property inside of your application. This could be a string, it could be another object, it could be any of that nature. You're basically telling Kotlin, hey, I'm going to need some type of variable that I don't know what it is yet, but I do need it populated before I can use it. So I'm not going to initialize it here. It's just going to be initialized later. So late init. So it's late initialization. So just if I don't initialize it, blow up. Now, one important thing, if we say, hey, well, this is a mutable property, I don't want it to be mutable. Well, if we try that, what we'll notice here is we get this error that says the late init modifier is only allowed on mutable properties. And well, if we think about that, the reason why is because we have to mutate it as soon as whenever we want to change it. So it has to be a mutable variable. Otherwise, it would be defined immediately. So as soon as it's defined, if this were this way, of course, we're going to get an error. But if we were to define this as NYC, it would work just fine. But since we are using late init, it has to be a var. And that's how you can define a late init and use it in Kotlin. Let's say that you wanted to have classes nested within themselves. Kotlin supports that. So let's say you have a class called vehicle, and the class vehicle has a brand, and the brand is going to be string, and we'll just default that to unknown at this time. Now, perhaps a vehicle also has a type of a steering wheel class for whatever reason. So we have steering wheel. So we actually put this class inside of the vehicle class, and then I could say something like this: val name, or we make this var, whatever we wanted to do. And we could say the steering wheel. And inside of here, we could even provide a function of some sort. So we could say func info, and then we could just say it could be a print line of some sort. So inline function, and we would say name. We print the name. Now, if we wanted to use this class, we could actually very easily come up here and say val steering, SW for steering wheel, say vehicle dot steering wheel, create a new instance of it. And then I could say sw.info. And if we were to run this, we will see that it prints the steering wheel, which is we see here. Now we can also, we're not limited to just one class. We can have multiple different classes inside of here. So we could have a class, and we could call this one a transmission. And perhaps we just, for whatever reason, we're building some automotive software. And we're going to have a var type, and it could be, we're going to default this to automatic. And then, of course, maybe we might have a function called shift, and we'll just have it print off something like that, say println, and we'll say the vehicle is shifted. And what now we can do is, of course, we have the steering wheel. We don't have an instance of the transmission. We would say val transmission equals vehicle dot transmission, of course, and then we'd say transmission dot shift. And of course, we're going to see when we run this, we'll see the steering wheel, and then we'll see the vehicle has shifted. So now each time if we were to run this multiple times, we'd see the vehicle shifted twice. Very simple. So we can actually nest classes inside of here. Now notice we haven't done anything with the brand here. So we could also have some information about we have a info function here. And this one will just print off the brand here of the vehicle. And the brand of the vehicle will kind of print off there. And let's actually set this to a var, because we know we're probably going to change that as well. So maybe we want to say something like this: val vehicle equals vehicle. And maybe we want to change the vehicle to brand equals fiat vehicle.info. So we'll print, we'll see fiat, and then we'll see that the steering wheel and the vehicle shifted, and the vehicle has shifted. So that's how we can nest classes inside of Kotlin, and it's useful for when you want to things are somewhat related and you want to kind of keep a class hierarchy accordingly. So you might have a vehicle, and inside of that, there's a steering wheel. So as we're creating it, we can kind of see that these things are related. So there's many different related domains that you're going to encounter in software. This is one way to organize them with nested classes. Kotlin's nested classes are easy to create. Inside of another class, you can have another class to create different types of hierarchies. However, there are times when you would like to access instance variables and methods and so forth inside of a nested class. So let's assume the steering wheel, we wanted to print the brand name. So we would say brand of car is the brand of the car, a vehicle with a boom name. We'll call it the steering wheel. We'll call it with leather. Say leather with a leather steering wheel. Now notice we have an error here. Brand is not accessible. The reason for that is by default nested classes do not have access to the member variables of the outer class. If we want to do that, we need to specify that this is an inner class of vehicle. So vehicle has an inner class, and the inner class can now access these variables. So you can see brand is the brand of vehicle. So let's go ahead and get rid of this. And then we can say Fiat is the brand, vehicle info. Now we see here the steering wheel is the constructor of steering wheel can only be called with the receiver of the containing class. Now what that means is because steering wheel has access to the member variables, it's going to have carries a reference to the outer class, meaning that we can't use the actual class name vehicle. We actually have to use the instance because steering wheel is going to carry a reference to it. So we have an instance of vehicle right here. It's called vehicle. So I'm just going to go ahead and delete this because it's the capital V, which is the class name. I'm going to go with the lowercase v. Now, if we want to just change this and call, my car, we could do that. So it's called my car. And now we can say my car.steering wheel. And then we're going to actually see it's going to create an instance of the steering wheel class. We're going to say steering wheel.info, which is right here. And if we go to info, we'll see it's print off the brand of the vehicle. And let's go ahead and run this. And what we will see now is that when it runs, it says Fiat. Fiat is the brand of vehicle with letter steering wheel. Now, since the transmission is still a nested class, we cannot call my car.transmission. So the reason for that is it's a nested class. If we wanted to create a transmission, we would have to say vehicle.transmission. Now, if we wanted to make this a inner class, of course, we'd slap on the word inner. Now, of course, this is not going to work. We have to use an instance because the transmission is going to have a reference to its outer class. So in that case, when we create an instance of transmission, it's going to keep a reference to the instance of my car here. And that's how you create an inner class, which can reference an outer class in Kotlin. Often during development, you'll need to create some type of construct that shows you what different types you have to work with. And for example, we might want to have something with different account types. Maybe we have various different users who have account types and they look something like this. So we have one that's a bronze account type, we have a silver account type, there's a gold, and there's a platinum. Very often you'll see these, for example, with credit cards or different types of gym memberships or something like that. And if you're modeling something like this, you'll want to create a user-defined type, and that's typically done with an enum. And to define an enum, you will use the keywords enum class, and then, for example, I'm going to call this one account type. And then by default, inside of enums, you give the names of the types, which is your user-defined type. You uppercase them. So we'll say bronze, and then they're separated by commas. So silver, gold, platinum. And then if I want to use the account types, which we'll get rid of this now, I can just say account type dot gold. And now I have an instance of gold, so I can start representing something like that. So if I were to print line this, and these are very useful inside of various different if statements and conditional clauses and so forth. So we can see gold there. Now, this is something in Kotlin about anytime you're interacting with an application, a lot of times you'll be talking to a API and perhaps you get a value down that's gold like that from an API. And so you need to create an account type off of that. And to do that, you can use the account type .value of, and then perhaps you would say, so let's say we had a string that was given to us from an input somewhere, maybe an API, and we'll call this, account type from API, and then we'll just call it gold. And if we want to turn this gold, this gold right here into an actual account type, then we'll say account type. We'll see value of, and we'll say account type from API. Now, if we run this, we're going to run this here, and we'll see that, well, that didn't work. There's no enum constant by the name of account type.gold, but we do see one here. So what's going on here? Well, the reason is because this is an uppercase value. So we can just say here to uppercase. And if we run this again, we'll see that it runs and compiles just fine. That gives us our account type. So now we can actually say print line, and we'll actually say account type, and it'll say gold, as we see here. So now we actually have an instance of gold, which is nice. So we can actually say account type. Does this actually equal an account type of gold? So this should return true, which we'll get running and say it's true. So now we can actually work with these different types of enums. Now, a lot of times this is very useful inside of conditionals and different types of things like that. So you might have your user class, which if we go back over here to our typical user class that we might have a user that's associated with account type. So we might have our account type, and that would be, an account type of whatever. And we might want to default it to account type.bronze. Maybe that's what it defaults to. Or instead of doing it here, we could actually just put this all up inside of the constructor and have it use a default value. So account type, and we don't need that. We can say account type equals, we do need that, excuse me. Account type equals the bronze. And then if we decide to override it, for example, we could say val user equals user. And then we want to say Don Felker. And then I don't have to provide an account type, but if I'd like to, I could say, well, he's actually going to be a platinum account for whatever reason. He's a good customer or something like that. And now I can actually start working with this. And then in my application, I can say user.account type. I can then do some different types of things with conditionals inside of that and then start working with it. And it gives us some user-defined types that are basically strongly typed. We're not working with strings, doing string comparisons, and we can work with them accordingly. That's how you can create and work with very basic enums and define them in Kotlin. Sometimes it's useful to provide values associated with an enum. For example, if this was used for a gym membership, let's assume that if you're a bronze account type, you're going to then get, let's say, 10% off. If you're silver, you're going to get 15% off. If you're gold, you're going to get 20% off. And if you are a platinum customer, you're going to get 25% off. Maybe bronze is a single member. This is 2, this is 10, this is more than 10. So you start getting more discounts for more members on your plan or whatever. So how would you define this? Now, what you would need to do is provide a constructor for your enum. And so what you would do is you'd say val discount %, and this could be any number of things, but we'll make this an int. It could be floats or whatever. Now you'll notice we have a bunch of errors here because the enum has no default constructor. So we need to use the parameters. But if we were to provide a default constructor, maybe we said 10, now all these would work and they would default to 10, but let's not do that. Let's make the compiler work for us by defining that we actually need to have a particular value passed into each individual enum. So here we're going to say 10, this one's going to be 15, then this one will be 20, and this one will be 25. So there we go. Pretty simple there. And we can go ahead and delete all this stuff out. And now if we were actually to print line this to the screen, we would see that we can still do account type.gold, and we'd still be able to print gold. And then we can actually say discount %. We can actually print the discount %. So if we were to run this, we would see that we have gold and 20. Now, you're not just limited to a particular number of parameters. You can do another one here. So we can say val, say number of subscriptions, and this could be another integer value. Now you see here again, we're having the same problem. So maybe this is the minimum number here to reach this one. This one you have to have 5. This one you have to have 10 people. And this one you have to have at least 15 people. And these are perhaps the minimums. And now again, I could then say, all right, well, what does this one have for number of subscriptions? And I can start providing a kind of a known simple little data type structure, a custom data structure here that says, hey, this is a enum class. It's an account type. And it's going to be bronze and silver or gold, etc. And it's going to have these discount percentages and subscription percentages or number of subscriptions that are required accordingly. And I can start to define that here in code so it's strongly typed. And of course, as usual, I could actually perhaps maybe even say I only know this because it comes down from an API. And I can say account type dot value of, and I'm going to use gold to uppercase. And I can even do something like this. Maybe it's, regular case like that. And would we be able to see this? Let's take a look here. And we can actually just say value. Actually, let's just do, instead of gold, let's do platinum. And we'll run this again. And we can see that we have platinum. And now if we actually do something like this, print line, I should just copy this twice. And we'll say discount percent and number of subscriptions. So basically what we've done at this point in time is we've gotten a string here. We have acquired the account type enum, and then we're able to print the values off that. So let's say that the value platinum came as a value from an API or a database call. We could then create this type at runtime and say, all right, well, they are platinum account type, and it's a 25% discount, and a minimum number of subscriptions is 15. So that's how you can use constructor parameters with an enum in Kotlin. Let's use the discount example again, and let's assume that you needed to provide a discount for bronze or silver, gold, or platinum, but it had to be calculated. So what you could do is you could define an abstract function, and you could say discount percent, or you could say calculate discount percent. And it's going to return it's going to be a function, and it's going to return an integer. Now, what you're going to see here is I spelled abstract wrong. And now, as soon as we get that fixed, we have a bunch of errors here saying class bronze is not abstract and does not implement the abstract member calculate discount percent as defined inside of this type. And the same thing happens here for silver and gold and platinum. So what we can do is we can add some curly braces here. And then we can implement that interface, and actually we'll see, implement that abstract class, that abstract function. And we can either just do it inline here, or since this is going to be, if you're going to perform some type of complex calculation, you could do that in here and, perform your logic and so forth. And then finally return, whatever 5 or whatever you've calculated. Or if you just know it's going to be very simple, you can also inline it. So we might be able to just say 5 here. And the same thing would happen here. Again, I would need to implement that member here. And then I could say 10. And what I'm going to do is just copy this over because this is easy. And then we have to space that over. We'll have 15. And again, these are different percentages than I had last time. But for the example here, they're all the same here. So calculate that accordingly. And it looks like it's expecting a semicolon at the end of this after we've kind of built all that up. Now what I can say is if we use that same type of example again, maybe we have something coming from the API and it's just all spelled kind of really weird with weird casing. We would want to say we have the account type and we got that from the account type dot value of, and then we take the from API, go to uppercase. Now we have that type. And then we could say print line account type dot calculate discount percent. And if it's going to be gold, which we could run it, we should see that we're going to get 15, which we do. If we change this to num, which, we're just doing weird casing here to mess with it, and platinum is 20. So that's how you can implement an abstract method inside of an enum. This would be very useful, again, if you are not sure what you are going to return. Of course, it's going to be an int, and you need a larger calculation. You can use a larger block here. So you could do a bunch of work here, and then you're going to return whatever that value is. If it's, for example, maybe it's going to be a var percent, and you want to start off at 0, no discount percent, and you get to return a percent here, and perhaps you're going to kind of do calculations inside of here based upon maybe some other constructor parameters that you have inside of the account type, which we don't have any here, but if you did, you can perform all those calculations here. And that's how you can use a abstract function inside of a Kotlin enum. You can also iterate over all of the types inside of an enum very easily by using the account type dot values. So you can use the values method, which is built in for you. You don't have to define that. It's just part of the enum built in for you. And so what we can say is for, say type, let's actually say account type in these types here. Then I could say print line, and then I could say account type. And if I were to run this, then what I would see is that when I run it, we're going to see all the types here printed on new line, bronze, silver, gold, and platinum. And the values method returns an array of those account types. Now, because it's an array, it's a collection that's built into Kotlin, we also get to have access to all those nice little helper functions, such as for each. So I could do the same thing here, and I could use print line. I could use the kind of built-in IT to kind of one line all of this together instead of having 3 lines of code that does the same exact thing. So you can iterate over each one of those. And that's how you can iterate over all the values inside of an array, really, of a enum as an array very easily. To add a static method to an enum, what you want to use is a companion object. But first you want to terminate the different enums by providing a semicolon at the end. Then you'll want to say a companion object. And for example, here we could actually have a function that says get account type by name. We could just pass in the name, and it's a string. And this could just be we could just use the value of name.toUppercase. And you may be wondering what this is for. It's a kind of a nice little syntactic sugar to say account name, account type by, get account type by name, and I could just pass in gold. And so I could say account type, and now I could actually print this to the screen and just say account type. And then if we hit run, we should see that we're going to get gold on the screen, which we do down here on the bottom in the output window. I could change this to platinum, which, different casing or whatever. And then of course, for whatever reason, if I just spelled it wrong, it's going to blow up because we don't have a value with a constant of this type, which is what you would probably want to have happen if you're trying to use that in your production code. Now, just an important note here is that Kotlin doesn't have a concept of a static method. This is just Kotlin's way of kind of providing the same functionality out of the box. And that's how you can create a companion object method. It kind of acts like a static method inside of a Kotlin enum by using a companion object. Kotlin doesn't have a concept of a switch statement. Kotlin's switch statement is known as a when. So let's go ahead and create a user to work with real fast. And this user will have a first name of Dawn and the last name of Felker. Now, the when statement looks something like this. You say when, and then you provide the value that you're going to evaluate here as the condition. Say user.firstName. Say, hey, when the user's first name is equal to something. And each line here will be a condition that we're checking. So when the user's first name is Dawn, then we want to go ahead and perform some type of action. And we'll put that inside of some curly braces here. And we'll say println. Say this is Dawn, and then we can run this. Now, if we run this here, we'll run, and we'll see in the output window that we say this is Dawn. Now, if for some reason we change this user's name to Dan, of course, this evaluation is not going to run, and we're not going to see anything printed out to the screen. So what we can do is also provide a default branch, which is known as an else inside of the when, and we can provide the brackets in here too. Println, this is not Dawn. Now, if we run this again, because the user's name is Dan, which I'm sure there's a Dan Felker somewhere, we'll see this is not Dawn. So the else branch has now executed here. Now, one of the things, and you can put multiple different things inside of here. So we could do a print line, foobar, or do some type of logic or whatever. These are just basically blocks of code that you can do stuff with. Now, one of the challenges that you're going to run into when you first start developing with Kotlin is you're not going to understand how to write a when statement. At least that was my experience. So thankfully, the IDE helps you out a lot here. So you may be familiar with writing something like this, user.firstName equals Dawn. And then you may have this print line statement here. And then you're going to have an else. And this is very common in all C style languages, which you're probably used to seeing many times now. So if we comment this out, we'll see here that Dan Felker. So we should see this is not Don. Let's run this now. And we'll see this is not Don. If I change this back to Don Felker up top, we'll see that this is Don. So that condition will be run. Now, again, I know that I probably want to use a when statement. It's very Kotlin idiomatic to do so. Now, you see as I put my cursor here, we get this little yellow light bulb. You hit Alt to enter or hit this and say, replace if with when. And automatically it rewrote the code for us to a little bit different here. Now, this doesn't look like the one that's down here, yet it does the exact same thing. And what this is basically saying is, hey, is this username, first name equals Don? Now, it's going to just say print line. Now, notice how there's no brackets here like I have here. So let's undo what we just did before. If I have multiple statements in here, and I say this is cool, and then I come back up here and say replace the if with the when, the IDE will automatically provide the brackets for us. So if it's a single line statement, what will end up happening is when we replace the if with the when, it will then turn it into a single line inline statement, so it's easier to read. And it's also optimized it here because it says, hey, we don't have to evaluate the when for the else here, so we're just going to throw it in this item here, which also means we could just say this could be Dan. Now at this point, it's getting kind of redundant. So we say this is Dan. And if we were to run this now, let's run real fast. You're going to see that it's going to say this is Don. Now if I put in Dan, say this is Dan, and then if I put in this is Dana, it's not going to work because this is Dana. So then I can rewrite this. In my opinion, it's a little bit cleaner. I can actually just say, get rid of this stuff here. And what this will do is it'll evaluate when I can put this inside the user.firstname. So what this is going to do is only evaluate whatever is inside of the first name variable. So what this is saying is user's first name, when it equals Don, go ahead and print this out here. When it equals Dan, print this out here. Now, when would you want to not use that? That's a very good example. So you could actually say, well, when the user's first name is Don, then we want to print this as Don. But what if we only want to print it when it's Don Felker? So user.last name equals, we want to go over here. User's name equals Don, and user.last name equals Felker. Then at that point, we want to say print this as Don. Otherwise, we don't. So let's go back here and let's change this. Again, let's go to Dan. Let's go to Don Felker and run this. What you'll see here is it's going to say this is Don. But what happened if we added just Felk, right? They misspelled whatever, and run it again. This is not going to run. It's going to say this is not Don, because what this when statement is doing is using this entire line as an evaluation. And again, once it starts getting kind of long and goes after the initial line break, I prefer to put it inside of a print line here. So you can start evaluating multiple different conditionals inside of here using this when statement. And then of course you can have a fall through as the else at the end. You can mix having blocks of code inside of here, or you can kind of have one line evaluations and statements here, which will then evaluate these expressions and print them to the screen. You cannot put multiple ones here on the same line. As soon as you need to do multiple things, you will need to provide a block for that. So that's pretty easy to do. You can just go ahead and provide that. println, and accordingly. And you can put some other stuff inside of here. Println. This is, ABC, whatever. And then that's how you can go ahead and use a basic when statement inside of Kotlin. And of course, this can be used with different types of things, such as primitives can be used to check different instance types. This is just a conditional, very much like an if. And again, if you don't know how to write the when statement, you can always go back to the if statement, write your if statement, and then go ahead and use the helper inside of IntelliJ, Android Studio, or any other Java IDE that's built by JetBrains to actually have it go ahead and replace your if statement with a when statement. There are times in a when statement when it's used as an expression that it needs to be exhaustive. What that means is an else statement must be provided. So let's assume that we have a when statement based upon an account type. So if we have an account type, and we'll just say account type.gold, and we can say a when statement here. So when account type, and then we say gold, what we can actually do here is, we can actually have some type of code here, and we can say return gold member. Maybe we want to return certain strings based upon whatever their status is. So you can see here, we have an error and it says, hey, this is by default a unit. It returns a unit, but we're telling it to return a string. So what we can actually do is have when return a value. So we actually say val equals message. So I want to say a message off of this when statement. And what you'll see here is it's telling us, hey, well now when the when expression is used like this, it must be exhaustive. So we have to actually handle all of the different scenarios because this val must be populated with something. It has to be something. And the compiler knows by default, well, account type has different values. It has bronze and silver and gold and platinum. If you pass in, if this is platinum, it doesn't know what to return. So it's telling you, hey, you have to return all of these things inside of here. And what it's saying is here, you can do this one of two ways. You can add the necessary bronze, silver, or platinums, or add an else branch. So there's two ways to do this. We could say, hey, gold member, or we can say else, and we could return a regular member, something like that. And we'll see here we have, looks like it's returning. We don't need to add the return statement there because it's actually used as an expression, so we don't need to return anymore. And then what we can do here is say print line message. And when we print this, well, we're going to see that they are a gold member. Now, if I were to type this as platinum, we know that this is incorrect. And it says regular member. Now, that's not correct here. So maybe what we want to do is if we say if they are gold, then, anything else like that, or maybe platinum is the highest level, we'll say platinum member. Platinum. And then inside of the class here, we can say not eligible for special access, whatever that might mean. And if that's basically saying this is maybe a string that's going to be displayed to the screen. When they're platinum, then use this. Otherwise, for all other instances, if they're gold, silver, or bronze, then we want them to only see not eligible for special access. Well, here, they're a platinum member, so we can actually say platinum member access allowed. And then when we rerun it, we'll see platinum member access allowed. And then we can come up here and change this to silver. And we rerun it, and it says, hey, you're not eligible for special access. Now, that's when we could do it. One way we could do it now, we could also change this and provide an implementation for each individual one. Now, it doesn't matter. We could type bronze here. We could type the different ones here. This would, of course, maybe there's a bronze access. There's bronze member access. And so we have this. We'll change this to silver. And notice we still have this squiggly line up here. It's still complaining that we don't have everything that we need. And then we can change this to gold, right? As soon as I provide the gold, I've provided all of these values. Gold member access allowed. Now, the beautiful part about this is, regardless of whatever I've typed inside of here, now look, this is telling us we can inline this here. We can inline the message, which we don't really want to do because we're assuming this comes from an API or database. The beautiful part about all this, once we run it, we'll see that we get the correct bronze, silver, gold. Is that, and just excuse me, I'm going to reorganize this here because it just makes more sense and matches the code. Is that when we have account types, they're going to have a value here, which means later on in our application, if we decide to, for whatever reason, our business needs change and we add a new level called Onyx, now our application will not compile. The compiler is going to check this and say, hey, this when statement is not exhaustive. So if this account type is in another class file or another file in our application, which it's most likely is going to be, and we've added Onyx because it's coming down from the API. Cool, we have Onyx now. We're going to add that and we're going to try to compile our application, and the Kotlin compiler is going to say, no. You can't do this because you have to make sure that this when expression is exhaustive. Now, of course, can be gotten around by if the else is here and then say unknown member type, or whatever. And you can have that and it'll be, you can add it in there. So if you add another one, you can say pink and whatever that would be. Maybe it's special, cancer awareness or something. It pops in there. Then you can have that inside of there. The different types that you have in here, again, this doesn't matter if the bronze is at the bottom or whatever. The expression will be evaluated and the message will be returned at that point. And that's how you can work with an exhaustive versus non-exhaustive when statement. And again, the non-exhaustive one is going to be perhaps if you just want to perform some type of evaluation. So this would be non-exhaustive when account type. And I could say gold. And I would say maybe just print something to the screen. This is gold. Now, this is non-exhaustive here. We're not required to provide an else statement. Because this is using an expression, it's going to be returning a value. We have to provide an exhaustive approach. We have to exhaust all the options. So we need to provide all of the options or also provide an else at the bottom so we know what to do there. And again, there's no onyx here, so it starts complaining and so forth. And if we delete the onyx and we just go to platinum there, we fix our compiler problems. And that's how we work with the exhaustive versus non-exhaustive when statements in Kotlin. In programming, it's very often that you'll have a class that's used simply to hold data. And so what we might have is a class called person, and it has string and a last name of string, and it doesn't maybe even have a body. It just has no properties or anything, no functions or anything like that. So this is a person, and we may define person1 as P1, and we would say person. And we say if their first name is Don and their last name is Felker. And I'm going to create two of these. So P1 and P2. Now, if I were to actually say, are these equal to each other? You might think, of course, that these are equal to each other. They have the same contents. They must be equal to each other. So let's run that here. And what we're going to see is that it's false. These do not equal each other. And if we are to print these out, we're going to see P1 and P2 actually have different little codes here at the end, which we can get to that in a later time, basically showing that, look, both of these objects are actually different. They're different. It's not actually comparing the value equality inside of them. Now, thankfully, the language designers at Kotlin have thought about this and said, well, there are times when we just want to carry data around. And so if we have a class like that, you can then use what's known as a data class. And to use a data class, you'll just slap the word data at the beginning. And then you also have to have at least one parameter. And all parameters must either be val or var. And so we've added that here. And now we can actually say print line P1 equals P2. And if we run this, we'll see that both of these values are the same. And what will happen behind the scenes is it's actually comparing the values. Now, there's a couple of things that are making this happen. The Kotlin compiler is actually creating the overriding and creating the equals operator and the hash code operator, as well as the toString and a couple of other functions, which we'll talk about soon. So if we were to take a look at the equals and hash code is what's kind of helping us with the equality here. However, with the print line, we can actually, as we remember, print line will call the toString method by default. So we can say P1. And then what will happen let's actually go back a little bit here and take this off. If we run this just as this is, as a regular class, we'll see that we have, if we do a print line, we'll see person at 494764842. So it's not too helpful. However, if this is a data class, what you'll notice here is that the data class has a toString method, which is implemented for us, which is a very nice format here, which has person, first name, last name. And let's say we add the age inside of here. So val age int, and we'll put some numbers here, 30, and let's just do the same thing, 30, and we run it again. You'll see that the print line method also outputs that parameter. So it'll actually output each of the parameters as a value in the toString method. So this is all generated for us, the equals, the hash code, and the toString. And this is how you can create a data class inside of Kotlin. Now you can also have functions inside of here. So you might be able to say full name. And this is very similar to our other user object, which we've seen before. This will return a string. And this will be returned like this. We'll say return first name, and then last name. And we can actually come up here and print the full name. And if we run it, we will see Don Felker. And of course, we can have it do other things such as this, such as name length. If we want to have a method that perhaps returns an int, and all that does is full name.length. And we can do the same thing up here, full name or name length, and that will provide us the length of the name in characters. That's the character count, so 11. And that's how you can create a very simple class in Kotlin, a very simple data class in Kotlin, and how it can perform data equality and so forth. If you would like your data class to be constructorless or seem like it's constructorless, you will need to provide default values for each of those. So you could say first unknown here, and then we can go to first unknown here, last unknown. These are just values I'm typing in there. They could be anything. And age, we could just default to 0. And of course, it's getting kind of long, so let's go ahead and put these on separate lines. So now we have our class kind of broken apart into separate lines. And then if I would like to create a P3 up here, I could very easily do it. So val P3 equals person, and I don't have to provide any values because they're all default. Now, again, I can't have another value in here, val such as foo, which is a string. It's not provided. We'll see we get a bunch of errors here, even up here, because there's no value unless I default it to something. But at that point, these are all vals. And then, of course, if we, print ln the p3, delete these, you're going to see that we have the default values that are output. So first unknown, last known, and age 0. And that's how you can simulate having a parameterless constructor in a data class. Kotlin data classes by default will generate what are known as component methods. So we have P1, we'll see component. We have component 1, which is a string, and this is going to be the first name. P1.component2 is going to be for the second item in the parameter list, which is a string. So in the order in which they occur is what the components will occur in. So this will be val first name, val last name, will equal that, and then as you can see here, we do not have any more components because that's all. So P1.component, component 1, component 2. However, if we come down here and add another item here, so val age, it's an int, and let's provide a value up here of 30 or 30. Now, if we cite P1.component, we see we have another one, and this one is an integer type because this is the third parameter up here. This is the int, so it's the third component in the parameter list. And so we say val age equals component 3, and these are generated for you behind the scenes by the Kotlin compiler. So if we were to print line all of these things out there, we could say first name, we say print line, last name, and print line. We could do age. And if we were to run this, we will see Don Felker 30 being printed out to the screen. Now, of course, we could just replace this with P1.component1 and P1.component2. We'll just copy this here, save time. It will do component 3, and we can delete these other ones here and delete all these. And if we run this, we'll see the same thing that we just saw before, Don Felker 30. So component 1, component 2, component 3. Now, if I switch this around, so I'm going to put 30 here, and I'm going to get a compiler error at first. So I'll say 30. I need to switch the parameter order down here. I can actually do this. Then component 1, 2, and 3 are going to be different. Component 1 will be Don, component 2 will be 30, component 3 will be Felker. Let's put it back to how it was before with the age at the end. And one more thing that we can actually do here too is we can actually specify these in incorrect order. So let's do this. Let's just say age equals 30, last name equals Felker, first name equals Don. And actually, let's even flip these two. Let's flip these two right here. So we're completely out of order at this point. But however, we're using named parameters, and Kotlin's going to figure that out for us in the way anyway, because this is the way that they're defined. So these are the way that the components are going to be adjusted, not in the order in which they're passed in, but in a way that they're defined in the data class. So first name is component 1, last name is component 2, and age is component 3. So even if I use name parameters in a different order, Kotlin will figure that out behind the scenes and correctly render them in the correct order with the correct components. As we can see here, component 1 is Don, Felker here is component 2, and component 3 is 30. And that's how you can work with the components that are generated inside of a data class. And they do have one more use, and that's going to be destructuring, which is coming soon. One of the main reasons for the component values that we see inside of data classes, such as component 1, component 2, component 3, is for destructuring. So component 1 references the first name, which is the first parameter as defined inside of the data class. Component 2 will be the second parameter here, and component 3 will be the third one here. This is used for destructuring. So we can say val, and we can say first name, and then we say last name, and we can say age. And then we can say equals person. So as we've defined the person here on line 2, what we're doing here is actually defining these 3 variables, and we're destructuring the person object. And what's happening behind the scenes is Kotlin is using component 1, component 2, and component 3 to shove it into these variables here. So now let's print line each one of these to see what they look like. We'll say first name, print line, last name, and we'll say print line, age. And if we run this, what we're going to see here is we see Don Felker 30. So this is great. Now this isn't based upon the name of these variables. So I could actually switch these around. I could say last name, age, first name. Now watch, if I run this, it's not going to be Don Felker 30 anymore. It's not going to print these in that way. It's going to print 30 Don Felker. Now the reason is, it's based upon the destructuring. So this is component 1. This is actually going to be the first name. So last name right here, which we print right here, is the second one. That's Don, that's correct. Then we have first name, which was actually using component 3's location, component 3. So it's going to see first name, component 3's location, which is age, which is why we see 30 printed first here. And the last thing that was printed, I have listed as the name of the age variable, is showing Felker, because that's actually the second component here. So this doesn't matter what these variable names are. So in essence, I could actually just rename these to component 1, component 2, which I would have, these names don't really mean anything. And I would never do this in production. But this is just an example that it doesn't matter the name of the actual values that you're destructuring into, it'll still print those values. So let's go ahead and move this component 1, component 2, component 3. Let's print them in the proper order again. So there was Don Felker 30. So again, I could just call this F name for first name. I could call this L name for last name. It could be, whatever casing. L name. And then we could call and this could be person age. It doesn't matter what, as long as whatever is in this is in the third component this is a third component, is going to be shoved into this variable here. And that's how you can destructure a data class into values here just in one quick line. Because if you were to do it the other way, you might have to do something like this. First name equals person dot first name val. Last name equals person dot last name. And there's nothing wrong with doing this. It's just you can also use destructuring to your advantage very easily by turning this 3 lines of code into 1 line of code. And that's destructuring data classes in Kotlin. It's very often in development that you'll need to create a copy of some data. So perhaps you need to create a copy of this person, and you'll want to create a sibling, and the sibling will then, you can easily do that with the data class with the built-in copy method. And the copy method will automatically create a copy of everything inside of the class and give you a new instance. So if we were to print this to the screen here, we would see person, and then if we were to come down here, we could see sibling, and we would run it. We would see that the 2 classes had the exact same data. Now, it's very often you may only want to change a couple of the attributes, and you can do that with the named parameters. And so I could say something like Sam. change the first name to Sam. And if I were to run that here, we'd see the rest of the data stays the same, except for the first name changes to Sam. And maybe Sam is perhaps an older sibling and Sam's age is 44. And we were to run that, and now we would see Sam Felker, age 44. Now, this is an easy way to do this. This is very useful if you have a very large object graph. So perhaps you have a person, or maybe you have perhaps a data class with a order, and that order has an amount, which is an int, and then that order belongs to, and actually needs to have a val or a var amount, and then it actually belongs to a person, which could be the customer, and that will be a person instance. So if you were to do this, you could actually come up here. Let's go ahead and create this order. So we say val order. And this order would be, and we say the amount is equal to 100, and the person equals, say it equals the sibling. Excuse me, the customer is the sibling. And of course, if we print line this, we're going to see that the order has the amount of 100. And then inside of there, the customer is that person instance with the age of 44. So let's say I wanted to copy that order. And so I say new order. And I know, let's say the customer is the same, but I just want to change the amount. I say order, and I'd say the amount is 200 this time. Perhaps they purchased a different product, but it's going to be the same customer. I could very easily do that. Oops, excuse me. We'll say order.copy, and the amount will be 200. And once we get to 200 here, we can print line that for the new order. And then once this runs, we'll see that we have another order here for the amount of 200 with the same exact customer. Now, this could also be, let's take this something, a new route here. So let's say val new order 2. I could say order.copy, and perhaps I wanted to create another order of the same exact thing, but this time I have a different customer. And this time the customer would be the person. Now I could say print line, and we could see what this would look like. And we'd say new order 2, and we'd run it here. We could actually see that the order amount is still 100, but this time the person has actually changed. And that's how you copy a data class in Kotlin, period. It's important to note that this is not a full deep copy. If you're using lists and so forth, a lot of these items will be shallow copies, so be careful copying lists this way. You can build your own data classes, but there are a couple of useful data classes built into the standard library. One is known as a pair, and it's just a pair of values. So you could have foo, and then you could have bar, and these are just a pair of values, and they're accessed via the first and second parameter values. So you can have a pair of values. So you don't have to create if you have two values you need to pass around, you don't feel like creating a custom class for it, you can use a pair. And of course, when you print line these to the screen, you're going to see that we have the following. So we have the first, which is foo, and the second is bar. Now, there's also another syntax you can use for this, and you'll see convert to 2 here. And this is a syntax using the to syntax. So basically, we have foo is going to match to bar. It's a pair. So this is another way to create a pair, is foo to bar. This is syntactic sugar over the application. And this is inside of the Kotlin standard library. And you can look at the implementation here. It creates a tuple pair from this and that. So this and that is basically the two values. So you don't have to worry about the implementation, but you can either use a pair like this, or if you want, you can go ahead and use the regular pair method like this. And we have a small error. There's our pair. Now there's another one here. If you have 3 values, you can call it a triple. And a triple is the same type of thing. So we can say foo, bar, biz, or whatever. And we have 3 values. And the same thing happens here. You can say triple, dot first, dot second, dot third. And these are all very similar. Now, they don't have to be strings. They can be whatever you want. If you want them to be an integer and you want this one to be Boolean, you could do that. And this is up to you how you would like to have them. And then, of course, as we see here, the triple dot second is going to be Boolean, as we see right here. We see the third is going to be integer. And then we can see we can also copy that because it's a built-in data class, so we can copy these and work with them as they would with regular data classes. So these are the two built-in data classes right now that are inside of the Kotlin standard library. Of course, more to come if you're watching this in the future. It's pair and triple. They're both in the standard library. Adding a protected modifier to a variable in Kotlin is easy. All you have to do is inside of your class, add the protected modifier to your variable name prior to the declaration. So here I have added protected to favorite food. Now let's go ahead and remove that real quick and see what the cause of that happens is. Back in the main file, I've created a new instance of the person class. And this person class has a favorite food property on it. So I could set perhaps watermelon. Now this works just fine, works as a regular setter and getter. I have a property that we're used to working with. However, if I were to add the protected keyword here, this now modifies this variable so it's only visible from within the current class and any of the classes that it inherit from it. So if we come back here, we now see in the main class, I no longer have access to set this value. And if I try via IntelliSense or code completion to see favorite food, we're going to see that it's not there. And the reason for that is because it's now protected. So only this class and any of the classes that inherit from it are going to see it. So let's see that in action here. Now I've actually already created another class called chef. And remember, I have had to add the open keyword so I can extend the person class. I've created person and chef. So basically a chef just extends person. Now, maybe if I have a chef class, for whatever reason, the chef can have a favorite food. So I'll say favorite food, and we're just gonna say string. And so when I create a chef now, I have to provide a favorite food. And then what I can do is I can actually set that. I'm gonna create an initializer block, which will be called as soon as we create the class. And then I can say actually favorite food. See, there's favorite food. And if I go to the declaration of it, it's actually gonna take me right up here to line 5. Now back here on line 15, I can say favorite food equals my fav food that I just passed in. So that's interesting. I can access it from within side of chef. Now, let's say for whatever reason, I don't want to allow regular persons to modify the favorite food variable. I only wanted to allow the chef to do it. So I've not really restricted anything up here. I could still come here and say favorite food, and I can still change it here. But maybe I don't want to have a public API per se that allows me or any callers to modify it. So I don't ever want the person variable. So I never want the person.favoritefood to be called. Now, if I were to call a chef, or create a chef, I would say perhaps something like this. And we could say Bob, and Bob is 33, and Bob's favorite food is ribs. Then we could see here that now I can actually set the favorite food here because this is being set right here, which in turn is being set inside the initializer block. But let's go ahead and assume that I wanted to only allow chef to change it. So I can create a function to say set favorite food, and then maybe I'd pass in the food, and then what I would do is say favorite food equals food. Now, we have an interesting error here. We're getting a squiggly line, and if we put our cursor over it, we'll see that we get an error of an accidental override. And what this is basically telling us is that, hey, Kotlin actually does us a favor here. When we declare a property up here, automatically what's being created behind the scenes for other JVM-based languages, such as Java and so forth, are variables like this. Methods like this. We have a set favorite food, which is going to allow us to pass in a value, which this is a setter, which can be string. And then there's also a getter, so an accessor. And these two methods are created simply for, it's going to return a string, interoperability with other JVM languages. Anytime you've worked in traditional Java environments, anytime you declare a variable, you need to provide a mutator and an accessor, so a setter and a getter. And this is typically the method in which you do it. You prefix the set, whatever the variable name is, in proper, of course, camel case. And then, of course, if there is a getter, which there usually is in this case, you want to get the value, you have the getter in the same format. So prefix it with the word get. So set and get, these are generated automatically for you behind the scenes. So Kotlin's saying, hey, we can't really do that. You shouldn't do this. We're already going to generate this for you, so no dice. So I'm just going to go ahead and rename it set my favorite food just for an example. So now if I go back to my main class, what I can actually do is that the chef can actually set my favorite food, and maybe I want to change that to celery. I don't know who likes celery that much, but that's beyond the scope of this. So we have a favorite food that's set to celery, but now if we try to change the food to set my favorite food on the person, well, that method, of course, does not exist in the person class. So that's the interesting thing. But what we can do is we can actually print with my favorite food from the superclass. And that's very easy to do. Say print line. And inside that print line, we'll go ahead and say the favorite food. So it's pretty simple. Now, if we were actually going to call this from the person class, p.print my favorite food, that'll work. And if we're going to do it down here, let's actually do it 2 times. C.print my favorite food, and then same thing down here, print my favorite food. Because again, I am extending the person class over here. So the chef class is extending the person class. I then can call any of the methods that are available to it, so that are not private based. And I'm calling print my favorite food. Now for the person class, this is going to show up as unknown because we are not able to set the favorite food of that person unless we're using a chef instance. So the favorite food is just going to show up as unknown. For the chef, we're actually going to see it twice. So we'll say print my favorite food, it'll say ribs, we're going to change it to celery, and then once we print it again, it'll show as celery. So this is us enabling to work with a protected variable. So if there's anything that you would like to protect from any outside callers, you want to hold some state inside of your class, but maybe you still want it to be available to other children classes via inheritance, then you can go ahead and provide a protected variable, and you can do that. And of course, this works with objects and value types, etc. Now, of course, if we were to run this, here's what we would see. We would see unknown, which is the person, then we'd see ribs, and we'd see celery. And that's how you can work with protected variables in Kotlin. You can also make a method protected as well. So we're going to use the same example here that was used in the variable protected modifier lesson. And so here we have the print my favorite food method, which can be used back inside of this main class. So again, we could say p.print my favorite food, and we say c.print my favorite food. And that's going to print the actual favorite food, which is called from the person class. Now, for whatever reason inside of your application, you may determine that you do not want this to be part of your public API. And what I mean by public API is a part of your class that can be called anywhere that's perhaps public. And this would be a public method, so we can actually access it publicly. Let's say for whatever reason you wanted to only access this within the current instance of person or any of the children classes such as chef or whatever. To do that, all you're going to want to do is slap on the protected keyword, and now this modifier was now applied the print my favorite food to only be available from within this class and from within this class. So let's go back to the main file and take a look what happened. Now we can see that the print my favorite food is protected. So what does that mean? Let's take a look here, and the autocomplete, we don't see print my favorite food anymore. However, if we were to go perhaps into the info class, here we can say print my favorite food. We could still call it from within the person class, so it gives us a little flexibility here, and also any of the perhaps other classes. Perhaps we wanted to set my favorite food and then print it to for the console or whatever. We can call it from within any of the other children classes as well. So now let's say that's what we want to do. We only want to print it when we set the favorite food for whatever reason. So we can say print my favorite food. Now we can come back here, and of course if we cannot print or have anything to do with the favorite food from a person perspective, because maybe that's just part of the given the way you're designing your application. But we can actually say set my favorite food, so we know that the person's food was ribs before, but for whatever reason we want to change it now and change it to be a potato. And so if we were to run this now, what we should see happen is, well, it's going to be set from ribs to potato, and then it's going to print potato to the screen. And we see print potato to the screen. And the reason why is because inside of the set my favorite food method, we're setting the favorite food to a different food, and then we're calling print my favorite food, which is protected inside of here. Now, of course, maybe there's no need for this to be inside of here, and maybe the food does not even need to be inside of here, which when you start thinking about it, perhaps we don't need to know anything about the person having a favorite food. So maybe we just need to move both of these into this class down here. And this would both work here. So we're going to see favorite food now it's going to have a problem here. So what is it saying? Variable cannot be initialized before declaration. Okay. So what we can then do here, we've trying to initialize it before it's really been declared. There's a couple things we could do here. So we just kind of go ahead and remove this, and we could actually remove this as well, because let's assume that every chef needs a favorite food. So to get access to this, since we're mutating it, we're going to change this to a variable. So throw the var word on there, and now we can print it, and now we can also mutate it as well. And if we go back to our main class now, we've kind of cleaned up our API a little bit. So we definitely do have our person class, and we do have the chef class, and this will still run accordingly because the person is just a shell of a class. And of course, when we print, we see potato. And what I mean by that is the person class just contains the name and the age, and it's just a very basic information about a person. And we've extended it using inheritance, and we've created a chef and added a favorite food for that chef. And this chef may also have additional methods like cook their favorite meal or anything like that, or prepare foods. And as we start building an application out, we can start separating it into different classes, yet also having values in here that are perhaps more protected, and the modifiers are in ways such that they can only be seen by children. So, which kind of brings up a good point, that if you had a chef class, well, you could also have a class, you have a sous chef class. And this one would take in the name and a string and a age and an int and a favorite food, perhaps. And this one would inherit from chef. And so we have name, age, favorite food. There we go. We can just go ahead and rename this to fav food or whatever. We'll call this fav food. And then, of course, we could have inside of here something else. We have some other classes and stuff inside of here. Or, you could actually, if you would like to, you could say inside of your in a block, for whatever reason you wanted to print something when it was created, you could do that inside of here. And so print my favorite food is not accessible to the outside world. It's not a public API. So I can't call c.print my favorite food, which is a chef. I can't call it anywhere in public because it's protected. However, any of the children classes can then still call this. So here, person is just giving us some root level inheritance. Now we've kind of created a chef class, has some stuff around it. And then we've created a sous chef class that maybe has some other things inside of here. And you might want to have something like, prep foods, methods, and stuff like that, or something that a sous chef would do. And that's how you can create a method which has a visibility modifier of protected. How do we use the internal modifier on a class? And what is it used for? It's a great question. So the vehicle class that we have here is a very simple class that just takes a color of a vehicle and then we can print it out. Now, of course, this class would have a lot more information about a particular vehicle, etc. However, let's go ahead and assume that this vehicle has some axles. So we need another class. So we're going to create a class called axle. And we're going to have a count, and this count is going to be, actually it's called number, and it's going to be an integer value, and that's basically the number of wheels. So we'll say number of wheels on the axle. And then, of course, there would be a whole bunch of other stuff inside of this axle class that would do things for us, but we're going to leave that out for brevity here. Now, we know that the vehicle is going to have a number of axles. So let's go ahead and say axles, and then we're going to have it as an array of axle. Now, of course, we don't know what that is given this period in time, so we're going to actually go ahead and apply the late init modifier saying, Kotlin, I don't know what it is right now at compile time. I'm going to initialize it later. Don't worry about it. I'll take care of it. So this all makes sense. We have a public class, we have axles, and then we might even have something else like another class, and this one's going to be a truck, because perhaps we know that the truck is going to be Of course, it's going to be a vehicle, and we need to pass in the color. And then for whatever reason, we already know that this truck that we're building, or all trucks in our application, are going to have some axles. So we say axles equal, we'll say array of, and it allows us to create an array, and I can say axle. And perhaps this first axle has 2 wheels, and this next axle has 4 wheels. Basically meaning we have 2 axles, one with 2 wheels in the front, 4 on the back. So this all makes sense. This is great. If we go back to our main class, we can easily create a vehicle as I've done here. I can actually say vehicle.axles. I can see the axles. I can say val truck equals truck, and I can pass in blue, and the truck's going to have axles I can have access to. But let's go ahead and assume for whatever reason that we do not want anybody outside of our current module to know about this axle class. Maybe we only want to expose things about the vehicles, but internally for organizational purposes, we want to be able to have a class that represents an axle. Maybe it has a bunch of utility methods that just helps us do things inside of our application, but we don't want other people to know about this class or even be able to use it. We just kind of want to keep it internal to us. Like, this is our class. It's for us to do work with. We don't want anyone else using it. There is a way to do that, and you can apply the internal modifier to the class. Now notice we got a bunch of errors automatically right out of the gate. So right here in axles, it says public property exposes an internal type argument axle, which means over here in main, if I were to type t.axles, well, we would have the ability to have that. So now this can be interesting if we don't want that to happen. So what I can do is I can actually say, hey, you know what? I don't want axles to be, I can't, basically Kotlin's saying, hey, look, you cannot expose axles because axle is internal to this module, meaning that you can use it in this module. We'll compile everything together inside of, perhaps you're building a library. We'll compile everything together, but we're only going to expose vehicle and truck because those ones are public. However, you said here's an axle class, it's internal, so don't expose it, but you're trying to expose it here, so don't do that. So in this case, what I really need to do is actually say put private axles. Now, as we see here, now we have another problem. Okay, can I access because it's private? So what we can do is then we say, you know what, let's change this to protected because we have a child class. Now we have protected, and what do we have here? Protected exposes its internal type argument. Okay, so now we have a whole different situation of maybe we don't want to expose these axles. So you have to start rethinking your API design at this point in time if you want your axles available inside of these other types here. And so maybe you don't want to do that. Maybe you want to put it as private. It's like this. So now you have your axles that are private, and then perhaps you want to say the number of axles in the wheels, and you just want to expose this as a function. So you could do that. So you say add axle, and you say number of wheels, int. And then what you could do is you could do something like this, and all this would do is it would say axles dot, and you know what, we just turn this into a list actually to make it a little bit easier to work with. We say axles dot, and we need to make this actually a mutable list so we can actually change it. Otherwise we have a read-only list. Add, and then we'll say axle, and then we'll pass in the number of wheels, and there we go. Now we can actually have that, and so if we know that we need this, we can say add axle, say 2, add axle, 4. Now what this is allowing us to do is have this axle class inside of our module, but not allow it outside of the public API. So if we are over here, now we could say t.add axle. So I could still kind of work with the axles, but it's hidden behind an API here. So I said add axle on a vehicle. So the vehicle can also add an axle. But if I were to try to do anything with that axle, such as return it, maybe I want to say, all right, well, let's return the axle, someone might think. So we say, you know, get axles. So you get axle info. And what we're going to do is we're going to return all the axles. We'll return a list of axle. Well, as you can already see, we have a problem. Public function exposes internal return type axle. So even if I wanted this, get axle info, this is not going to work because Kotlin will say, look, this is internal. You're trying to expose this as a public API. We're not going to allow that to happen. So perhaps I need to just expose some additional information. I expose them as strings, and then maybe for whatever reason, I iterate over them or whatever. Now, if I do need my class to be accessible outside, then internal is not going to work. However, it's very useful if you have a particular class where you need to encapsulate behavior, but you don't want to expose its behavior and all of its intricacies to the outside public, and you don't want anyone to be able to call it. You want that to perhaps any of the interaction with that internal class to happen through its public API, such as we're doing here in the main class. If I want to add a axle to a vehicle, I can say number of wheels, 3 or 4 or whatever. And maybe this method perhaps does a bunch of validation and a bunch of checking before it actually creates this axle class, or maybe it has to do a whole bunch of other things. That your application maybe goes out and checks to see if are any axles available at the manufacturer. Can we even add an axle right now? What is an axle, etc. So there's a whole bunch of things you can do, but it allows you to lock down your API internally. And so you kind of want to play with it and see what works best for you, but it's very useful for hiding bits of code and functionality and logic inside of your application, but still providing you with the ability to be organized inside of your module. To create an abstract class in Kotlin, all you're going to do is slap the abstract keyword right on the class itself. Now you have an abstract class. Let's go ahead and delete that though, and back at the main file and see how this impacts it. By default, classes are open, so we can go ahead and create instances of them in Kotlin. So now I have a vehicle. If I want to provide the color, which will be red, and I can create many different vehicles. So I create, call this one A, this will be blue, and I can create many more, etc. However, if I want this to be abstract, all I have to do is add the abstract keyword, which is a modifier to the class. Now, I am not allowed to create an instance of an abstract class. Now you may be wondering, why would you not want to create an instance of an abstract class? Well, if you think about it, when we're designing type systems, we have various different types we're trying to represent. In this case, we might be building an application which works with vehicles, but we do not want users of our application to create just a vehicle instance. We want them to create actual implementations of a car and a truck and so forth. And so a lot of these vehicles will have some similar things to them. For example, they may all have a color. They all may have a number of wheels. So we say val, number of wheels. They may all have various different things and doors and so forth that are all similar. So we can say number of doors as well. So val, number of doors. Now, for whatever reason, this vehicle may actually drive a certain way. So it may need to shift gears a certain way. So it may be an automatic, it might be a manual, different type of vehicle. And we may not know what that is. So we might want to actually have, if we, for example, was to provide a method to tell the vehicle how to drive. And so that function might be just be called drive. Now, this perhaps does something. Well, now depending upon the vehicle, drive can mean one thing or another. For example, in a car that's an automatic, we just step on the accelerator. As long as we're in the drive position, it drives. However, if you're in a manual transmission environment where you have to shift gears manually, well, drive is going to require a few more steps. So we cannot abstract all this information into just this class here, into abstract. So this class, we might want to actually say abstract function drive. Now I'm not going to provide an implementation here because the implementation is going to change based upon each different implementation of the class. Now, one thing that may be the same as everything else is a function called open door. And this function just simply opens the door. And all that does is open the door. Now it's going to be the same perhaps for every single vehicle you have. You pull on the handle and the door opens. Now, of course, this is different if in the real world we're going to have electric cars and electric doors and electronic doors and manual doors, but for the brevity and situation here, perhaps just assume that every door is open the same way. And so we can leave that inside of our class here. It's an abstract class. We can start having other different things inside of here, such as a function called stop. Well, what does stop do? It just stops the car. And maybe even better, say turn off. Even better, every car can be turned off, vehicle can be turned off. Let's just turn off the ignition. And if we want to be real specific, say turn off ignition. And perhaps this is going to turn off the ignition, whatever that implementation looks like is what it looks like. However, we now have an abstract class that does a couple of things for us that we don't have to re-implement everywhere else. And this is the vehicle class. This is how we can define an abstract class, but we cannot implement it. So we actually have to implement it in another class somehow. But so we can have a function that's abstract, which means, hey, whoever is going to extend this vehicle class at that point has to also implement this drive method because it's going to differ between different classes. However, they can go ahead and use the open door and turn off ignition methods. And that's how we can develop a very simple abstract class and define it in Kotlin. To implement a abstract class in Kotlin is actually pretty easy. So let's say that you want to have a car class that extends this vehicle class. So we'd have class car, and for whatever reason we can say we're also going to have a color, which is going to be string. We're going to have number of wheels, it's an integer, and number, this needs to be val number of doors. And then what you can do is you're just going to go ahead and extend the vehicle class. And vehicle, of course, is going to need that color and number of wheels and number of doors because those are constructor parameters. However, notice we have a red squiggly here. And the reason why we have that is the car class is not an abstract and does not implement the abstract base class member drive. So what this is saying is, look, maybe you can do one of two things here. You can have an abstract class extend an abstract class, so you could have this one here, and you could maybe even call this a two-door. Let's call this a two-door car. So we call this a two-door car, and I'm going to go ahead and break this into a new line here, so it's easier to read. And so instead of passing in the doors here, I already know that this is going to be my two-door sports car for whatever reason. And now I have an abstract class here, and this one I have a function here, an abstract function. And it's called drive fast. Now, of course, I don't know what drive fast means because in this two-door car, it could be a Porsche, it could be a Lamborghini, it could be any number of cars. But I know that this two-door car is going to drive fast, and how it does that depends on the implementation. Maybe it's an electric car. So that's one way I could do it. I could also just go ahead and implement a car if I just know that I want perhaps a simple town car, or let's just call it a hatchback, even simpler. Hatchback car. So it has a little hatch in the back. And then I can say color, of course, is string, number of wheels. It could be any variable, number of doors. It's going to be who knows. Same thing here. I'm going to put it in a new line. This one's going to implement vehicle, and it's going to be the color, number of wheels, number of doors, etc. Now again, I'm going to get this because I'm going to get this error saying that we have not implemented the drive function. So what I can do is implement that member, and basically what we're telling here is, hey Kotlin, I have now implemented the hatchback car. It is of type vehicle, and this one is going to drive a certain way. And so when the drive method is called, it will then call this implementation right here. Now I can have many different implementations of this car. So I'm going to actually copy this and paste it right above. And then I'm just going to call this one perhaps call this a town car. Call it a town car. And same thing, we have drive. So we have different implementations here. And this town car might do, have something different where it has a very smooth ride. And this one is a very basic, smooth. And this one is very basic. It's very just hatchback car. So you can have many different implementations here. However, in order to implement an abstract class, you also have to implement the abstract functions here. So, which is interesting. Let's go with this two-door car. Let's create some space here and let's implement this two-door car. So we've already seen how we can do it once, but now we have an abstract class that extends an abstract class. What does that look like? And so let's go ahead and implement something here. So class, we'll call this Lambo. And of course, perhaps we just are going to assume that every Lambo is going to have, so it's going to be an extended vehicle. I'm not even going to provide these things inside of the class Lambo because every Lambo that we're going to create is going to be red, and it's going to have 4 wheels, and it's going to have 2 doors. There we go, simple enough. Now we have this little error here saying, hey, look, drive has not been implemented. And actually, we know it's going to be a 2-door car, so let's change this to 2-door, and we can get rid of this right here. And now we have Lambo says, look, drive fast has not been implemented. So let's go ahead and implement drive fast. Okay, and look, we have 2 things here. Well, let's just go ahead and implement drive fast because that's what it was complaining about. And we'll say, and whatever this is going to look like is what it's going to look like. Depends on your implementation. Now we also have another error here saying, hey, the drive has not been implemented. And why is that? Well, because the drive fast method came from this abstract class, and the drive method comes from the vehicle. So because 2-door car extends vehicle and our Lambo class extends 2-door, we're basically getting the entire object that we need to implement here. So as you can see, this can be beneficial, depends on how you are developing your classes. However, it can also be very difficult if you decide, let's say you have 20 implementations of vehicle and the subclasses, or maybe there's 100, and you decide to add one abstract method to the top where people must implement it. Well, now it's gonna ripple throughout your code base, and you're gonna have to implement that in each of your child classes. So it's something to think about that you'll encounter from time to time. Sometimes that's necessary, sometimes that's what you expect to happen. Maybe you need to implement some type of method like a safety check to ensure that all of the vehicles meet a particular safety rating, and you have to implement that in each class, and that's what you need, and that's okay. However, other times you're gonna realize, well, maybe I don't need that method to be abstract, and that's going to be on a case-by-case basis. Now, over here, of course, we can go ahead and start implementing all of these. So if I want to say var or val Lambo, then I can just say equals Lambo. Now I got a Lambo. And remember, I didn't have to provide any variables there. Well, why didn't I? Because I already knew, because I said, hey, all of our Lambos are going to be red and they have 4 wheels. And since this is a 2-door car, we already know it has 2 doors. I don't have to provide anything. I already have a Lambo now. And so if we wanted to, provide a method up here, we could say what kind they are. Another thing you can also do is let's go ahead and create a couple of these other cars here. var 2-door equals, let's say town car. Equals town car. Now, of course, what are we missing? We're missing the color, so it's called brown. It's going to have 4 wheels and 4 doors. And now I have my 2 cars. And I could have multiple other ones inside of here. I've got my Lambo, I've got my town car, I've got my hatchback. I've got all these different types of cars. So one thing I could do here is create a hatchback too. So we have our hatchback car. This one's going to be silver. It's going to have 4 wheels and 2 doors. So at this point, you might realize, well, some hatchbacks have 4, some have 2. So that's why we need to have the number of doors in a way that we can configure them. So this is how you can implement an abstract class. And you can also have an abstract class extend another abstract class and implement that. And then you can see how the abstract methods and members are required inside of each individual class itself. And you're required to implement them. So for example, our Lambo here extended from the 2-door car, which extended the vehicle car. So we had to implement the drive method, and we also had to implement the drive fast method in order to fulfill the requirements of the abstract class. And basically what the abstract method is saying is like, look, we don't know what drive does, but we know that every person or every class that implements this vehicle class has to provide an implementation of drive. And the same thing down here. And we didn't have to implement it down here is because this is an abstract class. And that means like, hey, there's nobody who can create an instance of 2-door car. But if you are going to use 2-door car, then we do know that you have a drive fast method for whatever reason. And whenever you implement that, you have to also implement whatever else vehicle is asking here. So if I were to throw another abstract method onto here, so abstract fun stop. Now notice one thing, Lambo is going to give us an error, and if we scroll down, also so is town car and so is hatchback. Well, why is that? Well, simply because stop is implemented everywhere else. So I would have to go into town car, implement stop. I would have to go into hatchback, implement stop. Now here's an interesting thing. Maybe I know that all of my two-door cars, the only way to stop them is to slam on the e-brake. And so what I can do is I can implement stop inside of my abstract class here. And I can say pull e-brake, which is the emergency brake. That's how we stop these two-door cars, just as an example. So in this case, Lambo doesn't have to implement the stop method because that's just handled in the two-door car level. So I've actually can override an abstract method inside of an abstract class of the parent abstract class. So again, this stop is actually from up here inside of this stop. So you can go here and you can right click on that and you can say navigate. Excuse me, not navigate. You can go to Command U on Mac. It'll take you to the implementation of where this is at. And I think it's Control U for Windows. So this abstract class has implemented one member, but it's still passing this member down further below. So we're still saying, hey, drive needs to happen. And what we can also say is, well, maybe anytime a two-door car is driving, well, we also know that we are going to, if we drive, we're actually just going to drive fast. So anytime you drive, two-door cars only drive fast. So notice one thing. I can actually get rid of this down here because the Lambo now is using the drive method. If anyone calls drive, it's just going to call drive fast, which calls this drive fast method. So let's really see this in action. Let's go over here into our main file. And inside of our drive fast, let's go ahead and just do a print line. Driving fast. So if we have a two-door car, it's going to drive fast. And let's do another two-door car here. And let's create another one here called, let's do another one. Let's just call this one, let's call this one Honda. And maybe we're saying, hey, I like this really fast Honda. Or let's just do Acura. And this one's going to be a two-door car. Not that work. Two-door car. It's going to be blue. And it's going to have four wheels. There we go. However, we do need to implement this Acura drive fast method. So we're going to say print line, zoom, zoom. And what am I getting at with this? What we're going to see here is when we call the drive method here on a two-door car, it's going to delegate to the drive fast. Now, the drive fast has no implementation. We don't know what that does yet. However, that's going to delegate down into the actual implementation of the abstract class. So the two-door car has a drive fast method. So anytime we call drive, it'll call drive fast, which then calls the drive fast method, which is implemented in the abstract class. So let's go here and let's go ahead and create, we'll have our Lambo. We'll move that down here. We can get rid of these two for now. And then we say val Acura equals Acura. And now what we can do is we can say something like this. We can say Lambo drive and Acura drive. Now they're both going to drive. They both drive the same, whatever. They have the same abstract class. They have the same interface, so I can work with them. They're both vehicles. Now we see down here, one is driving fast and one is going zoom, zoom. Now an interesting thing that you can do here is you can start creating all different types of implementations. Now I can still call drive fast. That's not restricted. I can still say Acura drive fast. And I can still do this and everything will still work and we'll still get the same results. So driving fast, zoom, zoom. Because remember, drive, if we go to implementation, Command B, takes us to the two-door car, which is just going to delegate down to the drive fast. Now we had to implement the drive method. That drive method was from the original vehicle class. This is an accidental import. And so that's how you can create an implementation, an instance of, implement an abstract class and have it also extend other abstract classes as well. One of the more interesting things about abstract classes is the word abstract. Anytime you think of an abstract class, think about the definition of the word abstract. What does it mean? It means to basically pull something away from it, to abstract the details away. In software, when you use abstract classes, especially in Kotlin, it means you can kind of use this as an abstraction of sorts. So let's assume that we've created these 4 different cars. All of them all inherit from a base abstract class called vehicle. So we have vehicle, we have a 2-door car, which extends vehicle. We have a Lambo, which extends a 2-door car. We have an Acura, which is a 2-door car, a town car, and a hatchback. And each one of these have a drive method. So the hatchback says driving a hatchback. The drive for town car says so smooth. The drive method for Acura says zoom zoom. And the drive method for Lambo says driving fast. Notice these say drive fast. Now why don't I implement the drive? Because that's implemented in its superclass up here. And anytime someone calls drive, we just call the drive fast method because we're just going to assume 2-door cars just drive fast for whatever reason. Okay, so we have all of our cars here. Now, if we wanted to call drive on each one of these, what we could do is we could say Lambo.drive. We could call Acura.drive. Now, this is great and all, or we could even say drive fast if we know we wanted to just drive fast. However, there are a lot of instances in Power when we know that we want to rely on the abstraction. So we'll say drive vehicles. This is a method called drive vehicle, which just tells the vehicle to drive. Vehicle, and then what we're going to do is we're going to take in a vehicle, and inside of here what we're going to do is say vehicle.drive. Now this vehicle is an abstraction. We're not creating an instance of it. We're just saying, hey, this method is going to take an instance of a vehicle. We don't care what kind it is. We just want a vehicle and we're going to tell it to drive. So what we can do here is then you could say Lambo, you say drive vehicle, Lambo. Pass an instance, so I'm going to just duplicate this a few times, and I'll say Acura, and then I'm going to say hatchback and town car. Now when I run this, what's going to happen is drive vehicle is going to call in, so we're going to say Lambo. We're going to get an instance of a Lambo. It's going to call this drive method, which is going to say, all right, who's implementing this drive method? Well, a 2-door car is implementing the drive method because, well, who's implementing, okay, it's going to call drive, because Lambo is a 2-door car, and say, oh, well, I'm going to implement drive fast, which is this method. Well, who's implementing drive fast? And say, well, Acura and Lambo are. So in that case, it's going to go here and call driving fast. So if we were to run this, what we're going to see really easily is we're going to see each one of these methods, method invocations, are going to dive down and call the appropriate method. So for a Lambo, it's driving fast. For an Acura, it's zoom zoom. For a hatchback, we'll say driving a hatchback. And for a town car, it's so smooth. And so an abstract class, think of the word abstract. It allows you to abstract the details behind some type of, almost like a contract. So this is the contract of what all the vehicles are going to have. They're going to have color, they're going to have number of wheels, they're going to have number of doors, they're going to have a drive and a stop, which is different for each vehicle. And then it's those child classes can either decide to override and implement things, or if it's an abstract class, it can leave it as is and let the implementers downline implement it themselves, such as town car is doing here. Well, it needs to implement drive. So again, you could have an addition. You could extend 2-door car to be a slow 2-door car, and instead of it being drive fast, you could override that to make it drive slow. So, and then again, up in your main file here, you could still just use this method to call drive, and that class would then react accordingly. And you can start performing all different types of operations with different types of vehicles, but have them have the same type of type signatures. And that's how you can use abstract classes as abstractions on a very simple manner. So when would you want to use an interface? Let's take the simple example of you going to eat at a restaurant. So here you are. You're getting ready to go eat at the restaurant, and the waiter brings you out a menu. Now the menu I want you to think of as an interface. And what is an interface? Well, an interface is a contract saying what are the things that we can do for you. So here at the restaurant, this is an Italian restaurant, they say, well, here we can make you spaghetti and meatballs, we can make you baked ziti, we can make you lasagna, we can make linguine and clam sauce, and and shrimp and garlic and all kinds of stuff like that. And you determine the one thing I would really like is spaghetti and meatballs. And so what you're using is this contract. You're reading the contract saying, hey, what are the available options, which this menu is. It's the list of available options of what this restaurant over here can produce. And this is the restaurant. And the menu is the interface between you and the restaurant. So the restaurant says, this is what we provide. This is our contract of goods that we can do for you, or things we can build. And then what you do is you communicate through this interface here, this menu, and say, hey, I want to order this. And so you tell the waiter, hey, I want to order this spaghetti and meatballs. And so this order gets to go over here to the kitchen. And then what they end up doing is they end up making your spaghetti and meatballs, and they end up making it, blah, 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 blah. And here's all the noodles, and it kind of looks like a smiley face now. Anyway, there's your spaghetti and meatballs. And then what ends up happening from there is that gets directly returned back to you, and then you get to enjoy it, and you are now a happy camper because you are enjoying your spaghetti and meatballs. So it's a pretty good thing. All right, there we go. So your spaghetti and meatballs. Now this is the contract. Now here's the thing. Let's assume that this restaurant has many different locations, right? So this locations, you could have another location, which is over here. Maybe it's in a different town, but they're owned by the same company, right? But when you go to this restaurant, to this chain restaurant, you realize that, hey, you know what? I really like the spaghetti and meatballs. And so you go to the blue one here, which is the same company. They have the same menu. So they bring out you the menu again and say, all right, here's all the things that we have to offer. And these things, of course, are going to be your spaghetti and meatballs and your baked ziti and your linguine and clam sauce and et cetera, et cetera, et cetera, et cetera. And of course, you say immediately, well, I like the spaghetti and meatballs from this place. Again, it's owned by the same company. So again, you're going to make an order again, say I want the spaghetti and meatballs. The order goes over to here, spaghetti and meatballs. And then what you don't know behind the scenes is, well, this is just the contract. Like, you don't care how the spaghetti and meatballs are done. You just want the spaghetti and meatballs. And so what ends up happening is, maybe because of the way that the business is built or the software is built, in this instance, when I'm running over here, instead of building and making the spaghetti and meatballs myself, they actually kind of just go over here and say, hey, folks, we need some spaghetti and meatballs. And maybe they've already pre-packaged those spaghetti and meatballs before, and they actually have already delivered a box of those spaghetti and meatballs, and the spaghetti and meatballs are already pre-packaged and ready to go. And then, as you can see here, they got all these little meatballs in here, and you're ready to eat them, or they're ready to warm them up. And so at this point in time, you've just ordered this, say, hey, I want spaghetti and meatballs. The restaurants are also adhering to this contract and saying, okay, spaghetti and meatballs came in, cool. If you're at this restaurant, we make it fresh because we're the main restaurant. If you're at our other location, we've already made a bunch and kind of prepackaged it, so this location can kind of get it done because we have a special way of making it that only 2 people know how to do. And so now over at this location, what they do is they come over here and they say, all right, cool. Well, let's go ahead and take some spaghetti and meatballs here, and we'll go ahead and put it on the plate, and we're gonna warm it up, and we're gonna do whatever we're gonna do to it. And here's the spaghetti meatballs, whatever. And then at that point, we're going to go ahead and, once that's done, we're going to go ahead and deliver it back to you. And boom, there you go, right into your stomach. So now you have spaghetti and meatballs over here. The key thing is here, from a user perspective, this is the user who is perhaps consuming a library, your code, or whatever. This is your interface. Your interface says, hey, here's the things we can do. And then the implementations are these restaurants. These are who implemented the interface. This restaurant A implemented the interface, and restaurant B implemented the same interface. They both said, hey, we can both make you spaghetti and meatballs. Now, how they do that, you really don't care about. The caller of that, from the interface perspective, doesn't care about it. The caller says, hey, I want spaghetti and meatballs. At the end of the day, you know that you've just been delivered the spaghetti and meatballs that you want. You don't care how it's done. Now, behind the scenes, the implementation could be different. For example, if this is code, this code might call into a completely different module to generate something, while this code might generate it itself. It all really depends on how you're doing it. But what it allows you to do from a developer perspective is say, hey, I have this known interface here. And so anyone who interacts with us just needs to pass us an instance of this interface and call this interface, and whoever implements it over here will do whatever they need to do to return back what they want. And so you can have one, you can have multiple different implementations of these over here. You could have, we have two colors here, but you could keep going, and there could be all different types of implementations of this interface, and they could be all over the place. There could be ones up here, there could be hundreds of different of the implementations, but they all, every single one of them, adhere to the same interface, the same contract. So it doesn't matter if you're ordering spaghetti and meatballs from this location or any of these locations, they all know how to return back to you the spaghetti and meatballs that you want, all done through this interface. Now, if you take this a step further, and we can go ahead and kind of clear this thing out. Again, you have yourself over here, and now we're going to a futuristic restaurant. And this futuristic restaurant now has just a digital ordering pad. And you come in here and you get to press on some buttons. So I want, spaghetti meatballs or baked ziti or whatever. This is just an interface too. Think about like a graphical interface. This is an interface that's been implemented. Now, it depends on where you're going. You don't really care who's implemented it. You just want to know that you're going to get either your spaghetti and meatballs, or you're going to get your baked ziti, and you really just don't care where all these different types of things are coming from, because to you're interacting with whoever agreed to that contract. And then at that point in time, so for example, let's even take this a step further. You could have two different implementations of that interface. So this is going to be number one will be up here, and number two will be down here. And as you order this item here, right in this little section, so I want to order this, and at this point in time, you're going to kind of go down this path right here. Well, cool. That means I'm going to go ahead and this automatically then says, okay, that's spaghetti meatballs. We're going to go to this module and generate, whatever we need to generate. And for whatever reason, you're going down this path over here. Well, all that's just kind of, we have custom code for everything. So everything is just kind of done right here in this whole section. So what that allows you to do, the interface allows you to hide the implementation behind a particular interface. It's a contract. Like, this is the things that we can do for you. So anytime you want something to adhere to the same contract, you can do that. And that's exactly what has happened over inside of the examples here. In this case, we're using mammals. So we can have a mammal, and it can be a cow, it can be a human, or whatever. We know that it walks, it can speak, whatever. But all we know is that with a mammal interface, if I tell the mammal to walk, it will walk. Now, I don't care how it walks. Does it walk on 4 feet, 2 feet, 12 feet, 15? I don't know, don't care. I just know that it walks. And so when you have an interface, it means that, hey, these are the things we can do. To implement an interface in Kotlin, you'll type the word interface and then the name of the interface. I'm going to call this one discountable, as in something might be able to be discounted, such as a physical product or maybe even a digital product, but I just want it to be discountable. And inside of there, I can declare functions that I would want the implementer to implement. So here I'm going to implement a function called discount%, which will then return the percent amount that whatever the discounted item is going to be will be discountable. So now I have created an interface that is called discountable. It has one function. I create another function that could do something else. Perhaps I'd call it foo, and maybe it doesn't have a return type. It doesn't have to be. It might be something such as calculate something, or you could just do whatever you want to do inside of your function. So it doesn't have to have a return type, and return types can be anything you want. And that's how you create an interface in Kotlin. To implement an interface in Kotlin, you'll want to actually create a class. So you can say class. It might want to have a physical product, so we'll just go ahead and say generic toy. And this class is going to extend and implement the discountable interface. So here we have a red squiggly, and we can click on this button and say implement members, and it'll ask us which ones. We can select discount%. And then what we have to do is we have to implement whatever that value is. And of course, if we do not implement it, we can leave the default to do here, which will then, if we look at the implementation, we'll go ahead and throw a not implemented exception. So if we run it, we'll kind of get something in our log saying that this has not been implemented for later. But this is how you can implement the interface. Now, if you do add an additional member on here, so let's just call this foo for whatever reason, we're going to get a compilation error again. So we won't be able to compile until we implement that on anyone else who has implemented discountable. So we may also have another class called digital product. And digital product is also going to implement discountable, because perhaps you can discount that as well. And you will also need to implement both of these values on to both of these as well. So they'll both be discountable. And that's how you implement an interface in Kotlin. And some examples of this might be you build an interface for your file system. So if you build a file system interface, you might have something like this. Interface, we'll call it FS for file. It's very common to call file system, and I think Node even has one called FS. And we might have a method called reader, which is going to read back, and give us back a list of a list of strings called files. We could have function read file, and it's going to return us back a string. And we could have a whole bunch of other things inside of here. Now, what we could do is, I'm actually just going to rename this so it's a little bit more, makes a little more sense, a file system. Then what we could do is we could have an implementation of the file system, and we might want to call that a real file system, or let's just call it FAT32 file system, which is a real file system, and it's going to implement file system. And then what we'd have here, implement these members. And then we have to do something with each one of these members here. So we would read the file in a FAT32 method, and we would read this in read the directory in a FAT32 method. And then there's other file systems here. So let's just go and return an empty list, just so we don't get a compiler error. And let's just go ahead and return an empty string. And of course, we would read a file. The file would probably have a path or whatever, and we're leaving it off for brevity at this point. Then if we wanted to have an ext file system, so class ext file system, we could have a file system here. Same thing. We need to implement those members, and we need to actually implement the other one too. And I'm just going to leave this to do there so we don't have the error. Now this is great because we have the ext file system, we have the FAT32 file system, and we know that anytime we're working with a file system, we need to do something. Now lastly, we might have a very interesting one, which we have right here. So we have class memory file system. Why would we want this? Now this is very interesting here because we might just have something that allows us to, let's go ahead and implement these members. And we might be able to have an implementation here of memory file system where we take in a constructor here. Watch this, we say read directory. We take in files. So we take in a list of strings. And look, and what we're going to do here, and we take in the file contents, be string. And all I'm going to do here is just return files. That needs to be a val so we can actually work with it inside of the class. And the same thing down here. We'll return the file contents. So the interesting thing here is if we go back to our main application, if for whatever reason, inside of our main function here, we want it, if we were to work with just the file, the file system, so we'll say file system, and we're going to work with the FAT32 file system, right? And then we're going to do something with the file system, blah, blah, blah. We could actually say, we're going to read this directory, and it's going to read the directory. Now, this would be very pertinent to FAT32 file system. But what if we wanted our application to run on the ext file system? Well, now we're going to have to do like some if else statements to check what file system we're on or whatever. Or what could be provided to us during real time is actually a interface. So we might actually say something like this. File system, right here. Remember, this is the interface here. And we can say equals FAT32 file system. Now that still works, and we can still kind of do the same kind of thing we did before. And if we were using something like dependency injection, we could actually get this from a constructor which is beyond the scope of this, but we get it from a constructor or a setter or something like that, some variable, some type, in which, we could set that pretty easily. Now, the real power from this comes in when we determine later on. So let's actually do that now. We can actually just create a method here. So we'll call get file system. So function get file system is going to return us a file system. Return FAT32 file system. Okay, there we go. And all we can do here is just say this. File system. Get file system. Now at that point in time, we can do this. Now the interesting thing here is if this was inside of dependency injection or whatever, we could use the in-memory version. So if I'm writing a test, maybe I've just moved this code into like a helper function somewhere. And then what I do is instead of this one, I say return memory file system. And then what I do is a list of, path to file, and then another path. So remember this path, the file path, file contents. Go here. So what I'm doing is I'm actually creating a in-memory file system. I'm kind of faking the whole thing. And then inside of my application, I could say file.read directory. And then what I can do is actually give a known list of files here. And so now I've actually, and I'm enabling myself to have different implementations. This is a contract. Remember, the contract says, hey, I'm going to read a directory and I know how to read a file. And if I read a file, I'm going to get back a string. And if I read a directory, I'm going to get back a list of strings. That's all I know how to do. I don't care how it's done. But on a FAT32 system, it's done differently than an ext file system. And you know what? I may also build a memory file system which allows me to provide the values to the actual file system so I can actually basically do this in memory or for testing, etc. So interfaces allow you to separate and think of them almost like shims. They allow you to kind of really decouple your application. And so they're just a way for you to communicate. It's a known contract between you and your application and what it can do. When creating interfaces, it's very often that you'll do it in an anonymous fashion. Here, I have set up an interface called onClickListener. This is something you've probably seen in various other UI toolkits. And this onClickListener has an onClick method that is called when a particular view is clicked. And so we have a class here called view. This could be such as like a button, a text view, an image view, some type of map or anything like that. And it has a listener that's going to be assigned to it. Now we're just going to very simply here use the late init modifier to say at some point this will be called and set. And we're not doing any null checking here, so this is not production quality, but this illustrates the example. So anytime the view is clicked, it'll then instantiate the click listener, and then whatever happens inside the click listener will happen. So that's the interface here. onClickListener with a onClick method. So we have a few other classes that extend view, such as button, image, and map. So let's assume we create a button here. If I wanted to set the click listener, I could set it to an instance of the click listener if I had implemented an instance of it, in which I could do my own custom one like this class, my listener, and that would be on click listener, and then be like this. And then perhaps I want to say print line, and say clicked. And I can do that very easily by just saying new listener. Excuse me, my listener. And there we go. Now that click listener will work. And if I call button.click, the listener will now get invoked. So if we run this here, we should see clicked in the output window. There you go. See clicked. Now this is not an anonymous implementation. This is a concrete implementation. So let's go ahead and get rid of this. This is not what we want here. There's a way we can do it directly in line here. And so what we're going to do is we use this word called object. We're basically creating an object right here in place. And we'll say click listener, and then open and close brackets. And then you'll see object is highlighted, and you hit Alt Enter for Mac and implement the members. And it'll just allow you to implement that member, which is on click. And then we can just do print line here and say this was clicked. And of course, now if we run this, what will happen is this basically created an inline object here. We've done an inline object, which is an implementation of the onClick listener directly in line. And it was called here and directly set up accordingly. So that's how you can create a new instance of that. Now, sometimes you'll also see methods perhaps that allow you to set listener. So just say set my listener, we'll just call it that. And this is going to have a click listener, and this click listener is going to be this dot click listener equals click listener. And so it basically says this one is going to be set equal to this one up here. And so that's another way you could do that there too. So inside of here, we could say button dot set click listener, which is a method now. And so I could actually just cut and paste this out of here. And the same thing. I'm going to use an object. So object colon, the name of the interface, open and close brackets, and then implement the required methods in the middle. So the abstract methods, in this case on click. And an instance of on click listener will be anonymously created and set into this value here. So when the click button is called, it will then say this was clicked. And just to show some differences here, we'll say this was clicked ABC. If we run this again, when it gets to button.click, we'll see this was clicked ABC. Now, the same thing happens here for the map and the image. So you could then very easily and say map. So val map equals map. And you could say map.clickListener equals, and you could do the object thing here again as well. You say on click listener, and then open and close brackets. And there you go. And then you can do something inside of there. And then of course, if the map was clicked. Now what this allows you to do is have the very common interface, the contract of when a view is clicked, it'll just invoke a function, and then you get to decide what to do when a map was clicked, or what to do when this particular button is clicked. And so this is a very common pattern you'll have seen inside of various UI platforms. So that's how you can create an anonymous interface implementation in Kotlin. You can easily create arrays in Kotlin. So let's do that real quick. We'll create a variable called items, and you can say array of, and then you pass in some primitives. So we can say 1, 2, 3, 4, 5, and then we can do something with that array. So now we have an array of integers. So we can say items dot for each, and what we're using is the extension function on the array class. There is a for each extension method built inside of the arrays, inside of the Kotlin standard library. And so what that allows us to do is pass in a lambda expression, and we can actually just do a print line with the value. So we can say for each, and print line will then provide the, take a value and print it to the screen. IT is the default name of the item inside of the lambda expression. If we want to change it to something different, we could change it to maybe the word value, and we would do so like this. And then at this point we can say value. Now that doesn't really provide us any additional benefit here. If I hit Alt Enter, we can see that we can replace the explicit parameter value with the name it, and this just kind of cleans up the code a little bit. Now once we run this, what we'll see inside of the output window down here on the bottom is all the integers have been printed out. Now an additional cool thing with some of the built-in array classes of Kotlin is we can also have an int array. So by default, we'll specify, hey, we would like some integers. We can also have a double array. And notice this is going to create a problem here because these are not doubles. But if we were to turn them into doubles by providing a .0, so it is actually a valid double value, we can then at that point start using the double array of call. There's multiple other ones in here as well. So we have the array of, double array of, float array of, long array of course the int array of, char arrays, short arrays, byte arrays, and Boolean arrays. Now you'll notice we don't see a string array in here. So what do we do there? So that's actually pretty easy. We can actually just do array of, and then we actually provide some values in here. So Don Felker would be a simple array of 2 items. And if we were to run this again, it would just say Don Felker, 1 string on each line. Now, that's not all we can do with some of the arrays as well. We can also get an array of objects. So we'd say array of, and what I can do here is, since we have our user class, which if we remember that, it just has a first name and a last name. What we'll do here is we'll have user, and we'll say Don Felker, And then we might have another one called Jane Doe. And now we have two users who are part of the user array. Let's actually call this users. And then at that point, we can actually do the same thing that we saw before, and then we can iterate each over one of them. And we'll call print line, and we'll call this IT. Because remember, IT at this point is just a user itself. Up here, it's going to be a string. So the compiler is going to know that if we run this. Now we're going to see the toString value of the user class. So let's go take a look at the user class again. And the user class, I've added a quick toString implementation. I've just created an override, so of toString, and we can go ahead and return something. Now it's full name, and it just returns this string up here. And that's how we can work with strings and primitives and objects and easily create arrays of them and alter them and so forth. Now let's assume that for some reason, we needed to update the users and we needed to add one to it. So what we could do is to say file updated users, and we could say users.plus, and they're going to add a new user to it. And we say John Doe here. And what this will do is if we take a look at the plus implementation, what does it do underneath the hood? It's just an extension function that creates a copy of the array with a one larger index, adds the item at that given index, and then returns that new array. So we have to make sure we're using that new array. And so of course we could do updated users.forEach and it's a print line. And then what we could do inside of here is just say IT. And now we'll actually see if we run this again, we'll see an additional person down here, John Doe, has now been added to the second array, which is these three down at the bottom. Now there's other things you can also do with those user objects. So you can actually say users dot, there's other extension function on here. So you say reverse, this will give you the reversed array. There's a whole bunch of other collection classes you can do, and which we'll talk about in the future here, and so forth. But you can also get the size. You can get a particular value at it. So if I want to get the value at item number 0, the location, and I can say print ln, and I can say item. That's going to be at that point item 0 is going to be Don Felker. And then if we run it, you'll see that it's just Don Felker's printed down here at the bottom. Now you'll see that we have a squiggly here because we can actually use the indexing operator. So we'll place that and we can actually do the same thing here that does the same exact method. We can set a value. So if I want to set the index of 0 to be a different user, so I can say foo bar. And then if I were to go ahead and get that, and if we look at the implementation of set, you'll see it's just going to return a unit. So we don't want to do anything with this anymore. So now at this point, we'd want to actually get the value again. So we'd say val item equals users dot, and we'll just use the indexing operator instead of the get. And if we were to run this, we'll see here that the item that's printed down the bottom is foo bar because the first item in the array was updated. Now again, we see a squiggly here. We can update this with an indexing operator again. So we're going to say, hey, the first user is actually going to be equal to this. Go get that first user and print it at that point in time. So there's all different kinds of stuff that you can do with arrays. You can add things, you can get copies, you can reverse them, slice them. There's a tremendous amount of things you can do with these collections, such as the other collections in Kotlin, which we will cover. And that's how you can work with arrays and build them quickly in Kotlin. To create a list inside of Kotlin, it's pretty easy. You can just say, let's create a variable here, and we say val items equals list of, and then you can provide a list of, perhaps a list of primitives like we have here. So we have a list of integers. This is very similar to how it's done with the array of operator for arrays. So if we want to loop over each one of these and print them out to the screen, we could say something like this, say items for each, and then once we compile this and print it and run it, it will then print to the screen as we see in the output down here, 1, 2, 3, 4, and 5. So we have a list here. Now this is important to note here that this is actually an immutable list. So if you notice here, I don't have the add method here. I can't add an item to the list at all. So if we look at the implementation of list of, we'll see that here that's going to return a new read-only list. So that means that we cannot add items to it. The same thing goes for if you were to create a list of, perhaps a list of users. So let's say list of, and then we could actually create a list of users. So I'm just going to do a new line here. Say Don Felker. And then we can have another one would say user would be perhaps Jane Doe, and then so forth. We could have a number of them and so forth. And of course, we could also iterate over these as well pretty easily. So we'd say users.forEach. And inside of this, we'd say print line. And inside the print line, we could just say, we could print the user. And that's going to call the toString method on the user, just like it did when we did the array version. So we'd see Jane Doe and John Doe. And I actually did print here. I didn't do print line, so I'll put it on the same line. Print line will add each item onto a new line as we see here. So again, these are immutable lists. If we want to add an item to a list, we're not going to be able to do that. So we have to create a mutable list, which will be in the next lesson. So here we can also get access to items. So maybe we want to do the first item. We could say users.first. And it's going to give us the first item. And notice the first method, this is an extension method on top of a generic list. So we have a first item. So if for some reason there was a default, if we were to print this here, let's actually do print line, just to show you what this looks like. We should see Don Felker again printed, and there we go. Now there's also the opportunity here for us to perhaps maybe we need to create an empty list for whatever reason. Maybe we have a null value or something like that. So let's say that we have a name. So let's say val name, it could be a nullable string equals whatever. And for whatever reason, the code is null. And then we want to create a new list, and we could say stuff. We could say it's going to be if the name is null. So if we want to do something like this, we put it around the if statement. So if the name is null, then we could return an empty list, and that would just return us an empty list. Otherwise, we can then return a list of name. And what that's going to do is automatically the compiler is going to infer, since Don is doing a list of name, it's going to be a list of strings. Otherwise, this is going to be an empty list of strings. Now notice here, I was getting a compiler error because it doesn't know enough about the type here. So if I wanted to specify the type for empty list, I could actually say string there, it would work. And we could say list of name. Now, at this point in time, you can see that this is grayed out because the compiler can infer the type. So it can go ahead and remove that explicit type argument. Now, empty list, all it is, again, is just a function. It just gives us an implementation of what's known as an empty list. It doesn't have anything in it. There's basically the size. If you look at it, the size is 0. Is empty is hard-coded to true. So this is just kind of a general helper method inside of our application. So if we were to see if this was empty, we could actually say stuff.isEmpty. That would return true. We'll see a bunch of different other methods on here as well. We can see if a list is empty. Again, we can't add anything to it because it's an immutable list. So that's one way we can work with the empty list. Now, we can also grab the last item of a list. So we can say users.last. And that will give us the last item of the list. And at that point in time, we can also print that to the screen, which is going to go ahead and show Jane Doe at that point in time. And there we go, Jane Doe. So there's a bunch of different operators on the list you can look at. So you can just say users, and you can use IntelliSense in code completion to check it out. You can do last with a predicate, all different types of stuff, which we will cover in the future. And you can also get the first value or null if it's nothing's there. So we'll see here. Returns the first element or null if the list is empty. So there's a bunch of different things that you can check for there as well. And that's how you easily can create a list inside of Kotlin with either primitives, or you can create it with objects. In another lesson, I showed you how to create an immutable list using the list of method. The list of method allows you to create a list of some primitives or objects or anything of that you desire. If you'd like to create a list in which you can change, because let's take a look at this, items does not have an add method. We can't add or change or remove or do anything of that nature with an immutable list. It's just there. It's can't be changed. If we need to create a mutable list, we can do so with the mutable list of. And if we use mutable list of, we can provide a type if we'd like to, such as we can do with the list of operators. So if I know it's going to be int, then I can do that. And I could say 1, 2, 3, 4, 5. But then what will happen is type inference will kick in and the IntelliJ IDE will let us know saying, hey, we don't really need that explicit type argument. So let's go ahead and remove it. So at this point in time, based upon the parameters of the mutable list method, Kotlin can infer the types for this list. So now I have a mutable list of items. Now this works the same way if I have a list here. So if we just do list and we leave that, we'll notice that both these things are going to compile just fine and do the same thing. We have the same method for each. We can print those. The difference is here though, is that we can add an item here. So I can add the number 6 now. And then if I copy this and I kind of reiterate over this again, we'll see that I have 6 in here. So let's go ahead and print a line here so we can see that there's, something different. And let's run this. And what we'll see here is we print 1, 2, 3, 4, 5. And then I'm going to add an item here on number 6. And then I'm going to run it again, say 1, 2, 3, 4, 5, 6. So we can also do something else and say, we can say items.remove. And we could say a whole bunch of things here. We could remove, if we meet a particular condition, we could remove all the items. We could remove a particular item. So I could remove element number 0, and we could print this off again. So what would happen here if we were to run this? So now we have a list where we have, to make this a little more clear, let's add this in here as well. And we'll run it again, and we'll see here that we have now 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Well, why didn't we get anything out of here? It's because we're asking it to remove a particular item. Now, it's not finding the item 0 in there. So let's tell it to remove number 3. So let's run that again. And then what we'll see down here in the bottom window is it was actually found item number 3. So it didn't find 1, 2, or 3. It wasn't the index base. It was actually the item in the list that was removed. So that was able to be removed out of there. Now there's a whole bunch of other things now. We can replace items inside of here. We can replace all. We can add a whole bunch of them. So if we take a look at the implementation of add all, we can take another collection and add another one inside of here. So we can add a whole bunch of them. So if we have another list, we can add that list to it. We can remove something out of position. So let's say we want to remove this at position 0. Let's run this and see what happens. Now notice how this says index. So now we have 2, 3, 4, 5, 6. I'm just going to delete this stuff here just for brevity. And we'll run this again. And we'll see that we have 2, 3, 4, 5 is printed. Now if I were to change this to remove, just to reiterate here, and we could say we want to remove a particular element. I want to remove element that is the value of 3. Now we're going to see 1, 2, 4, 5 is the output down here in the bottom. So remove at removes it with an index. So inside of the index of the list, we can find something to remove. However, if we want to remove an actual item given its value, we'd say remove element. Now we can also say, we can do something with mutable list of objects as well. So we can say user Don Felker, which is something we have done before with the other types of list. And maybe we just have a user called Jane Doe. So now we have 2 things in here. And if we try to remove here and we use I'm using an index here because it's the number 3, even though it's saying, hey, you're wanting to remove something here. Removing int is an error. Use remove at index instead because it realizes, the compiler, that I'm trying to use a number here. So it's trying to help me out saying, hey, you sure you don't want to remove a particular index? Now what I could do, let me just go ahead and comment this out for a second. Inside of here is let me run this to show you what this looks like. We're going to get basically 2 users printed. If I wanted to pull this out into its own variable, I could do that and say pull it into a variable, and I could say Don. Now what I could do inside of here is I could say remove Don from the list. Now let's print this list and see what happens. What do you think we're going to see here? We're going to see we just have one item in the list, because what happens is we have these items. So let's actually do two things here. Let's do this. We'll print each one of there. And then inside of here, we're going to do a print line, and we'll just print out a little break there. And what we're going to see is both items are printed first, which we see here. And then we print this nice little line break. And then we say, hey, I want to remove Dawn from the list. Now remember, remove removes the element. It's going to tell the element that we'd like to remove. Remove at is going to tell us we want to remove an index. So I can say, hey, if I want to remove index 1, it's going to remove Jane Doe. Now if I run this here, we're going to see Don Felker and Jane Doe, and then we're going to remove Jane Doe, and it's just going to say Don Felker. Now there's a whole bunch, again, this is a mutable list, so I can continue to add and remove items accordingly, and the difference is it's mutable, it's changing. The other one is immutable. So if we want to do different types of things with it, you can inspect the various different operations using the code completion here. We can remove it at, we can replace things, we can set certain values. So if I would like to set the first value to equal a different user, I could say different user is now going to be John Doe for whatever reason. So let's go ahead and change that and get this down here. Now what we're going to see at this point in time is I'm going to set the item 1 to John Doe. So the first time through, we're going to see Don Felker printed. And then the next time through, we're going to change the first, the item at index 1 to John Doe. So we'll see Don Felker, Jane Doe. We change it, and then it's Don Felker, John Doe. Now notice we have a little bit of squiggly here. Alt-Enter, and we'll say we can replace the set call with an indexing operator. So using the indexing operator, we can say actually take the first item in the index and replace it with this one. So it's the same exact code. This does the exact same thing as this. Now, we can also access these items via the index as well. So I might say print line, and I might want to do items 0. And that's going to print the first item. Now that's going to be the same exact thing as if I were to do a items.get, and I can provide the index. Now notice again, we're going to get the squiggly, and what IntelliJ is telling us here is that, hey, we can actually use the indexing operator. So go ahead and do that. Now that's how you create a very simple mutable list inside of Kotlin. You can create a mutable list of primitives, could be strings or integers, or it could even be something like an object itself. All right, I'm going to show you how to filter a list of primitive values here. I'm filtering a list of strings. This could be integers, doubles, longs, Boolean values, anything of that nature. But I've created a list using the list of, so this is an immutable list, list of names. So we have Don, Bob, Jane, Jenny, Tushar, and Kavita. Let's assume that we wanted to filter this list, and we only wanted to include everybody but Don this time. And so we would say names.filter, and then we can pass in basically a lambda expression. So there's a couple things we could do. We could do open close parentheses, and we need some type of predicate. If we look at the implementation of this inside of the Kotlin collection standard library, we'll see that we have the filter method, and we need a predicate. And this predicate is requiring a lambda expression that's going to return a Boolean value. Basically returns a list containing only the elements matching the predicate. So if it's true, it will be included in the list. If it's false, it will not. So what does that mean? Anything inside this filter we pass in, which I'm going to use the lambda expression version, if this equates to true, what happens inside of here, it will be included. So this is pretty easy. Using the default iterator value of it, I say it does not equal Dawn, it'll be included. So what this means is I want to look through all the names and filter it and check to see if it doesn't equal Dawn. If it doesn't equal Dawn, then include it. So how can we tell if that worked? Let's print this to the screen, and we'll say filtered. And once we run it, you're going to see that down here in the output window, we'll see Bob, Jane, Jenny, Tushar, and Kavita. So Dawn was not included. Now, we could also flip that around and say, you know what, we also only want to include the names if it includes Dawn. So let's do that. Say filtered, does it equal Dawn? So here we're going to get back an array with one value in it, which is going to equal Dawn, which makes sense. Okay, it's good enough. But sometimes maybe inside of your application, again, this is a predicate. A whole number of things can happen. This could be a bunch of code that's doing something inside of here. But let's assume that you want to check to see if anyone has a letter A in it. I only want to see if someone has a letter A. So what we might do is say it.toLowerCase. It's because I want to check for lower uppercase dot contains a character, and let's see if it contains the letter A. If it contains the letter A, I want it to go ahead and return it. So let's see what happens here. If we run this, we'll see we get returned Jane, Tushar, and Kavita. That's right, because Don, Bob, and Jenny do not have the letter A inside of there. So you can start filtering based upon all different types of things. And the same thing will work if you had a list of ages, such as this. And then you wanted to actually filter them, so you'd say val over 18, or you say adults, which can be over 18, and you'd say ages dot filter it dot greater than or equal to 18. We'll print line that, and we could see the adults. If we run this, we'll see that we have 23, 33, 19, and 99, which is true because if you're 12 or you're 9 or 17, you are not an adult. One additional thing you could do is actually create a function called isAdult. And perhaps this function has a whole bunch of things inside of here. So we want to say age, which is called value. Let's be int. And then inside of here, say if the value, so we'll say return value greater than or equal to 18. And again, this is going to be Boolean, so we need to return a value. So this function will return if this person is an adult. But now let's assume for whatever reason you have to put a bunch of if statements in here. Maybe in one country an adult is 14, in the next country it's 21, and in the next country it's 18. So you might need to have many different lines and logic inside of here, but it's going to return a Boolean value. Doing that inside of this filter is going to get real messy. And so what you can do is you actually pass a function reference into the filter. And you can do this with a lot of the methods inside of Kotlin. So here it's an age filter, so it's a colon isAdult. And what this will do is it'll take this as a function reference and say, as soon as I say ages.filter, it'll basically pass in the values one by one into the isAdult function, and then we'll run it through everything that's inside of here. And then whatever the result is, if it's true, it'll be included in the filter. Otherwise, it'll be excluded. So if we run this again, we should get the same result as before. So we see 23, 19, 99. Now we could change this. And so we could change, if we want to say is adult, we say is child. And we probably need to fix the spelling of that. And then we can say less than or equal 18. And if we rerun this again, and of course, this variable name is wrong. It's not adults. It should be children. Okay, and run it again. We'll now see 12, 9, and 17 for the ages of filter. So that's how you can easily filter a list, an array, and so forth in Kotlin. Let's assume you have a list of data and you want to find something in that list of data. This could be primitives as we have here, such as a list of strings, or you could have a list of objects, anything of that nature that you want to filter, not filter, but just find a particular item in the list. How can you go about doing that? Of course, you could use a for loop. However, there's also built-in utilities in the Kotlin standard library. So what we're going to have is I'm going to create a result variable. And then what I want to do is I want to actually find the first instance, names.find. I want to find the first instance of Dawn. So let's go ahead and say it equals Dawn, and then I want to go ahead and print out if I actually found it. So print ln and result. And I'm going to go ahead and run that. And then what we're going to see here is that we have Dawn that was returned. That's what we expect. Dawn was in there. Now, however, there is a kind of a gotcha here. So let's just throw something in here we know doesn't exist and let's run it again. So I'm going to use the word foobar. Now, we have the word foobar. Of course, we're going to get back null. Now, we kind of had some help from Kotlin to find this here. So we had find. It's going to find the first one. And if I actually look at this, what it's going to do is it returns the first element matching the given predicate or null if no element is found. So find kind of helps you, but now you have to start worrying about null values at all times. So if you're going to do a null value, you say, so if you want to compare something, result equals, or you say result dot length, well, now you're going to get a problem here because it's saying this is a null variable. So you need to check to see if it's null first. You may have heard too that Kotlin will protect you from null pointer exceptions and doesn't allow you to do nulls. Well, that's false. As you can see here, we can use a null. However, I prefer to use things like first. Now first will actually give me the actual value first of Dawn. And so if we run this here, it's telling me, look, I'm always going to get a variable back. Now if I run this, I'll say result.length, it'll be 4 because Dawn has 4 characters in it. Now the real interesting part comes in here. It equals foobar, which we know foobar does not exist in this list. But if we run it again, what we're going to see is we're going to get an exception from Kotlin, and that's the no such element exception. If we look at the implementation of first here, it says it returns the first element matching, or it'll throw an exception. So this is something you need to be aware of. And I prefer to use this method because now I actually have a string that's going to be returned if it's found. Now, but what if I want to find the first or the null value? I feel that's a decision I need to make because I need to be able to read the code and know that, hey, I'm either going to get the first one or a null value, because that gives me context into understanding what's happening in my code. As regards to find, it does make sense, but it's not as obvious. It's not in your face. So first has also one called first or null. So I'm going to take first or null. And now again, we get back a string here that's going to be empty. So I'm just going to go ahead and take that off there just because it's not going to work. And we'll print it and we'll see it says null. Now, of course, I could do the null operator check. The null safety check, dot length. Otherwise, I could just go ahead and do something else, do that. That should work. And there we go. We get back null because there's no values there. So I can find the first instance of it. So what this also means is if I have another instance of Dawn in here, or actually no, let me say this to say, Donovan. Let's say we have Donovan in here, right? And I want to see the first instance of, watch, so I always say first, of dot contains, so we'll say dot to lowercase, dot contains Dawn, right? So I want to find the first one that it's going to find in that list. So what is it going to find? Well, it's not going to find anything. So let's go back to the result here. I'm just going to get rid of the length. First, it dot to lowercase contains Dawn. And that's not going to work because I have a capital D there. We'll run that, and now we'll get back Dawn. But we actually have 2 instances in here. So what if I wanted to return the last instance? We can do last. So there's a last operator. We can find the last instance of a list. Donovan. So there's many different things we can do inside of here. We can find names.index of, and what we're going to see here, index of first, index of last. So I can get the index of the first, and what is that going to return? That should return us a 0. And if I do index of last, I can do index of last. It'll show me the last value here. And then of course, if I were to throw something in here in XYZ, what do we think would happen here? We're going to get -1, so it's not found. So if you look at the implementation of that, or -1 if the list does not contain such an element. And this is all within the Kotlin standard library. So there's a number of things that we can do to find values inside of here. And just like we had the last before, we also have last or null. So we can also take last or null as well. So we'll just change this back to Dawn. And we'll see the last or null returns us back with Donovan. And then if we have Dawn X, which there's nothing in there with Dawn X in there, it will return null. So we got a null value at that point in time. Now, the great thing about it is I can read this code 6 months down the line and understand that I'm filtering the names list and I want to find the last value or give me null. And then at that point, I know exactly what to expect at this point. I'm either going to have the value or I'm going to have null, and I need to plan for that accordingly. Now, thankfully, Kotlin's not going to allow me to just print the length of this because this is a nullable type. And I need to basically say, hey, what happens if this is null? And I'll just provide the null safety operator, which says, hey, if this is null, just return null. Otherwise, give me the length. That's what that means. You can filter to include certain things, and you can also filter to exclude certain things. So for example, if we wanted to have the result to include everything from the list except something, we could have used a inequality expression inside of our predicate, or we can just use a names.not filter not, and then we could say it dot contains the letter A. And what this will do, it will print line the result, and this will go ahead and include everything that doesn't have the letter A. So in this case, we're taking the list and we're filtering it to not include anybody who has a letter A in their name, which is Don, Bob, and Jenny. And that's how you can use the filter not, which is basically the opposite of filter. So if we include filter here, we're now going to see the folks who have the letter A in their name, which is Jane, Tushar, Kavita, and Donovan. So you have filter and filter not, which are basically the exact opposite of each other. Or you can also just use inequalities inside of your expression. It just really depends on what makes sense for you and your code readability. I prefer to actually use the different variations, so filter and filter not, because it's very readable and I have to do less thinking and cognitive load for me in regular development. And in 6 months from now, I can read it as just kind of regular English. And that's how you can filter and not filter. You can easily take one list and then take some values out of it and drop it into another mutable list with the filter_to command. So we can say names.filter_to, and then you have to provide the destination, which is going to be where you want it to be applied to. And this has to be a mutable list, which is the approved list here. So let's take the use case of you have an approved list of people that are going to be on the guest list for a particular event. And you want to randomly choose some more people out of this other list. And perhaps you want to say anyone who has the letter A in their name, we're going to randomly choose them. Not a really fair randomized assessment, but it does work. So we'll say print line, and then we'll say approved. And what this is going to do is going to take anyone who has, not take, just kind of say anyone who has their name A, and we're going to append it to this list up here. So if we run this here, we'll see Danielle, Paul, Jane, Tushar, Kavita, and Donovan. And so that's how we can take one value, so a value here, which is a list of names, and say, hey, if anyone in this list has the letter A or whatever this predicate is, that again is true or false. This could be a very complex, if-else switch with a bunch of things happening behind it. If this returns true, then include it and drop it and add it to this mutable list. Otherwise, don't. Now, we can also do the opposite too. Filter not to. And what this does is say, all right, if you don't have the letter A in your name, well, now we're going to move you into this list. So it's the exact opposite. So we have the inclusion and exclusion. So now it's Danielle and Paul. They have already existed in the list. But now we want anyone who doesn't have a letter A in their name. So Danielle, Paul, Don, Bob, and Jenny. So we're going to take anyone who doesn't have a letter A in this name, in this list, and apply it to this list. And so that's how you can easily filter from one list into another list. Now again, the list has to be mutable. So if you were to change this to just a regular list, which is an immutable list, this is not going to work. As you can see here, the error states that a required collection must be mutable. So we need to change this to a mutable list of, and we can get rid of the type parameters there. Again, if you wanted to provide them, you could, but we don't need to because it's already being inferred. And that's how you can move things from one list to another using filter_to and filter not to. Sometimes in code, you'll find yourself having a list of arrays or basically a list of lists and an array of arrays. So let's start with the top example here. We have an array of, think of a bunch of people bringing a bunch of their fruits together, and we're going to have a party, and everyone's going to bring all their fruits, and we're going to combine all of our fruits together, and I need to see which fruits all of us have, and we're building an application for this. So mine, I have apples and grapes. Theirs, they have oranges, pears, and strawberries, and there's the other people are bringing a kiwi and a watermelon. So I need to see exactly what I have, and so I am going to combine all of those together, all these arrays, because maybe they've come into my application at different periods of time. And so I have these three different arrays, and now I have an array of arrays. So basically I've created a list of arrays, a list of lists. So I have a list of mine, a list of theirs, and a list of. And now if I were to print this, it would show an array, a list with 3 items in it. And this one, the first item, would have 2 items in that list. The second one will have 3 items in that list. And the last one will have 2 items in that list. Now there's actually a method called flatten. And what this will do is it'll take all these values and flatten them out and basically put them into one list. So I'm going to go ahead and comment this out so we can run this. And you'll see here that down we have, when we print this, these brackets indicate a list. So this is one of the lists. This is the next list right here. And this is the last list here with the kiwi and the watermelon. And of course, the whole thing is inside of one set of brackets here, which represents that the whole thing is inside of a list itself. So it's a list of lists. Kind of a mouthful. Now, when I call the flatten method, what it does is it just takes all those values and flattens it into one list itself. So I'm able to combine all of these lists if they're inside of one master list and flatten them out. Now you can do the same exact thing with arrays. It's the exact same thing. We'll have an array of arrays here. And so we have an array of the same exact things. Instead of using lists, I'm just using arrays. And I'm going to call the same exact method on it. And so I'm calling flatten. And both of these actually do the exact same thing. This one is going to be iterating on a list, and this one is going to be iterating on an array. So you can see they are different. There's a different code. So see line 19 inside the arrays file, and then we have line 69 of the iterables file. So it is different code, but it does the exact same thing in our use case here. And so we're going to take arrays, and if we run these here, what we'll see is the top 2 lines will be for our lists. So we have the list up here. And the next one, this is the array of arrays, and it's printing out that, hey, there's a bunch of strings in there, and then it kind of stopped printing. And then it flattens them out into one large array. So that's how you can go ahead and flatten an array of arrays or lists of lists inside of Kotlin. Let's assume you have multiple lists that you need to combine in Kotlin. These are all immutable lists, so you cannot mutate any of them, but you would like to combine them and have a list at the end that contains all the items. It's fairly simple. All you need to do is you have a variable. And you actually don't need a variable if you're just passing this. You can just say mine dot plus theirs. This is going to return a new instance, and then you can say dot plus others. And this is going to return all of the values concatenated together. So if we were to run this, you now see that the result contains apples, grapes, oranges, pears, strawberries, kiwi, and watermelon. So we've combined all of these immutable lists into one final immutable list. Furthermore, you can do something interesting. You can also, if you have this list and you want to remove a whole bunch of items from it, you could do this. You could say minus, and you could remove a bunch of items. So maybe you want to remove theirs from that list. And what you're going to see here is our result now is we're going to take out theirs. We're going to remove the oranges, pears, and strawberries, which on the second item here, we've removed the oranges, pears, and strawberries. Now, the minus operator does allow you to do a whole bunch of stuff. You can pass in an iterable, you can pass in some sequence, you can pass in an array elements, and you can also pass in a single element itself. So if you just want to remove one item and you just want to remove kiwi, and you were to run this, now you would see that at the end, that kiwi would then be removed. So you can pass in a list or an exact element to be removed. So that's how you can concatenate lists together inside of Kotlin, even if they are immutable. One of the most powerful operators in Kotlin on a collection is going to be the map operator. So we have a list of names here. Let's assume that we wanted to take the first 3 letters of each name, make them uppercase, and make that the abbreviation for the person's name. It's a pretty rudimentary example, but let's go ahead and try to do that. We could use a bunch of different loops to do that, or we can use the map operator. So I'm going to say items.map, and what this allows us to do is pass in a lambda function. And what we can do here is start doing something with. So it is going to be each name in the list. And then we could say substring, we're going to say 0 to 3, so get the first 3 letters, .to uppercase. Now what this is going to do, map, is going to return a brand new list. So it returns a list containing the results of applying the given transformation function to each element in the original collection. Okay, what does that mean? What that means is for each item inside of this list, when we call map, it's going to execute a function. It's basically going to give us that value, and then whatever we do with this value, it's going to return this back. It's going to return whatever the result of this is back. So let's print it off and see what happens here. All this substring is doing is taking the first 3 letters of the name and making it uppercase. And so as you can see, the result is Don, Jan, Car, Pet, and Claw. for the 3 letters of each of these names up here. Now, I could just completely ignore it and just say foo. Now watch. If I run this, we're going to see foo over and over and over. The reason why, this map, this function is executed every single time. So it's executed for Don Felker, it gets foo. For Jane Doe, it gets foo. For Karthik, it gets foo. For Peter, it gets foo. For Clark, it gets foo. It just executes each individual time. So here, I'm just returning these values. So at this point in time, I'm going to get those first 3 letters. Now, we could take this a step further. And we could say, all right, well, we can break this into multiple lines. And say, let's say I wanted to get the initials off of everybody. Now, there's multiple ways that I could go about doing this. Now, what I could do, this is a very naive approach, but it works. I could say it.split, and I want to split this on the space, and now I have some words. And then what I could say is I want to return, basically, the words, the first word, and then I want to substring that one. And that's going to start from 0 to 1. Basically take the first letter of the first word plus words.substring. The second word dot substring. And take the first letter of that one as well. And so we're going to see here type mismatch. It says found string required unit. So I actually need to just do this. And you may notice, like, why am I not returning it? Because what happens inside of the map is the last value is what's returned inside of this map, which is why it's pointing with an up arrow and it says map inside the IDE. So this is a little hint. It says, hey, this is the return value of the map operation. So now if I were to run this, we're going to see that it's just going to return back the initials, DF, JD, KM, PP, and CK. Now, this is not production quality code. If the user has multiple names and multiple spaces in their name, this is going to fail. If they only have one name, this is going to fail. So this is not production quality, but this just illustrates something that you can do inside of the map operation. So let's go ahead and you rewind this a little bit here and go back to where we were before with the abbreviations. So now I have the abbreviations, right? And just to run it again, you'll see what we have. You have Don, Jan, Car, Pet, Claw. Now, what I might want to do at this point in time is actually go ahead and I can perform another map. I can map over an existing result. I'm just going to move this over here. So now whatever is the result of this, which is Don, Jan, Car, Pet, Claw, I'm going to go ahead and do an operation on that. Now I could map on top of that. So I could say it.length. And we'll return that. Now what you're going to get back is a list of integers. And each one's going to say 3 because each of the abbreviations was 3 long. So that kind of makes sense. Now, what I could also do is something like this. I could decide that maybe I want to sum something. I could sum by a particular value, so it.length, and run that. And we're going to see 15. So sum by that. But what does that mean? It means we've taken each of the values here and it's then summed them up into 15. Now I can also decide if I don't want to do a sum, maybe I wanted to do a filter. So remember, this is applying to the result of this map. So I can say filter. I want to get everybody's the first 3 letters of their name, and then if their first 3 letters of their name have the letter O in it, so it dot contains. So we'll do 2 lowercase just in case. Actually, 2 uppercase. Everything, actually, it's already uppercase. So we say it.contains O. And if we run this, we should only get one value back, and that's going to be Don, D-O-N, because I've now grabbed the abbreviation, and then I've now filtered it. So I can start stacking these things on top of each other. Now, if I, for some reason, would like to reverse these things, reversed, we run that, you're just going to see Don. So let's say contains, and let's go ahead and flip this filter not. So I don't want it if it contains the letter O, which should give me all the other ones. We're going to see CLA, PET, KR, and JAN. Now that's because the array was reversed. I've reversed this array. And I can continue to stack different operations on top of this. So this allows it to be very functional. And so I don't have to perform all of my logic directly within one particular map. I can map from one thing to another thing to another thing. And this allows you to have functions that return perhaps a list of something. And then inside that list, you might perform an operation. And then you might map over that operation and map over something else. It allows you to transform your data in real time. Basically, as you're typing it, it's much more declarative and easy to read. So that's how you can perform a map operation with just regular primitive types. Now, of course, you can do this with other classes as well. So let's say we have a class called person, and this person has as a name, which is a string. Let's do something simple like that. And we'll say people, and we'll say list of person Dawn, and then we say person Jane. Now I have all my people. Well, I can also map right over these people too. So I can say people result. And what this will be is I'll say people.map. And now I'm going to have this IT value as a person. So I can say person.name. I could do something like that. So I can just get everybody's name. Now, if I were to print this to the screen, I would say people result. What this is going to give me is a list of strings. It's just going to give me everybody's name. So it's going to be Don, Jane, Bob, Kavita. So I'm just iterating over. I'm just getting a list of that. So it allows me to transform that data, which makes it very, very nice. And of course, I can map on top of that, which might be it.length. So I'm going to get the length of everybody's name. And maybe that would be a useful function for me somewhere. I could put this inside of a function and say, all right, give me the length of everybody's names. And it would give back the length of everyone's names accordingly. Now, maybe you would want to transform this a little bit further, and you could say, all right, what's the length of their name? And perhaps also I would like to show their, I wanted to include their name as well with that. And then you could create various different mappings and return arrays or arrays of arrays, a list of lists, etc. The possibilities are endless. The map and flat map operator can sometimes be the source of a lot of confusion, and determining which one to use can always be kind of something that will confuse you throughout time. Very often that I've had to look at the documentation and play around with a few examples to understand what I normally need to use. Now, working with collections, most often you want to use the map operator because you just want to return values and perform transformations on those values across all of the items in a list or an iterable of some fashion. However, let's determine what the differences are. Here we have a class on line 23, and it represents a shopping bag. And in each shopping bag, we have a number of items that go into a bag. And as when you go grocery shopping, you usually have a number of bags. So one bag has grapes, apples, and oranges. The next bag has milk, eggs, and pasta. And the last bag has some bread, naan, and cake in it. And we have basically a list of grocery bags. And those are going to be our grocery bags that we have from the grocery store. Now, we may have also went and purchased some clothing. And so we went to a few retail shops. And those bags, we have 3 of those as well. We have a shirt, pants, and trouser. We say trousers. So we have shirts, pants, and trousers. We have socks and shoes. And then another bag has a jacket, a sweater, and a scarf in it. So we're going to use these 2 lists. So basically these 2 groupings of bags. So we have a list of 3 shopping bags. And up here we have a list of 3 shopping bags. And we're going to perform a flat map on it and then print the result. And then we're going to perform a map on the retail bags to see what the differences are. So here we take grocery bags.flat map, and then what we do is for the transformation function, we just tell it to, hey, return all of the items. And so if we look at the declaration of flat map, it says returns a single list of all the elements yielded from the results of the transform function being invoked on each element of the original collection. That's confusing. So basically what it's saying is like, look, it's going to flatten out. If this is a list, it's kind of going to flatten it all out. Now, if we look at the map, we've already looked at this before. It says returns a list containing the results of applying the given transformation function to each element in the original collection. So that makes sense. All this function is really doing is saying, hey, map over all of the bags, and then we're saying, and give me all the items. Okay, so let's do something here. Let's just run this to see what the result is. If we run this, you'll see down here, the flat map actually says, hey, I've grabbed when inside of each bag, I've grabbed the list of things inside of the bag. I've grabbed the list of groceries that are in each bag, and I got back each list of groceries. And then basically what it is, I flattened them into one single list. So it's flattened them all into one single list. In this case, flat map, when you have a bag of groceries and each bag of groceries has many items in it, it's like taking everything out and putting it on the counter. So you're flat mapping it. You flat mapped everything out onto the counter. It's all right there in front of you. Now, the retail bags, and we're using the map operator, what we're basically saying is, well, I have a bunch of items in the bag, and I may have taken all these items out, but I'm still leaving them in little groups. I have a group number 1, which contains the shirts, pants, and trousers, and the group number 2, the socks and shoes, and then group number 3, which is a jacket, sweater, and scarf. But I don't have the bag anymore because I've taken them out of bags. And you may be wondering, what do you mean I've taken them out of bags? So let's do this real quick. Let's say print line retail bags. If I run this again, we're going to see a couple of print lines here. So here we go. We have 3 shopping bags. So if I just print out the bags themselves, that's like putting 3 bags on the 3 shopping bags on the counter. Now, if I were to take those items out and put them on the counter in the same groups that they were already in, that's what retail bags is doing. It's just removing the bag, but I'm still grouping everything together. Now, flat map basically says, hey, look, I've just taken out all the groceries and I just put them all on the counter. They're all right here in front of me. I just kind of put them out one right next to each other. There's no groupings. We're just one after the other, sequential ordering. So the best way to usually think of this is, if you have a list of something, so list of lists, then at that point in time, you need to start thinking about, all right, maybe I need to use flat map if I need to kind of get into each individual item and combine them into a larger list that's congruent. However, if I just need to operate on each item in a particular group, then perhaps I just need to use map. So list of lists, think flat map, everything else, I default back to map. And then of course, if you ever get confused, hop into the documentation. I hope that helps. Sometimes you want to have a list of data, but you don't want items to repeat. And so you want the data to be unique inside of that list. That's known as a set. And so what we can do is create a set of values. So I can say set of, and this is a helper function inside of the Kotlin standard library, the Kotlin collections library. And I'm going to create a set of names. So I would say Don, and let's say John, and then Felicia. There we go. And I can print this out. Now, what this will do, this should be names. When I print this, it'll look almost similar to just like a list. We have Don, John, Felicia. That works well. But the benefit of a set is, if we look at the definition here of the set of helper method, returns a new read-only set with the given elements. Elements of the set are iterated in the order they are specified, and the return set is serializable, so we can serialize it. But the interesting thing is here, it does not allow duplicate elements. So if I want to put Don in there twice, and I run this, you'll see that Don is not in there. Let's see if I try to put Felicia twice, or John. So do John again. We see that's not included. So we cannot put that inside of there. So with a set, you can't have duplicate items in there. And so that's how we can create a set that's basically a read-only set. If we want to create a mutable set, you would actually, which is a set you can change. And again, you could specify this differently. This is also going to be known as basically a set of string. That's the way you could do this. Set of string. Of course, this is not, the helper method doesn't work this way, but that's what this is a set of string. If you want to create a mutable set of, you would do like this. And we don't need to provide the type parameters because they are inferred. If you want to add something, you just say names.add, use the add method. And here we're going to go ahead and say Jenny. And we'll go ahead and print line names. And when we print that again, we should now see Don, John, Felicia, and Jenny. Now what happens here if we try to add Don in? And let's go ahead and print it again. Now Don already exists in there, so if we run this and see what happens now, we'll see that Don is not added again. So the set is remaining unique. Each item in the set is unique. So this applies for if you're going to have your strings, your integers, etc. Each item in a set is unique. Okay, now let's take this a little bit further here. We've kind of understand what we can do for duplicate names here. If Don is up here twice, it's not going to show. But now what if we have a class? So we have an object. So an object should not have duplicate values in there for a set. Now, however, if I've added a person class here that just has a name, and then I add 2 people to this, 2 persons to this people set, we should technically only see 1 Don in there. Now, when we run this, we actually see 2 persons. And notice this little number here at the end. I'm not going to get into the details of what it is, but this basically is saying, look, these are different objects. And so the equality checks inside of here are not being done. Now, there's ways you can implement these equality checks inside of your classes with the equals and overriding all the proper methods to ensure equality inside of your classes. However, if these are just classes that are going to hold data, such as this one is, then what you can do is you can just turn this into a data class and use this as a data class. It'll work the same way, but all these equality checks are already done for you. It's comparing all the fields, etc., to see if they're exactly the same. So now if we run this, I'm basically adding 2 Dons to the set of the same data class and say, nope, it's not going to allow it. So I could come up here and add another one. Say, no, I'm really sure I want to add Don 3 times. And what will happen is it'll come back and say, nope, there's only one. And so then I can actually maybe just change this one to let's do this one as Janet. We'll run here. We'll see, all right, and there's Don, there's Janet inside of there. So the set is not allowing each multiple different versions in here of the different types of folks. Again, so you can have a mutable set. So this is very much a very kind of Kotlin specific idiom. You have immutable and mutable. By default, everything's immutable. So you need to think about this. If you want something to be mutable, you need to tell Kotlin, hey, this is a mutable list. This is a mutable map. This is a mutable set. And if you need it to be unique, like a list of data to be unique, then you should be using a set. And if you're going to be using classes, you want to make sure that the equality checks are implemented correctly in your given class, or you're using a data class. Loops are one of the most common structures in programming. And for loops are going to be something you've probably used in other languages. If not, they're going to be something you'll become very familiar with. So let's assume we have a list of values. And these values are maybe integers, 1, 2, 3, 4, 5, 6, 7. You can iterate over these or perform various different operations of them pretty easily. The first thing you can do is just iterate over the list. So you can say for number and values, print line number. And what this is, it says for every value that's inside of here, we're going to give it a variable called number, and we want to print that number. And if we run this, we'll see 1, 2, 3, 4, 5, 6, 7 is printed. So now I can call this something else. This doesn't have to be called number. This could be called chicken. I mean, just for whatever, just for purposes of demonstration, this can be anything you want it to be. It's going to print the value, and this is each value that's in this list to be put inside of here. So the same thing goes for these primitive values as of, it could be names, it could be anything of that nature. And then again, I'm going to change this from chicken because it doesn't make sense, but to name, we'll run it again. We'll see Don, Bob, Jane. So that's each one of those values in that list. And that's how we can kind of iterate quickly over a list using a for loop. Now there's also ways you can do it if you want to do some type of counting. For example, if we wanted to say for I in 0 until 10, we could print the letter I. Now we're used to seeing I as a counter variable in very many languages, and you'll see here what's happening is I is defined as an integer in 0 until 10. So it says starts at 0 up until we hit 10, we want to do something. So each time it's just going to iterate and increment the variable value by 1. So we have 0 through 10 down here. Now there's also another thing you can do. So that's a very common way to do some looping, and you can set this as a variable up here. So because that val, say, upper limit is 10, and so you can say until upper limit. So, or you could say, here's another word, you stop, right? So stop, and then you can make another one called start. So there's all different types of ways that you can do this in your code, and it's up to you depending on the situation for I and start until stop. I mean, it doesn't really make sense because then I have to go find what start and stop means, but as just a demonstration that you can run this and it'll still execute accordingly. So I'm going to undo this here, and we're going to go back to how it was before, until 10. Now you can also perform stepping. So what this says is for I in 0 to 10, I want you to step by 2. What that means is basically count by 2 as we're iterating. So instead of incrementing by 1, increment by 2. So therefore, you see 2, 4, 6, 8. So if I were to jump this up to, let's go to 100. We're going to see it's going to count by 2s all the way up until 100. And there it is down here at the bottom. Now I could say step 10, and that's going to iterate all the way up to 100. So we're we're going to see starting at 0 all the way up until 100. And if I were to do step 5, of course, it's just going to run it till it's 5, and then it'll iterate upwards. Now you can also do it the opposite way. So let's go down to the step. Let's get rid of the step again. So we have I in 100 down to 0. So this will be basically a reverse for loop. So it's going to count from 100 down to 0, and it's going to increment by 1 by default. Now again, I could do step 2 here, and that's going to count down by 2. Or I could do step 10. And then we're going to have 100 all the way down until 10 to 0. So as we can see here, on 100 all the way down to 0. So when we're step by 10. Now the last thing you could have possibly is let's take a simple class like let's create a quick data class called person. And this person, of course, is going to have a name, which is a string. And let's create a couple people up here. So we'll say val people equals list of, we'll say person, Don, person, Jane, person, Karthik. And then what we'll do inside of here, we'll say for I in people, we're going to print the people. And so you can iterate over objects as well. So here we're iterating over each item in a list, just using a simple for loop inside of Kotlin. And that's how you can use a for loop in Kotlin. A while loop in Kotlin is very easy to create. So we'll say while x is less than 10, we want to perform some type of operation. So here we'll say print line x. And then what we need to do is increment the x value. So it continues to increment upwards as we are progressing through the loop. And if we run this, what we'll see is while x is less than 10, we perform some operation. Now a while loop is very useful where you need to do something while a particular condition is met. And so this could be maybe you need to be running something in a loop the entire time and only do it when maybe perhaps a certain button is pressed that needs to exit out. Now, for example, if I forget to set this x variable here and increment it, and I run this, watch the terminal window. I'm going to stop this pretty quickly, but there we go, I'm going to stop it now. But this is a very long scroll of zeros. I mean, I'm scrolling a lot and it's barely moving. If I had let that run, most likely the IDE would have had a out of memory exception or Stack Overflow exception, because it's continuing to print line over and over and over and over and over and over and over, and this loop is never going to stop. This is basically an infinite loop at this point because there is no termination that's being provided by it. And when we increment this x value, we're actually incrementing the x, and eventually this expression will end up being false. And so as soon as it hits false, the loop will exit, and then the next line of code will run. So say print line. So we can see this all done. If we run this now, we'll see all done is printed afterwards. And if we just let this go for 100 or whatever, then it could be a problem. Now, a lot of times, folks will actually run these while loops in various different programs in the back end and in client applications while they're waiting for a file to process, while they're waiting for something to happen. Perhaps they put a sleep command in here for the thread to sleep. And again, there's pros and cons of all this. I'm not telling you and advocating to use sleep inside of your code. That's usually a code smell. However, you'll want to understand when is a good time to use a while loop. A lot of games, stuff like that, use a lot of while loops to keep things running in a game loop. So while loops, you'll need to make sure that everything is going to run inside of the while loop. Between these two brackets, everything is going to run while this expression is true. And so this could equate to be some type of value, and perhaps this root loop runs until a user presses a particular button. Maybe it's drawing something on the screen and you're determining where to render things. A while loop is a perfect opportunity to do that. I need something to happen over and over and over until an exact particular condition has been met. That's when you're going to want to use a while loop. And that's what you can do. This can be this could be a method call inside of here if you want it to be. This could be a fung is okay to, or like keep going, which can return a Boolean. And at this point, you could have some code in here that says return true or false. True or false. In this point, we'll say true for whatever reason. And you could actually just call this right here. So keep going. while keep going, blah, blah, blah. And this method in here could be going out and checking file system, checking an API, waiting for an input, or checking an input, or interrupts of some form to say, hey, should I continue to go, and so forth. So that's when you're going to want to use a while loop in Kotlin and how to use it. Let's assume that you have a list of people here in a list. Now you could, of course, go ahead and iterate over each one of these inside of people like this for I in people, and you could print line each one of these people inside of this list, and this will work just fine. There's nothing wrong with this. In fact, many people probably do this day to day, and it works. However, there is a more idiomatic way to do it in Kotlin, and you can use the Kotlin collections to do that. So you say people dot, you can say for each, or each, for each here, and then what you can say is println, and then you can do it. And that's basically going to do the same exact thing for you. It's going to allow you to iterate over each item inside of the array, but allows you to say, hey, for each item in this array, do some particular function. Anytime I'm working with a list, a map, some type of collection array, or whatever it is, if it's some type of collection inside of Kotlin, I'll always want to prefer to use the iteration on the actual list itself. It makes it much easier. Unless I'm modifying the list and I need to do something with the list, then I might use a different type of loop structure around it. But for the most part, for most of the operations I'll prefer to use the each operator, so I can iterate each over each one of those things and so forth. So another thing that you could do, you can also, as we've seen before, you can perhaps map these things together and say map, I could say a substring of each one of these things, and it would be actually it.name.substring. I'll actually just take each person's name, and then I can do for each, and then I can perform some operation on that, and I could say something like it.toUppercase. So I can kind of start chaining all these different things together. And as soon as I get one or two of these things in the line, I like to kind of drop them here. And then I might say for each. And I can do a map on top of it. Actually, I can do another map here if I want to. And then as soon as I have that list done and I want to do something with it, I can then do for each over it. Now for each returns a unit, which means it's just a unit. It doesn't return another map, which is why I was not able to add a map operator before. So if I wanted to do something additionally to this to transform these values, I would perform map here and say it.toUppercase, and we can do this dot reverse. And if we ran this, we would see each person's name is uppercase and reversed. But we did not print it, which is the problem. And here, when we actually print it to the screen, we'll see everything here will be all the names reversed and uppercased in there. So again, if you're going to be using any of the Kotlin collections, I highly recommend using the for each operator to iterate over a collection. It's much more idiomatic and easier to read, and actually less code. Very often in Kotlin, you'll receive multiple lists, and you'll need to combine those lists into a list that does not contain duplicate elements. Now you could iterate over both lists and check to see if either one contains a value, and if it does, then not included. So each item in the new list is unique, and that's usually what you're after, is a list who has unique values. But really, at the end of the day, what you're looking for is actually a set. And a set, if you look at it, is a generic unordered collection of elements that does not support duplicate elements. And that's line 252 here. This is in the collections class of the Kotlin standard library. So basically a set is a unordered collection that does not support duplicate elements. Now, thankfully, there are some utilities built into the Kotlin collections library that allow you to do this real easily. So here we have two different lists of people. This one has Don, Jake, Janet, and Kavita, and this list has Don, Janet, Jumo, Kavita, Kevin, and Kathy. For whatever reason, in both lists, both people are present. Now, maybe this could be because these could be groups that are on, a popular site that you have, or maybe you're building an event management platform, and so Don and Janet and Kavita are both going to these two events, but there's some differences here. But you want to find all the unique people that are there. So this could happen for 1, 2 lists, 100 lists, and you need to find out which ones are unique. Now there is a built-in operator to do that. So you can say val unique values. And all we really have to do is say people.union more people. And what union will do is it will return a set containing all the distinct elements from both collections. And it's going to return a set of the values, so a set of whatever type it is. In this case, we're using persons. So what it will do is it'll look inside of here using the equality operations on the data class, which it checks, the values, etc. And it will check to make sure that there's no duplicates. And so now, if we were to run this, so we'd say println unique values, we run this, we'll see that we will only have Don inside of here once, Jake is only in here once, Janet's only in here once, Kavita, Jumo, Kevin, and Kathleen. There is no duplicates inside of here. So even if you were to add another one here, say union something else, and you could say person, and again, you'd say maybe Don again, so the third time that Don is going to be inside of there, you'll see that it's still only added once because the union operator will return you the set containing all the distinct elements in both collections. And that's how you can merge multiple different lists and return unique elements across all of them into one final set. When working with lists of data, it's very often to want to know the index of an item as you're iterating over it. With Kotlin's built-in for each iterator, you don't have access to the index. You only have access to the value, which is the person. However, there is an overload that we can use for each indexed. This will allow us to get us the index of the current operation and the person at that given index. So for example, if we were to print line this, we could see something like this. We'd say index, and we'd use string interpolation here. And then we could say person. And if we were to run this, actually we can remove the curly braces there because the data class will give us a good toString method. We'll see when we print this out here, we have the index 0 and the person object that is associated with the index 0. Now this is very useful if you're doing operations in which you need to know the index of a particular value inside of that data structure for whatever reason. You now have the index and you have the value that's associated at that given index to perform whatever operation that you need. So if you need that, you'll want to use the for each indexed operator. We're using the lambda expression version here. You may also have seen this with parentheses like this. This will also work. However, you'll notice that IntelliJ or Android Studio, whatever you're using, will give you a hint here that it does not need that. This is a lambda argument, so it can be moved out of the parentheses. Basically just remove the parentheses and the lambda expression is passed in via the SAM operations. And that's how you use for each indexed. A range in Kotlin allows us to specify a range of values. So here I'm specifying a range of values from 1 to 5. I'm saying if the I is within this range of 1 to 5, then print the value yes. Otherwise, print the value no. And so if we were to change this to 12 and rerun this, we would see that the value of 12, because I is not within this range of 1 to 5. We could also say for J, this will give us a range. Very much a for loop variable now. So we can say println, so j in 0 to 10. The range again is 0 to 10. This is the range that we're working within. And so we can say j. And when we print this, we're going to see 1 through 10 printed down here. Now again, this is, if you're familiar with the for loops inside of Kotlin, you can also provide stepping. So I might decide to say I want to step by 2, meaning that instead of incrementing the value of 1 for the j counter variable, it's going to increment by 2. So it's basically in this range from 0 to 10, I want you to execute something. If j is within that value, execute some code. So from 0 to 10, and then I want you to make a step of 2, which is we're going to see down here, iterates from 0 to 2 to 4, 6, 8, 10. And so every once in a while you will use ranges, and of course these values can be variables, etc. So this is a very simple implementation of how you can use ranges to count inside of Kotlin. A map is a very common data structure in computer science. A lot of times this will be called a map, hash map, or a dictionary. And basically it's a key value pair that you can store inside of a data structure. And this is a map data structure. To create one, you can use the map of helper function, and this will actually let you create an immutable map of values. And what this means is we'll have a map where the keys are strings and the values are strings. The keys over here are which means NY maps to New York, NJ maps to New Jersey, and CA maps to California. And of course, you could continue mapping all these down there. And then if you want to get that value, it's pretty easy. You can just say states.get, and you can pass in the value of NY. And then of course we could print line this and see what the result is. Now, as you're executing this, you'll see that New York has been returned. However, if I were to type, let's go FL for Florida and run it, we're going to see that's not in there and a null value is returned. That is because it will return the corresponding value if it exists or null if it's not present in the map. So it's very often that sometimes you'll want to say get or default if you want a value to be known. So I don't want to work with a nullable type, so I'm going to say unknown value. And then at that point, when I run FL, we'll get back unknown value that's printed out down to the screen down here. So that's one thing you can do. You can also use get or else, and or else is going to allow you to provide a function where you can actually return some code, which could be whatever, could be foo. This is a function that you're going to call that's going to be invoked when the default thing, nothing can be found here to match FL. So if I were to run this, we're going to see that when we say get or else, foo is being returned. Now back to the original method here of FL, we saw that the squiggly here inside of IntelliJ is saying that we can improve this through basically the code improvements. And when we press the light bulb here to get that, or over here, I was able to just turn this into an indexing operator. So basically saying, hey, states, just like an array index, give me the value for the key of FL, and then of course it returns back a nullable string, and we're going to get back null here. A couple of other things that are very useful inside of maps is you can check to see if a key is there. So you can say, is there a key there? It returns a Boolean value. If the key is there, it'll return true. We can also say, hey, does this value exist? And we know the value NY does not exist as the values, because the values are here in New York, New Jersey, California. Those are the values. These are the keys. And so the values don't contain there, so we can do that. And so there's a whole bunch of operations, and if you're interested to see what you can do, because a map is part of the collections library in Kotlin, so we can actually get all the entries, so which is going to be a set, because remember, in a map we can't have duplicate keys. So a key has to be unique. So we're going to get back this result. If we print this, this will be a set of strings, and we can see here, there's all of our entries, which is going to be for all the, it's going to have the keys and the values, all the entries. And then what we can do here is also we can see the keys. So if we want to look at the keys, you can also inspect all of the keys, which will return back NY, NJ, and CA. And of course, you can inspect the values across the board. So you can start working with all of these different types of things in a map. Now, that's how you can kind of set up a regular immutable map inside of Kotlin. Just like lists, which can have immutable and immutable lists, you can have immutable maps and mutable maps. And so if you were to create your map, so we can just call this map, actually call this items, you can create a mutable map. And what a mutable map will do is it allow you to add and remove items to the map. So what we could say here, again, we could do the New York to New York. And again, this is just going to create a map of basically state abbreviations in the United States to the actual full spelled out version. And we'll just do the same three that we have for the immutable version, which are New York, New Jersey, California. And of course, you could have all of them in here if you wanted to. Now at this point in time, if I wanted to remove an item, I would use the put command. And then inside of the put command, I would provide another key. And so I could say TX, and then the value, what it would be Texas. Now notice how we have a little squiggly here. What this is telling us is that the put method can be converted into an assignment call. So I'll hit Alt Enter, or you can also just click on the little light bulb right here when you put your cursor here. There you go. And we can just say looks like that. I'm going to leave it for put for now just because it reads a little bit better. And we can print line so we can see what this looks like. And if we run this, we'll see down in the output window that we have 1, 2, 3, 4 items. So we said New York, New Jersey, California, and Texas. Now, if for some reason I wanted to, whatever reason, remove an item from this data structure, I could say items, remove. And all I have to do is provide the key here. And now to provide the key, I'm going to say, all right, I'd like to remove New York. And then, of course, we want to go ahead and validate that our items were removed. And if we go ahead and run that again, we'll see that we now have the first call had all 4 items, and the next call had removed New York. Now, something interesting will happen here inside of your code. If you already have this list, let's go ahead and remove these. Well, we'll leave Texas. And we decide to put an item in here. And we decide to put New Jersey in, though we already have New Jersey up here on line 5. If we decide to put New Jersey in, and we say Joyzy, because sometimes that's how they say it out here, and we print line, we're going to notice an interesting thing will happen here. And what happens is that New Jersey is actually replaced inside of the array. So instead of New Jersey, it's replaced with New Joyzy. So perhaps that was a mistake in our code. Now it's perhaps created a weird side effect where there's a bug. Now there's something you can do to kind of help prevent this. So if you thought that New Jersey was there and you didn't mean to overwrite it, or you don't want to overwrite it, you could say put if absent. And what? So if we run this, we'll see is New Jersey was not overwritten. Why? Because put if absent will only put the item there. If we scroll up, see this, if the specified key is not already associated with the value. Otherwise, it'll return the current value. So if we look back at the code here again, it returns a value. So what does it return? Let's go ahead and check it out. So say print line. And what this will return is going to be the item that was currently existing already for that key. And so we're saying, hey, put something in there if it's absent. Hey, I'm trying to put something into this map that has the key NJ, and I want to use Joyzy. And what it comes back is saying, well, just letting you know, we already have something in there. So we're going to go ahead and show you what that is. And we're not going to overwrite it. So that's very useful. So you don't overwrite anything. Now, on the flip side, let's say for whatever reason, we realize there's you're allowing the user to edit something on a screen and they are removing items and putting them, etc. And you want them to allow them to remove something, but only if the key and the value match. So if I remove this, if I say remove, what will happen is New Jersey will be removed from the list. And we can see that when we run this. But what if I want to keep New Jersey inside of there, but I only want to remove it if somebody accidentally kind of got wise, was a wise guy and said, hey, let's add it as Joyzy. So what this says is, hey, only remove this key if its value is Joyzy. So let's go ahead and run this. And what we'll see down the last print line is that New Jersey was not removed. So this key and the value stayed put because while it did find a key for New Jersey, it didn't match the value. So the value Joyzy was not removed. Also, sometimes during development, you'll need to retrieve an item, but sometimes it won't be there, but you do expect it to be there. And if it's not there, you would like to add it to the map. There's actually something you can use, and that's called get or put. And what that means, returns a value for the given key. If the key is not found in the map, it calls the default value function and puts its result into the map under the given key and returns it. So if we go back here, so get or put, we can then take this key and we're going to say UT, and we'll say Utah. And notice how it's not giving us an error because it actually needs to be an expression. So it's a lambda expression because perhaps this needs to be a method that goes out and does something, or a bunch of different things. So it gives us the ability to do that. So we'll say Utah, and if we print this, what we're now going to see is because we have not ever added Utah to this map, we put Texas in, and now we're going to basically say, hey map, get me Utah, but if Utah does not exist for UT, for this key UT, go ahead and insert it for me and return it. So, which we could basically do inside of here. So we say val result equals this, and then we would say print line, and what the result would just be that value. So when we run this here, we're going to see Utah was returned because it's basically saying, hey, give me the value for the key UT. And behind the scenes, the map is saying, the mutable map is saying, I don't have this in here. Let me go ahead and insert it. And now I've inserted it. I'm going to return it back to you. So this one little line of code can save you a number of lines of code if you need to add and remove things to a value. Now, of course, this is a map. So it's a mutable map. You can do all different types of things with it. If you would like to clear it at this point in time, and then we can say, so here we're going to print all the items and we'll print it again. The items.clear is going to go ahead and clear all the items out of the map. So it's just a very, very kind of just typical map, hash map, dictionary object data structure that you're used to working with. And that's how you can work very easily with a mutable map in Kotlin. Retrieving values from a map is usually pretty simple, and you've seen this probably in other lessons. You can retrieve the value via the get method, which you could just say ny here, or this will return you your result, as we can see here, or you can actually go ahead and use the indexing operator to return the value. Now, there are a bunch of other things that you can do because the map inside, a mutable map inside of Kotlin is inside of the collections library. And so there's a bunch of different types of collections, and the map is one of the most common that you're going to end up using. Now, there's a bunch of different utilities that you can use on a map, just like for a list and arrays and other common collection data types. So if we say items dot, the best recommendation I can give to you is to start looking around at all the different things it can do. Now, one of the things that I am really happy about is actually the any method. And the any method basically says, hey, if there's any items inside of this list. And this is very useful, especially in common, expressions where you're checking to see if there's anything in there. And so if you would like to see if there's any items in the map, then do something. So you want to do X, Y, or Z. Otherwise, maybe you want to prompt the user to add some values because they can't continue. So any is a quick way to check if there's anything in there. Now there's other things in there as well, which kind of is the opposite of that, which is none. Basically says returns true if the map has no entries. So is there nothing in there? Okay, cool. Then at that point, it's kind of the opposite of any. So this would then operate if there are no entries, and this operates if there are entries. So these are very useful little operators on side of the map. This is also very common stuff that you're going to see inside of lists and stuff as well. Now, if you also would like to return values outside of a map, again, the most common way is going to be using the items.get or get or default or get or put, get or else, get values. You can actually iterate over the values themselves. You can also check to see if it contains a particular key. So does it contain the key NE for Nebraska? This will return true because we do have the key Nebraska inside of here. Now, one of the things you have to be aware of is when you're using the common methods inside of here is you may want to say, hey, I want to filter a particular value. So let's say val result equals filter, and I want to say item.key equals ny. Now, you may think, well, that's going to give me back my value. Well, that's incorrect. You're actually going to get back a map. And we can see this simply through the code help inside of IntelliJ, but let's just go ahead and print it out to see what that looks like. And when we look at the output, we're going to see that we actually get back an actual map. And we can see this a little bit further if we actually just filter this just by saying contains. Let's go with the letter N, and we'll go ahead and get rid of this NY here. And what this is going to do is actually filter the map and give us a new map back that only has any of the items in the map where the key contains a letter N. So we have New York, New Jersey, New Mexico, Nevada, Minnesota, and Nebraska. If we were to change this to the letter F, of course, we're only going to get back Florida because, as we see down here, because Florida is the only one that has any of the keys with the letter F inside of it. Now, that's kind of a very common, filter method you're used to seeing, but you can also use filter keys. And what that will do is remove the requirement for you to type keys, because it is the key right now. So now it is the key. This will run the same exact thing, and it'll filter out the keys. And of course, if we just did the letter N, you can see that here. So we can say filter keys. So you can start filtering based upon the keys. If you only want to filter the values, you can say filter values. Same thing. Does it contain the letter N? And that's only going to be a capital N, by the way. And so we're going to see back, we do have New Mexico, New Jersey, blah, blah, blah. If we wanted it to be lowercase, then we would kind of get all of our values that have a letter N, which might be additional ones like Minnesota and California and so forth, that are all going to be included inside of there. So there are different ways that you can work with these things. And of course, these are, basically collection operations. So if we wanted to filter those values, and then I wanted to provide a map over it, and I wanted to do something to that map, and again, this is going to be a transform function that's applied to this, I could say, at this point, I want to take the first 3 letters of the value, and I just want to go ahead and map that value and give me the value. So if we did this, and then we did the substring of it, and we said, all right, I want to take the first 3 letters, what would that look like? You may think, all right, am I going to get a map back? No, you're actually going to get a string, because we're just actually taking the value here. So you can take a look at all of the different things. So we can say, perhaps, filter keys, filter not to. We can say map keys. So there's different things you can do inside here. So you can map the keys, you can map the values. So if we take a look at this, it's going to be it.value. And then what we're going to do here is we can say substring 0,3. And if we run this, what we're going to see back is now we still have our map intact, because we're using map values instead of the map. So previously, again, let's go ahead and comment this out just to see the difference here. We used map, and then we said it.value.substring. And we said, all right, I want to take 0 to 3. And when we ran this, we just got back a list of strings that contain the first 3 letters of all the states. And the reason for that is the map is mapping, hey, this is a transform function applied to the map entry, which is basically each entry inside of a mutable map is called a map entry. And the map entry is a string. As we can see here, it's a string and a string. So the key is a string, the value is a string. And I'm just saying, hey, I want to take the value, and whatever is returned from this is what's going to be returned from the map. So it's going to be the first 3 letters of the value, and it'll be shoved back in there. Now if we kind of switch this around and comment this out, there we go, and we run this. Now of course, what the map values is going to do is going to say, hey, well, let's go ahead and take the values and allow you to transform something on the value itself. So it returns a new map, as we see from the documentation, with entries having the keys of this map and the values obtained by applying the transform function. So in short, what that allows you to do is transform the values, but maintain your map structure. You can do the same thing with things like map.keys. You could, do some type of transform function inside of here. We might want to say map.value dot. Would say map.key let's say, let's make it all lowercase, to lowercase. And now if we to run this, we'll see that the result that we get back is now we have all of our keys have now been turned into lowercase, but we still maintain our map structure and our map data. So anytime you are working with a map and you want to kind of transform the data, iterate over it, you want to go ahead and take a look at some of the various different map operators. So you can do flat maps and irregular maps and map not nulls and so forth like that, which are very useful. But this is one way that you can find and filter values other than using the traditional get and put methods inside of the immutable map and maps themselves. One thing that you'll eventually run into in almost every programming endeavor is the point in time in which you have to start working with null values. Now by default, you want to try to work with as many non-null values as possible, which by default is why Kotlin makes you specify nullable types. However, there are times when you perhaps need to perform some type of map operation. Now, for example, this map might have you do something and you have to call into a certain function. So we have a function down here below, and it's called find value in web service. Now this doesn't really find a value in a web service, but it does, we are trying to emulate that environment. Let's assume for whatever reason that all of your items in your map, you need to go up to a web service and you need to ask it for some value. And you don't control the web service, but for whatever reason, that web service could either return a null value, or it could return back that particular entry. Maybe it's been modified, it could be something different. But we're just going to return it back as a regular entry. So if we were to print this out here, what you might see at this point in time is that we have a bunch of weird values in here. So look, now we have basically a map, which again is just going to return us back a list of certain values or whatever. When we're going over the map here, and we're saying, hey, give me all the values of everything. So it's returning us back a list. But this list has a bunch of null values in it, and we don't want these nulls, because now when we have a null value, you can see that the entry that's returned is a list of all these different entries, which makes it very difficult, because now we have to worry about null checking and so forth. And if your method that you're sending in this result value into, so if you have another method down the line that says you want to process results and process values, and that method for whatever reason takes in a result, and it takes in a non-nullable type, which is what you should try to aim for, because nulls can create a lot of problems for you. That's going to create a problem here, because you're passing in null values. Now you have to do the checking. Now you have to remove them. Well, thankfully there's a way around that. So you can say map not null. And what map not null will do is it'll find if it encounters any situation where a null value is returned, which is what it will do here. And basically what that happens is anytime one of the keys inside of our map starts with the letter N, we're just going to return a null. Otherwise, just return the entry. So if it encounters, New York, New Jersey, Nevada, Nebraska, anything like that, it's going to return a null, which is what we saw here. These are all the null values that we see down inside of that were returned back and so forth. So we have them there, we got it there, we got it there, we're all over the place. And we don't want that. We only want the values that are not going to be null, because perhaps we need to do some processing. We don't have to worry about nulls, etc. So you can use map not null, and if you run this, now what this will do is Kotlin will say, all right, we're going to iterate through the map. If we get a null, we're just not going to include it. So here down on our result, we could see that we do not have any null values whatsoever. These are just values that are not null. So if you ever need to have a list, map, whatever, and you don't want the null values included, but you do need to perform some type of processing over them, and a lot of times you may not even have the ability to change that code, because maybe it's inside of a library somewhere and it returns these null values, you can use map not null to ensure that the map that you're going to get back is not null. Now, of course, items might be missing that you were expecting to be there, but you'll have to handle that as a case-by-case basis. And that's how you can work with a map and make sure that items are not null. This also works for lists as well. Let's assume that you wanted to generate a very large list for whatever reason to do some testing, or perhaps just to play around. What you can use is the generate sequence method that's inside of the Kotlin standard library, which returns a sequence. Now, a sequence is a completely different beast, and there's some other videos that talk about what sequences are and why they're important. But just know now that you can generate a sequence using this method. We're going to seed it with the value of 1, and then for each iteration we want to do something, we're going to perform some type of function here, and that's going to be the next function that gets executed. And all we're doing is we're taking that existing value, which is the integer value of 1, and incrementing it plus 1. And then we say .take, and what take is going to do is return a sequence containing those number of elements, and basically we want to do this 50 million times, which is a lot. And so again, this is the shorthand version for making longer numbers. Now, of course, we could have done this too. That would work, but thankfully Kotlin allows us to have some readability with the underscores. So we want to do this 50 million times, and then we want to turn this into a list. So now we have a list of 50 million items that are all different, that have different values in there. And then let's say that for whatever reason we wanted to do some operation. Now we could do this operation here. And now we have a very large list to work with to see what's going to happen. Now I'm going to run this here actually, and then what you're going to see is it's going to take a while. And so this is currently running. We'll know when it's done when we see the print line is done on here. Now, it's very possible that you could hear my computer fan start up in a second, because this code is still running right now. It's still filtering and averaging over 50 million items, and it's running on my laptop. And now I can hear my fans turning on, and there it goes. It's now done. So it took quite a while to generate that, and So we get back a double. So we could say the result, and then we say print line, and we could say the result. And then we could see the result here. And again, if we run it again, it would take quite a while to run this, but this is one way that you can use the generate sequence built inside of the Kotlin standard library to generate a very large list to do some testing with. So again, this is generating a list with 50 million items in it. And then I'm iterating over it, basically filtering out the items that, I have a modulus of, 3, 0. So if it's divisible by 3, then go ahead and take those out, and then I want to average those together. And then what happens is I get the result back, which is a double, and that's printed out down here at the bottom. And that's how you can generate very large sequences and very large lists inside of Kotlin, so you can work and do some testing. Very useful. Let's assume you have this chunk of code here, and if you run this code, you'll notice that it takes anywhere from, on my machine, upwards of 9 to about 20 seconds to run. And the reason why is because we're generating a sequence, which is like a collection, and we're turning it into a list. And this line basically says, hey, we have 50 million items in this list. And then what we're going to do is kind of do some operations over it. And then we're going to calculate the average of some of the values in there. And then we're going to print result and done. And so we can see that here. Now, one of the problems that we have with a lot of code sometimes is we don't know how long it takes to run. All I know here is like, wow, that was a long time to run. So how could we measure this? Well, what we can do is actually create a function called measure. And this function measure is going to take in what's known as a lambda expression. And this lambda expression is kind of confusing. So it's called a block, and this is just a function. We're just passing a function in. And this function right here has no parameters. That's why it's like an empty parameter list. And this function is going to return unit. So this block right here, this block is going to have no parameters, and it's going to return a unit. So it's basically a void. So it's going to be a void. So we can pass some type of function inside of this measure block here. But now we need to be able to measure that. So what we're going to do is say nanotime. And then what we're going to do is say measure nanotime. And we can actually pass a block in there. Measure nanotime, if we take a look at it, it executes the given block and returns the elapsed time in nanoseconds. This is built into the Kotlin standard library in the timing file. And all it does is it looks at the system nanotime, and then it executes the block. And remember, the block, which is what we pass in, is just a function. So I'll show you how to pass a function in a second. We're going to pass a function in. The measure nanotime basically just grabs the nanotime, then tells the function, hey, execute, do whatever you need to do. Remember, the function returns unit, which is basically the same as void in most JVM languages. It's going to return a void. And then at that point in time, it just calculates how long it took in nanoseconds for this function to execute. Because again, that's a blocking operation. We get the start time and we calculate the end time, and that's how long it took in nanoseconds. So now we have nanoseconds, but we're not too familiar with how to work with nanoseconds. So let's go and get the milliseconds. And so we're going to do time unit dot nanoseconds dot 2 millis, and then we're going to pass in the nanotime. That's how long it took. And then now that we have the milliseconds, we can just do print line. And then what we can do is say print ln. We can actually take the millis, print ln, and pass in the millis, and then type in milliseconds. And what this will do is show us how long something took to execute. So how do we use this function right here? So what we can do, because this is a block, we'll just go up here. Remember, and this is called a block because it looks like a block of code. And I'll show you what I mean by that. Let's type in measure and see how we hit the code completion here. And it looks like these little brackets we like to call that a little block. And so right now we're in the block. This is the piece of code that's going to get executed. So we can just provide these brackets here. Basically is a lambda expression, and anything that's in between these brackets is considered the block of code. So I'm just going to go ahead and take all this, and I'm going to go ahead and clean this up a little bit, and I'm just going to drop it right in here. So now all this code that's inside of here, this area right here, this is the block of code. So remember, so this right here is what turns into this block. And then when we get onto the nanotime, that's what executes right there. So anything between these two brackets here, so top bracket, bottom bracket, is the block. And all this code that's inside of here is what's going to get executed and measured. So let's go ahead and do that. So now what's going to happen is we'll still run this code as we normally would have, but what's going to happen is it's going to run, and then it's going to show us how long it took to run. So if we run this now, we'll execute this. Again, this is going to take anywhere from 5 to 8 to 10 seconds. And as it runs, it's basically calculating it. Again, take a look here. Right now, it's executing this code right here. It's already calculated the start time, and it's calculating the end time as soon as it's complete. And as soon as it's complete, we'll then see the millis ms. There we go. Done. So we know that we are done. We got the result, which is the average that was calculated, and it took 18,244 seconds. So on my machine, this operation takes 18 milliseconds, a little over 18 seconds. Now, it's important to note that measuring time and diagnostics for how valid timing is a difficult task inside of JVM. So this is a very important note, that this cannot be treated as the end-all be-all performance checking solution. The reason being is the JVM has indeterministic garbage collection. So we could be in the middle of running this, and for whatever reason, the JVM decides, you know what? We need it's time to garbage collect. And that could happen right in the middle of your execution and might throw this off. So I don't want you to take the measure nanotime as the end-all be-all solution. However, it is a very, very useful tool to kind of get a good diagnostic feel of, all right, how long is this taking? Why is this taking so long? And you can use this. So what I recommend is taking this little measure thing. You can kind of copy and paste it into maybe a Scratch file somewhere, or some type of tool where you save some code snippets, and use it anytime you want to start measuring things. Or you can put it in your project under like a utils and then decide if you want to use it or not. Now, of course, you probably don't want this in your production code, but it's very useful if for some reason you're like, wow, how long is this really taking? And then you can start determining, oh, wow, this is the, and then if you wanted to, you could say, all right, well, is the measure actually, is it this piece right here? So then, what is that? So we actually, we'd probably want to take this out here and say, want to take this list out and say list, var list. So we do late init, var list, and that's going to be a list of, looks like integers. And then we can just do this. So then we can see how long that took. So if we were to run this now, we would see as it's generating how long it's going to take. So to generate the 50,000 and then turn it to a list as it's executing. Okay, so I'm going to stop it here. Now what we see here is that it took about 9 seconds to generate that sequence. So then we could start measuring various different components here. All right, how long did it take for this other stuff? So if I wanted to, I can move this down here. Okay, that took 9 seconds. How long does it take for this stuff here? Let's go ahead and run that. And then you can run this, etc. And then you're going to be able to see how long it takes for each one of these things to be generated. Now, of course, there's a bunch of variables in here. Okay, we're late initializing. Is that impacting it? If you're looking for very, very fine-tuned ways to tune it, this is not going to be your solution. This will be just something to help you kind of gauge whether or not something is slow and how to do it very easily. So here we can see that the averaging itself takes about 8 seconds. So generating the list took a little over 9, almost 10 seconds, and this takes almost 9 seconds itself to calculate the average and print it. And that's how you can use the measure nanotime to create a measure block, which then you can use inside of your application to measure chunks of code to see how long they take to execute. To understand sequences in Kotlin, it's important to understand how lists operate over list of data and how the mapping operations occur to each of the list items. So what we're going to do is create a list of strings, and then we're going to filter that list, and it's not really going to filter anything. It's just going to go ahead and process it and print line, and then return back true, basically saying all the items will be included. And then finally, we'll go ahead and then print line it at the end of each one of those. Now, for each is one of the things we're doing here is actually showing that a list is eagerly evaluated. So each time there's an operation, a new list is created. So what that means is if I were to perform this same filter operation twice, and I were to say hello here, what would happen is Kotlin is then going to create it's going to take the list from the beginning, and then in the filter function, it's going to create another list. And then from that list will then be turned in and sent into this list right here. And when this one is done, that list will then, a new list to be created and sent into here. So basically, we're having this type of thing happen here, where these lists are being created over and over and over, but they're new lists. So this is a list off of this one. This is a list off of this one. And then a new list is finally created that we have a list down here. So Kotlin is lazily evaluating those. And the easy way to see that is with this function here. So let's go ahead and run this. And what we're going to see here on the screen, down here on the bottom, is that we have the filter was run for every single item in the list, and it didn't progress into the next function until all of the items were processed in the list. The same thing here, and then the same thing here. So as each item walked down, so this function did these ones, this function did these ones, and this function did these ones. So it operated it one at a time. This one, then this one, then this one. And that's what's happening behind the scenes. Now, this can become problematic when you have very large lists or many processing steps inside of your list, because if they are processing intensive, then if we're creating a new collection each time, eagerly evaluating it, we can just start slowing down the process. So let's see what that kind of looks like if we were to use a sequence. Okay, so I've copy and pasted some code, and I've removed the additional filter up here. Now we have down here almost the same exact code. The only thing that's different is we have the sequence of, and what the sequence of is, returns a sequence, which is basically something that can be iterated over. And a sequence returns a value through its iterator. The values are evaluated lazily. That's the key. Values are evaluated lazily, while lists are evaluated eagerly. So we've created a sequence of this. Basically, everything else is the exact same for both of these. Now, if we run this, we're going to see the difference here in the output. And so we have the line that's separating down here at the top from the bottom. So up top, we have new list was created, new list was created. We can tell that because all of the items were processed in sequential order before it moved on to the next map operation or the next operation inside of the chain. However, inside of a sequence, we can see that the filter executed for the first value X, and then X moved on to the next value, to the next operation, which was for each. The same thing for Y. So as each item is coming out of the sequence, it's processing through the entire chain until it hits down here, hits the termination. And so each item is processed sequentially, so as a sequence. So if you have a very large list, or you have a very high intensive chain of events that are being processed, it's recommending that you use a sequence because it's much more performant. Now, if you have 10 items and you're only performing a couple of operations on a list, should you use it? We don't know. What if it's 100? We don't know. As the saying goes, what gets measured gets managed. So how do we measure if something is slow or not? Well, let's go ahead and delete this code. And let's go ahead and generate some code that has a very high number of values. Now, the code that I'm showing you is actually from a gentleman named Benjamin. And if we go over to, I found this blog post quite a while ago, and it's been the one I've relied on for years on these sequences. And he talks about all this stuff in here, and I'll provide a link to it. So I'm actually using the same exact example he's using to show how performant some of this stuff is. Very, very useful. Thank you, Benjamin. Just wanted to give you credit for writing this phenomenal blog article. And I'm basically explaining a lot of what's covered in here, though he does go into some more detail with some other information. Okay, so let's go ahead and get some code to actually show how to measure things. Okay, so I have some code in here, and this code does a couple of things. We're generating a sequence as we can do, which is built into the Kotlin standard library. So I'm generating a sequence. I'm going to seed it with a value of 1, and then for each iteration, again, generate sequence is in the Kotlin standard library, and it basically says you can give it a seed value, and then we'll invoke the next function for every single time you want something from this sequence. And so I'm going to tell it to just increment that value, and I want it to do it 50 million times. So I have a sequence of 50 million items, and then I say, hey, turn that into a list. And so now I have this list of 50 million items. which is a very large list, and this can be processed on a laptop. So 50 million integers in a list, and then what I want to do is filter it, so find anything that's divisible by 3, and then average that out. And of course, we're going to get a value back, so let's go ahead and grab that value, this result, and we can go ahead and put everything back up on a single line here, because that kind of makes sense. And then we'll do is print the result, print line, and we'll do result. And then what this measure method will do here, which is what you've probably been wondering about, it takes in a block, and a block is just a unit of code, and this measure function is explained in another video, but basically shows how long it takes this chunk of code to execute. And so this is what's passed in. And so let's go ahead and execute this, and then what we're going to see at the end is how long it took in milliseconds to process this. This could take anywhere from 8 to 20 seconds, depends on my machine today. I've seen it kind of range all over the place, depends on what's happening on my machine. And it's still running. We can tell this by the stop icon is active, which means there's something running. The green little dot there also helps us indicate that something's running. There we go. Something came back. So we have the result, which is 2.5 to whatever power, etc., a very large number. And it took us 18,000 milliseconds, so basically about 18 seconds to run this process. So, okay, so we have a list, we're processing over the list, and remember how we executed those things before. So let's go ahead and change this, and instead of making this a list, let's go ahead and make this just a sequence. And so to do that, I'm just gonna remove this list here, and instead of calling this a list, I'm gonna change the name to a sequence. So now this is a sequence, so it's almost the same exact code. I've just changed the variable name and removed it from being a list. So let's rerun this to see how fast it is to process a very large list and do a couple of operations. Boom, we're already done. So 50 million items with a sequence took 628 milliseconds. And if we did it with a list, it took us almost 20 seconds to do. So it's orders of operations much more efficient to use a sequence in this manner. At what point should you use a sequence? That's up to you to decide. Should you be using a sequence? If it's 10 items, depends on how much processing you're doing on those 10 items. Are you doing 100 operations on it? Maybe it's important to use a sequence then. What if you have 100 million items and you're only doing 2 operations on it like we're doing here? And we're only doing a filter and an average. Should you use a sequence there? Probably so. But what if you have 10 operations, it's not really doing much calculation, and it's only maybe 10 items in the collection. Should you use a list? Maybe, maybe not. It's up to you to decide. I wouldn't focus on making sure that everything is performant. That's premature optimization. However, you can use this nice little handy measure block, as we have here inside of your code, throw it inside of a utils folder or whatever, and then measure something. If you find a piece of your code kind of being really slow, I highly recommend slapping the measure block around it. It'll give you a good rule of thumb of like, all right, is this taking a long time, or where is this slow? If you find your processing around a large list or list operations to be slow, at that point, it might be in time to take something and make it a sequence, which it could be also very interesting. So let's assume that for whatever reason, we have a method, right? And this method is called get list of customers. And this list of customers comes from a database, right? And it's going to return a list of data. And it's just call it just integers for now. And then what we'll do is I'm just going to do this right here. It's going to return a list to that to list. We're just going to pretend that this is from a database. So I'm going to pretend it's in the library. I'm going to get this out of here. Okay, whatever. So now I'm going to have I'm going to change this to list. Actually, we'll leave a sequence. Actually, we're going to change it back to list, and I'll show you why in a second. So we're going to say this is list, and we'll say val list equals get list of customers. So there we go. Now we have our list of customers. We're going to perform some filtering on it, and it's going to run. Now, as we know, this is going to take a long time because this list of customers here is a very, very large list. Now, again, we're generating this on the fly, so let's go ahead and pretend you don't see that. Let's assume that it just returns a list and we don't have control over that. But however, now that we have this large list, however it's been processed, maybe on a background thread, but now we have it and we need to process it, we now have control of it. So this is a very large list. Let's go ahead and run this again. So we have that list of customers. Actually, we can go ahead and let's assume that this is out of here because we don't want to measure that component there. So we have our list of customers. That list of customers is gonna take probably 8 or 10 seconds to generate because it has to turn it into a list. And most likely this block of code will probably take another 8 or 10 seconds to execute as well. So perhaps this is on a background thread. We can't control that. That just is what it is. And maybe we're gonna get that data back. But now once it's off that background thread, we can control it. So for example, it takes 8 seconds. So at that point, how could we speed this up? Well, because this is a list at this point in time, everything's running slow. Now, thankfully, there's actually a nice method on the collection here called as sequence. And what this will do is we'll turn this, I'm gonna go ahead and break these into new lines here. This will turn this list into a sequence. And so what this will allow us to do is get some performance benefit as treating this list as a sequence. And then from this point on, after this line, everything will be operated sequentially as a sequence would. So let's go ahead and rerun this. And as we're running it here, we're waiting. And of course, it's going to take a while because we're assuming this is on a background thread. It's going to take a while, 8 or 10 seconds. And then once we get our result back, boom. Now this code has been measured. Previously, it took almost 9 seconds to run. Now we turned it into a sequence via the as sequence helper method. And we now have transformed this from a 9-second operation into a 244 millisecond operation. Orders of magnitudes faster, just by slapping on as sequence. Now, of course, you're not going to get this benefit if your list is 10 items. You're not going to see that drastic improvement. It's going to be very negligible at that point. So follow the mantra of whatever gets measured gets managed. If you find a slow piece in your code, see what's taking a long time. If it's around a list or a map or something like that, perhaps you need to figure out a way to turn it into a sequence so you can get some performance benefit out of it. And of course, be sure to check out the blog link in the show notes. So big hat tip to Benjamin for demonstrating a perfect example. I tried to create my own, but his example was just so succinct and great. Thank you, Benjamin, for doing that. What's the difference between a list, a set, a map, and a sequence? Well, a list of data inside of Kotlin can be a list of anything. It can be a list of primitive values such as strings, as we have here. So we have some names: Don, Tushar, Kavita, Evelyn, Felicia. This could also be a list of integers. So we could have a list of integers of 1 to 12, 23, 44, 66, etc. And they can be a list of integers. It could be a list of objects. So anytime you need a list of data to work with, you're going to want to use a list. Now, as you can see here, the list right now is strongly typed to be a list of string. And again, if you need it to be a mutable list, you would type mutable list of, which means this is a list that you could change. So same thing goes for almost any of the collections inside of Kotlin. If you want it to be mutable, you'll actually slap the word mutable at the beginning. So when do you want to use a set? Well, a set, remember, only includes unique items. So in this case, I've created a set of these 4 items: Don, Tushar, Don, and Tushar. Now, when we actually print these out, if we were to print it, we would see that this set actually only includes 2 items because a set does not allow multiple duplicates of an item inside of there. So here it's going to see that Don is then presented twice, so it will not add the second one. And the same thing for Tushar has been added another time, so it will not add a second one. And this result will only be in this set, be Don and Tushar. So if you need your items to be unique inside of, basically you need a unique list, you're going to want to use a set. So what about a map? So when would you use a map? Well, a map is basically a mapping of one value to another. And I like to think of it as a key value pair. And that's what this is a map right here with the helper. Is we have the key, which is a string, and the value, which is a string. Now, this does not mean that you have to always use string and string. So we could say map to, we could actually say map of, and then we could say 1 to Dawn, and then we could say 2 to Tushar. And what this does is it creates a map with the key being an integer and then the value being a string. So you can create a map of all different types of things. If you wanted to create it as an object, you could create it as its own custom object. If you had, say, a data class, it'd be person, and we maybe had val name, and it's a string. What you could do is you can make this map turn to person Dawn to maybe he does Android. And we want to have a map of person Tushar which then maps to, let's say he does J2EE. And at that point, we now have a map where the key is a person object and the value is a string. And of course, it could be flipped around. There's no rhyme or reason to what you would want. It's just a data structure that allows you to have a map and a key. So if you ever need to have a map and a key, you're going to want to use a map type data structure. All right, so when would you want to use a sequence? Now, a sequence is basically going to be anytime you want something that's going to be more highly performant. And this could be if you have a very large list, so maybe 50 million items in a list, or you have a bunch of items you need to process. So you have 100 items in a list and you need to process it through a bunch of different maps. So you're going to do list.map, and then you're going to do another map for whatever reason, map, and then you're going to do it for a reason, you're going to do a flat map, and then you're going to go from there and you're going to do a filter, or you're going to do an average. Actually, it's not going to work that way, but you do map. It won't work on a flat map because you have a list. And then so you have, some averages or whatever you get inside of here, and you could filter and all different kinds of things. And let's say, assume all these different things had very complex, calculations that took a lot of time. Because lists and so forth are evaluated eagerly, a new list is created each time. Then there's actually a lesson that you can view that will show the performance metrics of actually using a sequence over large lists. And so if you need performance, you'll want to use a sequence. Now you can also take a large list and turn it into a sequence. Here, you can also turn a map and turn it into a sequence as well. So if you have a large map or a large list and you need to process it sequentially, you can just slap as sequence on there and it will process accordingly. And then you can make things very quickly. And then if for whatever reason, after you're done processing the sequence, you would like to turn that sequence into a list again, you can turn it into a list as well. Of course, you're going to want to measure the performance benefit. So sequence usually used for performance. So if you have large lists, large maps, or you're doing a lot of mapping operations, you're doing a lot of operations, on the data structure itself, then you'll want to go ahead and turn it into a sequence or use a sequence if possible. And of course, you can always use generate sequence. So that's the difference between a list, set, map, and sequence. Kotlin does not have a ternary operator. So if you're looking to do something like this, let's assume we want to get the length of the string, but we only want to do it if it's not null. Perhaps we could say something like this. You might be used to doing like this. If name does not equal null, then we're going to do name.length. Otherwise, we want to do 0. So you may want to do something like that. You'll see here we have to use some weird things. It's not letting us do this. This is because the ternary operator does not exist in Kotlin. So to do this, you need to use a single line if statement. So if name does not equal null, you can do name.length, else 0. Now this will give you the length here. So we can see print line length. And then you can run the code here and you'll see that the length is then returned. And for whatever reason, if this is null, we can return that. And then we'll get 0 because it's handled accordingly. Now we get this nice little use here where we can replace it with the elbow expression. If you know what that is, you can use that. But if you are looking for a ternary operator in Kotlin, it does not exist. So you want to use a single line if statement instead. It's very often that you could be working inside of some code and you may need to do something. For example, you may need to get the length of the name of a particular value, maybe of a string, and you want to say name.length. Now what you'll notice here, because we're working with a nullable string, that we cannot do this. Only save calls can happen. So we're going to get back. We could change this to a save call. This would give us a nullable integer. However, if we're working in an environment where we do not want to work with nulls, this is not going to work for us. So there's a couple of things we could do. If we can change the data type to actually be non-nullable, that would be fantastic. However, sometimes data comes back from other libraries, such as Java libraries, where the nullable type is just going to be there and we can't do anything about it. However, we may understand at some point in time that we know for certain that this value is not going to be null. Now, this says something I usually don't recommend, but there's a way to do that. And we can use the double bang operator to tell Kotlin, look, I know what I'm doing. I know that the name value is not going to be null, which we can see directly from here. There's no way, nothing in line 5 that's making this not null. we're making this null. So we're basically telling Kotlin, don't worry, I know what I'm doing. Trust me. Just go ahead and treat this as something that's not null. And then what will happen is we'll go ahead and we can say print line length, and then we can run it. And then what will happen is we'll then have a int value, which is, again, it's only going to be a regular integer. So it's not gonna be nullable. And then we'll get the length of 4. Now, the real challenge comes in here when you're telling Kotlin, hey, trust me, I know this is not going to be null, but for some reason it ends up null. And this can end up showing up inside of your code multiple times. So if you find yourself doing something like this all over the place, you might want to inspect your code to see if something is correct. Now in tests, you may have it a lot, but in this instance, perhaps I said, hey, this should not be null. Maybe this code on line 6 is buried somewhere in a method somewhere. What will happen is when Kotlin says, hey, go ahead and just treat this as a non-null value and give me the length on it, and it's null, it'll throw a Kotlin null pointer exception. So this will blow up your application. So you do have to be careful in this regard to see if you want to actually work with this. So again, if you know what you're doing and you want to tell Kotlin about it, you can go ahead and say, hey, Kotlin, I know what I'm doing. Use the double bang operator. The same thing could go for a class. So if we have a person, and then we have a val name, and that's going to be a string, we could actually say something like this, and we could have a nullable person. We could say person, and that's going to be a person that's nullable. Again, maybe this comes back from an API, and it could be empty or whatever. And so person could be Don. At this point in time, I could say, if I want to kind of get the value, say print ln, I want to print the person's name. Well, this is not going to work because, again, person is nullable, and Kotlin is saying, hey, we're not sure if this is a safe call because, well, person's nullable, and this could end up being a null pointer exception. So I could handle it this way, and if I did handle it this way, if we ran it, it would still work. We would get the person's name, it would be Don. However, if for some reason this was, we'll comment that out, and this was null, we're now going to go ahead and we run this again. It's going to show up as null, but again, maybe we don't want that. We want it to say, hey, trust us, we know what we're doing. So you can use also the double bang operator inside of here. Again, if the value is null as it's happening here, you're going to get this Kotlin null pointer exception. So if we were to just remove this, again, it's going to work as we expect. But usually my recommendation is if you see yourself or wanting yourself to add these values all over the place, you might want to figure out if there's a way where you can not use that or use something like require not null, which is in another video and linked in the show notes below. In some Kotlin code bases, you may find yourself wanting to type the double bang operator to force a nullable value to not be nullable anymore. You're basically telling Kotlin, hey, trust me, I know what I'm doing. This can happen for regular primitive nullable types such as the strings, integers, etc., Boolean values, or it can also happen for the nullable objects such as a person object that we have here. Now, there's a way around this. If you don't want to type the double bang operator, you can also use something what is built into the Kotlin standard library, which is called require not null. And require not null basically will turn this value, which if we look at it, into a non-nullable type. If it's null, though, it will throw an illegal argument exception, otherwise returns the not null value. So if we run this here, what we'll see is it'll continue to run. That's fine because we have the length of the name. This has now been turned into a regular string, not a nullable string. However, if for whatever reason this comes back from an API or a database or something, and that value is null, and we process it, what will then happen is Kotlin will throw an illegal argument exception saying, hey, the required value is null. Now, to be honest, this error message, while helpful, this required value is null, in a large code base, this is not very helpful. This can be kind of like, okay, there was a null value somewhere that we shouldn't have got. Where is it at? Okay, let's look at the stack trace. There's a stack trace. Let's go investigate it. Sometimes it helps to have some additional information inside of there. And so you can do that. There's actually an overload of this, which will allow you to provide a lazy message, which will be the result of that being called. And so it can be a function, and we're just going to go ahead and use the lambda, and we can say something like, the name should not be null, but it was, exclamation point. And now if I run this, we'll still get an illegal argument exception, but we'll now get the message the name should not be null, but it was. And you can provide some additional information inside of here Perhaps it might help you debugging if you are throwing an illegal argument exception and you have a crash handler on your application. Maybe you have an Android application. This information is going to show up inside of your crash tracking utility. So you might be able to say, hey, here's the value that came in. You could throw additional information inside of here that might help you diagnose what it is. Sometimes maybe a backend changed and they are sending a nullable value that was not supposed to be nullable, and you're not expecting it to be null, and things blow up. And so you can just say require not null, and that'll get you around it there. Now, there's also, you can do the same thing for objects as well, not just primitive types. So we have this person here. Perhaps we don't want to use a double bang operator here. We can go ahead and say require not null. And again, it's just going to take this object and make it to this not null type. And there we go. And if we run that, everything should run accordingly, except we're going to get that exception. So let's fix that. That's the exception from up here. So we'll just say Don. And if we run this now, we'll see that we get the Don, which is down here in the bottom, which is from this print line down here. So we can actually just go ahead and get rid of that to make it easier. And then if for whatever reason this person was null, same thing happens here. So you can say require not null on an actual class. You'll get the same thing. The required value is null. Again, just like the other version, it's the same exact thing. You can put some other message here, so hi friends. Not that you would want to do this in production, but this basically, and that needs to be inside of a lambda. So that just needs to be there, and then it'll actually show up in there. So hi friends, you can put any message you want inside there. So person should not be null. There we go. And then once you run it, you'll see that the person should not be null. And that's how you can use require not null inside of your application. So you may have some code in your application that looks like this. You have an object, it's a person, and for whatever reason it comes back from an API as null, or it doesn't. And then inside your code, you're using the double bang operator to force the person object to not be null. So of course this wouldn't work. You could do something like this. This would also work. It's actually much cleaner in my opinion this way than forcing it to be not null, because we could run into situations. But if for whatever reason, let's say you do have that, or you're using require not null, and require not null will basically turn that nullable person into a regular person. However, there's also check not null, and check not null basically does the exact same thing as require not null. And if we go to the implementation here, we'll actually see that check not null, which is down here at the bottom, is basically the exact same as require not null. So let's go ahead and shrink this down. See if we can get it all into the same screen. Very close. So require not null is up here. And then we have check not null, which is down here. And we can see it as a contract for require not null, checks the value, we get the lazy message. And if we look down here, the code is exactly the same. So it's doing the same exact thing. It's basically checking to see if it's not null, and requiring it if it's not null. And if it does, if it's there, it returns the value. Otherwise, it doesn't. So you can use either one of these, check not null or require not null, depends on what you like to do. I have seen in multiple code bases where a check not null will be somewhere randomly in the code base, perhaps after an API call, just to make sure that the user is not null. And then at that point in time, the person might be a var, if that's the case. So if that's the case, it might be var person equals check not null, or person2. At that point in time, check not null, so you then have a nullable version. So you can either use require not null or check not null. Let's go ahead and assume you have a list of names or some list of data that has come back from a database, API call, or anything like that. Here we're just creating a list of names, and we have a couple of null values in here. Now it's very often that, for example, we now have a list that is a nullable string, so a list of nullable strings, and in our application, or maybe even a library, that does not allow a list of nullable strings. All the values have to be present. So what can you do here? Well, there's a couple of things you could do. You could go through each one of these things, and so we could say you could filter them out. You could map them to a correct value, or if you just want all of the items that are not null, you could say val names that are not null, and you could say names.filter not null. So a nice little helper method there, and then you can just go ahead and print line that to the screen. name that are not null. Let's go ahead and fix that because it should say names. And if we go ahead and run this, what we'll see is we're going to have all of the names and we are not going to have the null values. So very easy to filter out a list of all the non-nullable types. So if you don't want nulls in your list and they are already there, you can filter it out with the easy filter not null method. One of the keys to understanding Kotlin is understanding the type hierarchy system. So this is a great diagram, which is actually used over here from this gentleman who created it, which is Marcos Sandoval. So thank you, Marcos. This is a great diagram that illustrates the Kotlin type hierarchy system, which basically states that any non-nullable type is always going to extend the any type, and any nullable type will extend the nullable any type, which we can see here. And then we have also nothing in there, etc. We'll get into that later. So Boolean, string, a class you create, unit, number, everything extends any. So you can use any or the nullable any type inside of your functions as a parameter type. So this is very similar to in the Java world of using object. Now you can actually test this by writing a simple little program, and we'll say val age equals 32, and we could say something like this. If age is any, then we can actually say print is any, and that would tell us if this is any. Now this is how we can check for types inside of Kotlin. This is type checking. We're checking to see if age is of this particular type. Now I could change this to say, hey, if age is a string, and we're going to see here the incompatible types, type, string, and int. Well, it already knows, the compiler knows at this point in time that this is not going to work. So what we could say is, I could change this to the type any. I could say if age is a string, then it would print that off. And if we run this, we'll see we get nothing back. So let's go ahead and add an else statement here. Print ln, not any. Now if we say not any, well, this is a string, so we're just going to change this to it is not. And so is age, which is any, does it equal a string? No, it's not. Okay, well, is it a int? Let's run that, see, is it an int? We see it is. We can change these to different values. So we say, is it a double? And we can run it. Is it a double? It is not. So this allows us to start doing various different types of things. We could change this to, because again, string, let's use Dawn actually, is a string, and we're going to see that it's not a double. But again, it still compiles. Is it a int? No, it's not, because it's an int. But if we were to change this to string, then we would see that we can actually easily type check it. Now this also works for other, your own custom classes too. So we could say a data class, say create an order, and maybe it has an amount, which is an int, and then maybe we have just a regular class that is a person, and this person has a name, which is a string. So we could create an object here, say val obj, and we would call this, again, we're going to say, hey, this is any. So we're kind of we're using the root object here, and we're saying, hey, this is any, and we're going to create this person, and its name's going to be, let's call it Bob. Bob. And then what we can say, let me get rid of this age thing, we'll say this object is string. No, it's not. So it's not a string. And we see that it is not. However, it would be nice to see what kind of object it is, and we can do that pretty easily. Say print line, and we can just inspect the object, object.javaclass.name, and this will give us the name of the Java class that it is. So is this person a string? No, it's not. It's a person class. So let's change this back to a, let's go to 16.0. Let's see what that is. So is it a string? It's not. And we'll see it looks like it is a double. And then we can also print a, we could change this to, we could change this back to Bob. And of course, this is going to say it is, but let's go ahead and change this to int now. And if we run this, what we're going to see now is it's going to say it is not, and the type is java.lang.string. Now we can change this around too. We could say, is this any? Now this is just going to execute for everything. It's just going to say it is. So it is. We could say 12. We're just going to say that it is. And we could say for a, the data class order, which is going to have an amount of, 120, is object any. It is. So any is the root object of anything So this allows you to do some cool type checking inside of your application, because you may have an application that returns, you're working with some different types, and for whatever reason, it returns back an any, which can happen for some various reasons. And so if, for example, let's go ahead and pass in a string. So value, and that's going to be a string, and we'll use a when expression, when value, and when we say the value is 1, then we want it to return, say return here. Return 2, and if we return 2, we're going to return a hello. If we're going to return if we say 3, then we're going to return something else, such as true, the Boolean value. If we ask for 4, then we're going to return a double. And so we'll say 16.0 or 1. And then, of course, we have to provide an exhaustive else, because this could end up being a certain value. So we can get rid of that. There we go. And now at this point, what we can do up here is we can just say, what we can do is, if we were to say get stuff, and I were to pass in the number 1 there, what that's going to do is any is going to return to it is. So, but let's go ahead and change this to string. So if my method, maybe a library I'm working with, returns an object or any or something like that, I can do the type checking with the is keyword. And so it's not, so it's an integer. What about number 2? So whatever this method returns is an any, it is. So now I can actually do this and do different type checking and perform various different operations based upon the type checking if I'm working with the any type. Sometimes you have a method that returns any, and you need to cast that into a particular value. So maybe we know that we need this to be the age, and it's going to be int, and so we need to cast this into an integer. So we could say obj.asInt. And when we run this, because the obj is an any value, if we run it, we'll go ahead and see that it did execute correctly, and we forgot to print it. So if we print this to the screen, we'll see that it was run as obj to 99. Now, if for whatever reason we were working with a string and we wanted to use a name, so let's just call this casted so it's easier. And this was a name, and we'll call this was a string. We're expecting it to be a string, and we want this to be cast to a string. And of course, we want maybe our method, assuming this is from like an API or something like that, or some library that gives us back an any type somewhat for some reason. We know that number 2 returns hello. We can then cast that to a string, and then at this point in time going forward, we now have a string. And what that gives us is the ability to actually use different, for example, I have the length. I can do all different kinds of stuff with this as well. Let's even take this a step further and say that I had a data class person, and that person has a name, and that's a string. Then what I could do inside of here, if we say 5, I would then return back a person with the name of Don. Okay. And then, so this is going to work because I'm going to have 2, and I'm going to return back the value of 2. But I could also do something like this. I could say 5. Now, this, of course, is, if we look at object, obj, what do we have on it? What is it? It's any type, as you can see here, it's any. So the things that we can do with it, I can't, if I know that when I pass a 5 in, I'm going to get a person, I can't say any.name. Name doesn't exist because I'm working with an any type. So I need to cast that to a type in which I can work with it. So 5, let's go ahead and cast that to a person. I need to make this person. And now I have a person object. And what that means is now I can say casted. And now I have the name, and I also have the copy method, which is built into data classes, and everything else that data classes also have along with it, or any other class that you're working with. So now I can access the name. So I've basically turned this any type right here, any, and I've turned it into a person. So now when I work with this person object, which is right here, I can see that it's a person, and I can use the type system accordingly. So if I run this here, we'll see that we can run, and we can get the object turned into a person. And that's how you can perform casting in Kotlin. Let's assume you have a method called getStuff, and it can return an any type, which is the root of all types in Kotlin. for non-nullable types. So if you pass in a 1, you get an integer. If you pass in 2, you get a string. 3, you get a Boolean value. 4, you get a double, and anything else, you get a false. So sometimes we need to perform various different casting. We need to cast it to a particular value. So I'm going to create a new variable called casted, and what I'm going to do is say obj as int. And so what I want to do is I want to get this, I want to cast this value that I get back to an integer. And so when I try to do this, I'm going to run this, and what we're going to see is we're going to get an exception. And the exception is a class cast exception, basically stating you can't cast a string cannot be cast, to an integer. And that's because the value we got back from get stuff, we passed a 2 in, 2 came in, executed this line of code, we returned the value of obj was hello, and we're trying to cast a string as an integer, and Java says, nope, no dice, that can't happen. So we got a class cast exception. So how can we solve this? So we can't cast it this way. So what we could do is we could do some type checking. We could do if object, and we change this to as is int, we could get back the obj, else maybe we want to return to 0. That would work. We could run this, and this would work accordingly. We'd get back 0 because object is not an integer. If it was, so if we came back here and we change this to a 1, which again would return us back in any value of 1, we'd get back the 1 there. And actually, let's go ahead and change this to, just so it makes more sense, let's change it to 99. And so when we pass in 1 for the value of the get stuff method, we'll get back 99, which executes this line right here. And since it is because an integer, we got this back. That makes sense. However, there's also another way that we can do this as well. Perhaps we're okay with working with some nullable types. One thing we can do is we can cast it and do a safe cast. And what that safe cast is, as an integer. And what this basically says is, hey, I would like you to, so I'm going to change this to 2. We'll do that in a second. We'll do that. I would like you to try to cast this object right here, this object, as an integer. And so when this piece of code executes, if it can execute it as, and it can do it, it'll return the integer. Otherwise, it'll return a nullable type. So if we run this right now, we're going to get back 99. That makes sense, because if we pass in 1, we get back 99. So let me change this to 2, which is going to give me back a string. Now, if I run this, what we're going to get back is null. And the reason for that is because this line of code right here that executed said, hey, this object is actually null. And so the smart cast said, hey, I recognize that was null, so I'm just going to go ahead and give you back a null value. And at that point in time, we can continue on and our application didn't crash. And that's how you can use a smart cast. So this could be anything for, Boolean. Can I pass that to a Boolean? And if we run that, is that going to work? Let's see. No, that's null as well. It's not true or false, so we can't do that. So anytime you need to cast something and be safe about it with a nullable type, you can use a smart cast, which is the word as with a question mark after it. You've probably heard the word generic tossed around inside of Kotlin various times. And the word generic just means that we're using a class or an implementation in a very generic manner. And so here we have an interface, which is a list, and then it has this weird little parameter. Ignore the out for now. And it has this little e, and that e is the type of elements that are contained within the list. And so this is a collection, which extends collection, and it takes a type e. So what this allows us to do is have all the same operations, like we can something contains, is it empty? We can use get, index. It allows us for high levels of code reuse and allows us to specify different types, so we still have type safety. So I could do a list of strings, or I could do so it's called list of strings, or I could say val list of ints, and then I could basically easily say list of int, and say list of, and I can say 1, 2, 3, whatever. And I can have my list of integers. And now they're all both going to have the same operations. List of strings, I'm going to have the get operation. I'm going to have in a list of ints, I'm going to have the same get operation. Now, a lot of these things are already built for you. So a lot of these generic operations and generic classes, such as a list and a map and a set and anything like that, have already been built for you. And so it's very easy to use them. So if you want to use a map, you can specify a map and say map, and you can specify the types that you would like as well. So the key is going to be a string and the value will be an int. And then perhaps you want to create a map of that. And you don't have to provide these type parameters because it will be inferred from the map creation. But here I'm just being very explicit about it. So I might map Don to 32, and I might map, Tushar to 42, and so forth. But now I have a map, and the string is its key, and the value is its int. And this is all already built for us. So here's just using a map interface. And so there's a bunch of different maps that are implemented inside of the Kotlin collections library, and all different kinds of things. So you can see, so we'll go map dot entries, and we can look inside of there and see all the various different entries. We can do different, for different things such as map dot map, which is kind of weird sounding, but it's part of the maps function and allows us to transform items inside of there. But the key thing here is that all of that common functionality is buried inside of these generics. So you don't have to worry about building a list just custom for strings or a custom list for integers. All of that's buried behind the generics themselves. And the good thing is you can actually build your own generic classes, which I'll show you in another video. However, these are the all basic built-in different types of generics, and very often when you're looking at the documentation, you're going to notice these single letters. So E in this case is going to be the type. Sometimes you'll see multiple different types. So if we go look at a map, you're going to see different types in here. You're going to see K and V. Now the letters, they don't have to be letters themselves, but they're using very good terminology here. K for key and V for value in this case. And so up here, this the E I think is for element of the list, and so it's a very element. Now you could actually, if you're building your own generics, you can actually provide a full-on word for the different type if you would like to. But a lot of these things are just that way. So that's what generics are. They allow you to encapsulate common functionality across a large swath of code, and folks can end up using them for various different things. So for example, here's a mutable list that extends another one, and all that's doing is saying, hey, we're going to use all of the exact stuff from within the list and everything from within mutable collection, and we're going to create mutable list. And by the way, here's how we're going to override this remove function, or here's how we're going to do all these other different types of things based upon this type of collection. So these are the generic kind of collections classes. There's a whole swath of things that are all generic inside of various different apps you're going to use inside of different libraries. HTTP libraries will have you returning a different component. If you're using reactive libraries, it'll be working with reactive streams of different types of data and so forth. And those keys and values and etc. are all performed and mapped inside of the various different generic classes themselves built by the developers. And so these are all the built-in ones, and this is how you can kind of understand what generics are at a very high level. Okay, let's assume that you want to create your own generic class. So the first thing you need to do is define a class, and what we're going to do is create a class called evenList. And evenList is going to give us, we're going to take in a list. So here we'll say list, and this will be a list of type T. And then inside of here, we're going to do something, or we're going to return, so function, and then we'll say items. And then what we're going to do is we're going to return a list out of this, and it's going to be the same type T. So notice how I'm not providing anything inside of here. So what this class is going to do for us is a generic class, and I'm basically saying, look, this class is going to hold a bunch of things, and they're going to be of type T. It's going to hold evenList is going to be of type T. Don't know what it is. The constructor is going to take a list into it, and it's going to be of type T. So basically, if it's a list of strings, then it'll be evenList of strings. And then what will happen is I want to return the even items. And so I'm just going to go ahead and return those even items. And to do that, I'm going to say return list.filtered. Now I need to put val on here so I can get access to it. Val.filtered index. And then what I'm going to do is pass in a lambda, and that's going to give me an index and a value. And then from here, what I can do is say index modulus 2 equals 0, which means, hey, if it's divisible by 2, if it's a second item inside of there, then, if it's divisible by 2, so 2, 0, 2, 4, 6, 8, 10, then go ahead and return the item. So only return the even items in this list. So I have not actually specified that I'm working with strings or integers or anything. And here I'm using this type T. So how would I use this class? This is a generic class that only works with even items. And perhaps for whatever reason, I want this to be something I can use all over my application because I am maybe building some type of game where I only work with even ones. And, of course, I could build another one called odd. So to do this, I could say val result equals even list, not event list, even list. Now I could specify a string here. I want it to be string. And I need to pass in, I'm going to pass in my list of strings. Now look, the IDE says, hey, we can remove the explicit type arguments because it's going to be inferred because you're passing in a list of strings, and we already know that this list of strings is this type right here is a string. So we already know that you're a string over here. So you don't really need to tell us that it's a string. We kind of already figured that out for you. So you don't need to provide that information. So then what I can do is I have my list of strings. So now I have an event list of strings. And if I wanted to print out the actual even ones, I could say result dot items, which is going to call this function here. It's going to call the items function. And maybe we even want to call this even, be a little more explicit here. We'll call it even items, which makes more sense, result.even items. And if we print this out, what we're going to see here, and we're only using the strings right now, let's see Don and Mary. Well, now the power of generics really comes in that you can reuse it with different types. So let's reuse this again. Let's say val result. Let's say other result, because we need another variable. And this one's going to be event list. And this time we're going to take in a list of ints. Not event, even list. So we're going to take a list of integers in, and we're going to print this out. I'm going to say result dot even items. And when we print this one out, we're now working with integers. And I used the wrong result. There we go. And if we use the other result, which is the proper one, we'll now see we were able to reuse this class's exact functionality. I didn't have to write it twice. I'm now relying on a type, this is called a type parameter, the type T, to do some work for us. And if we can look at this value, look, if we go over here and actually we're going to do something with a value actually, we can see the value over here is actually type T. So I don't know what that type is. I could say the value is of type blah. Now I could do as the value is a string. So if I pass in an any into this, then we could do some type of stuff inside of here. Now that's going to limit me on what I can do, but depends on my implementation of my generic class if that's what I want to do. So here now I have an even class that will work exactly with these. And I could, again, we could even go a step further and we can go class person, and we could easily do name string, and then we can create a list of people. So let's just do that. Val people equals list of, and then we'll just do person. And now if I have these people and I want to print it out, we're just going to do this. We're going to single line this right now. So I'm just going to do even list, and then I'm going to pass in my people, and then I'm going to say I want to get my even items, and I'm just going to print that out. And then what we're going to see here is even with my own custom class, I'm getting that. And I can make this a little bit nicer and just say data class, because data classes will give you a nice little two-string representation of your class already, as we can see here. Now the two-string is represented, that two-string is built for you by default in data classes. So I can print out everything here. So now I'm only retrieving the even number. So I'm receiving Don and Mary, but Bob is index number 1 and Felicia's index number 3. So we're just gonna, completely skip over that. Remember, because these are zero-based index. So remember that. This is 0, this is 1, this is 2, and this is 3 inside of array index, because we're zero based. So this is why we're getting the even index. So the other cool thing about this too is, like, let's say that you don't really like the type T. I prefer to use the word T because it means type to me, and it's a type system. I could also just say this right here. I could rename this type and just say type like that. And now I could use the same thing. I could even call this something else. If I wanted to call this, tiger. I call it tiger. It doesn't matter what I call it. This is just a type parameter that I'm going to be using. And if I look over here, now this might get confusing because I would never use the word tiger, because tiger has an implicit meaning of an animal. So I see that this value is of type tiger, but that doesn't make any sense. So it's usually good to keep these type parameters to be a very simple name that represents something. So it could be type. It could be, sometimes people use action if it's building something with actions and so forth. However, it's really easy just to use simple single letter types, because then when you're looking inside of perhaps your code and you're looking at the value of something, you can look over and say, oh, that's going to be of type T. Oh, okay, I don't know what that is. That's a type. All right, I need to think about this more. So that's how you can build a very simple generic class and your very first generic class inside of Kotlin. Let's assume that you have a person, and inside of your application, for whatever reason, you can't allow anyone to be under the age of 18. Perhaps it's an application for allowing people into particular restaurants or music events. So you want to make sure that no one gets in unless they're over 18. However, this is an exceptional case, so you want to check to see if the person is over age 18. If they're basically under the age of 18, though, that should never happen. Perhaps these values are coming back from an API or somewhere else. And at this point, you're like, you know what? If I get someone back less than the age of 18, this application just needs to basically blow up. There's something that should happen. And to do that, you can throw what's known as an exception, and you use the throw keyword for that. And so we can throw an exception. And so we have an exception here in Kotlin, and we can provide an error message. User is not old enough. All right, now at this point, if we run this application, what we're going to see is that this person, Donnie, who's 13, little Donnie can't come in because the user is not old enough. Now, the exception is built into the Kotlin standard library, and all it really is a type alias for Java lang exception. And what that means is it's kind of just created a little shortcut for you, like a little link. It said, hey, if you type exception, and this is a type in Kotlin, what you're actually meaning is this actual Java language exception. There's a bunch of different exception types inside of Kotlin, and a million more of them in various libraries. But the common ones you're going to see is just regular exception, where you provide a message, a runtime exception, an illegal argument. Maybe you provide an illegal argument. The state is illegal of the application, so it got into a weird state that it doesn't know how to handle, and it needs to get out. So that's an illegal state exception. Index out of bounds, if you're working with an array or a list and the index out of bounds. Unsupported operation. You're doing something that's not built yet. Perhaps this could be very useful for a feature you're building out, but the function isn't done, but you need to make sure that you do something in the function so it compiles. You could just throw an unsupported operation exception, and then if you accidentally hit that in testing or in code, it'll blow up. And of course, there's various other exceptions inside of here, but this is how you can throw an exception inside of Kotlin. And this can be any other exception here. So if we wanted it to be a legal argument exception, we could say the user's not old enough, user is too young, and then we could run that. And then of course, the output would then show that we then got an illegal argument exception. You want to use the correct exception for whatever you would like, for whatever you're wanting to do, and you can throw that correct exception at that time. And if you're using any type of code in production that's looking for these exceptions, you can start filtering on the types of exceptions that were thrown. And that's how you throw an exception in Kotlin. In Kotlin and in many other JVM languages and most programming languages, you're not limited to the default set of exceptions. You can actually create your own set that you would need as well. So let's assume that you didn't want to use the illegal argument exception, but you wanted to create your own. So you can create a class, and we'll call it illegal age, or let's call it invalid age exception. And usually you'll add the suffix exception to the end of an exception so you know what that type means. If I just typed invalid age, I don't know if this is an exception, if it's an object, or what is it for. But if I say exception at the end, it's very easy to read for what it is. Now, this is a class. I can provide anything I like. So maybe I want to provide the age, which is an int, and then I also want to provide the message, which is a string. And then I'm going to go ahead and make this. I can either make this just an exception, or you know what, since this has something to do with an argument, I'm going to extend illegal argument exception, and then I need to pass in either no parameters or the message, and I'm going to go ahead and create a message that's going to be based upon the other stuff. And I'll say invalid age, and then I'll go ahead and render the age variable, and then I'm going to go ahead and then also append the message here. So now, instead of using illegal argument exception, I can say invalid age except throw new invalid age exception. And of course, it can give me an error here because I don't have the age passed in. So I'm going to say p.age, which is the person's age. And now if I run this, what we're going to see in the output is that an illegal age exception is thrown. So illegal age exception, invalid age 13. The user is not old enough, user is too young. And so I'm passing this message in, and this is, which means invalid age exception is basically a child of illegal argument exception. And so now I've created my own exception. You can create many exceptions as you would like. These can help you inside of your application when things are perhaps not working and your application is crashing. You can see exactly what type of exceptions they are. Perhaps a particular part of your application is really difficult, so you may want to create a couple of different exceptions and you track those inside of your application or inside of your crash tool. Or maybe you're building a library and that library has very particular needs, and so you need to make sure that you're returning certain exceptions from your application and giving exceptional situations. So that's how you can do it. You just have to go ahead and take a class and extend exception, or you can just even extend just regular exception and so forth. And then you can start building your own. So it depends on which one you want to extend. You need to make sure that you can extend it. So there's exception. You can also extend, runtime exception as well. So if you want to make your own runtime exceptions, you can do that as well. So that's how you can create your own exceptions in Kotlin. Okay, let's assume we have some code here. We have a person object, and this person object has a user with the name Donnie and age of 13 and a method called checkAge. And if the age is less than 18, then it throws an exception. And maybe let's assume that this is in a different library somewhere. So we can't even control it. So this is beyond the scope of our things. We have to call into this library to do something. And for whatever reason, this library throws an exception. Even though we may or may not agree with that on the way that the code is working level, sometimes that's just the reality of the situation. I've worked with many libraries in which I can't control or don't agree with how they handle something and they throw an exception. So I don't want the application to blow up. So what I can do is I can wrap this in what's known as a try-catch. And a try-catch is going to give us a ability to catch the exception. So basically what's going to happen, and I want to show you something. What's going to happen is checkAge is going to happen, and then that's going to throw an exception, so we can see the exception again. It's going to throw this exception. Then what's going to happen is basically going to short circuit right here. I could have a whole bunch of code, most likely I probably will have a whole bunch of code down here, and none of this code is going to execute. Because why? Because this thing right here threw an exception, and I need to do something with that exception. And so here, I can actually catch that exception. I can actually get rid of that if I want to. Catch the exception, and then I can do something with it. Now I can decide to do println, caught the exception, etc. Now when I run this, now the application is not going to crash, and we got a typo there. And what we see is caught the exception. Again, we'll fix the typo, run it again. We see caught the exception, but we still didn't get all these values run. Now, this is beneficial because if we don't have this, let's go ahead and comment this out. What could end up happening is our application could run, and then for whatever reason, it just blows up. And maybe we don't want it to blow up. Maybe we again, it's a library or something. We get an exception and we want to do something different. So we're like, oh, wow, okay, this person's age is not 13. Okay, maybe then we kind of, do some other type of code handling, set some variables and do anything like that. So that's how we can catch an exception inside of Kotlin. Now, inside of here, if this were, if we're going to do println exception was caught, we'll say caught for now. If for some reason this person was 23, what we're going to see now is the code is going to run, and checkAge is going to run. That's fine. And then all these statements are going to run, and this block of code right here is going to be skipped. It's completely skipped. So what ends up happening is Kotlin says, all right, I'm going to try to do all the stuff in here. And then if anything bad happens, I'm going to go ahead and basically short circuit down into this little branch down here. Now, that's great. If no errors happen, then all the code in here will successfully execute, and then, it'll continue down here. So we'll say println after try catch. And this is known as a try catch block. Up here, so we have a try catch. And so we'll see done, 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 after try catch. And so that's how you can work and catch exceptions. You can also catch very particular exceptions. So maybe if we can see if this is an illegal argument exception, and what we'll need to do is change this again to something that will fail. So we'll set the age to 13, so it does throw. And then what we'll notice here is that all of a sudden, our application is bombing, but we still have a try catch here. What happened? Well, the reason is because what we're throwing down here is an exception. But what we're checking for is a much more granular level of exception. Here we're checking for illegal argument exception. We're checking, hey, the exception, we only want to catch this if it's an illegal argument exception. Otherwise, just let it blow up. So this is very useful if we're trying to make sure that inside, maybe we have that custom exception again. So we have class, invalid name or invalid age exception. And it's going to pass in a message. And what it is it's a, it's an illegal argument exception. And we pass in a message there. So instead of throwing this regular exception, we're going to throw this one here. And we can see what happens here. And so, looks like it caught the illegal argument exception. Well, why did it catch the illegal argument exception if it's an invalid age exception? Because the invalid age exception is an illegal argument exception. Now, if we were to change this to invalid, let's say invalid class exceptions, which is just a different exception from java.io. It's not going to work because it's not going to catch it. It's an invalid age exception. So a lot of times you may want to catch multiple exceptions at once. So you need to climb up the hierarchy of classes here. So the exception is subclasses are a form of code throwable, that indicates, etc., that things are throwable. So what you can do is just rely on just the default exception. So we can just delete this because it'll use Kotlin's type alias. And we can see here that the exceptions kind of all root up towards the top. And if we use just a high level exception like this, then what we can do is actually provide a when statement. When ex, we can say, is illegal argument exception. We can say print ln legal argument. And when is, we might want to say something like invalid age. Then we want to print something, print ln invalid age. And then anything else, we just want to say print ln else. Something else. Now if we run this, we're going to see invalid age. So if I were to remove this, let me say index out of bounds exceptions. So index out of bounds exception. We're just using an abbreviation. And what we see is invalid age is still being thrown. So I'm going to change this to just throw something else. We throw an illegal argument exception inside of the check age method. And then we're going to see that it caught something else. So something else was caught down here. Now, a lot of times what you want to do is you want to go ahead and rethrow that exception because you are not sure what's happening here. So you want to just say, hey, you know what? Here is the example. We have the exceptions come in, and when the exception is an illegal age exception, do this. When it's an index out of bounds exception, do something else. Otherwise, I don't know what to do with it. Just throw this. Maybe someone further up the stack will catch it. But these are the only two exceptions I know how to handle inside of this try catch block, because maybe will throw an illegal age exception, and maybe some other call down here that we haven't specified yet will issue an index out of bounds exception. And at that point, you can then start catching and handling multiple exceptions inside of your Kotlin program, or rethrow it with the stack trace accordingly, and then you'll get the whole stack trace all the way upside the call stack. So if it's further up, you'll get the call stack as well. And that's how you can catch multiple different exceptions in Kotlin. Let's assume that you have some code here, and you want to surround this with a try so you can make sure that it doesn't fail. You can also, instead of using a catch, you can use a finally here. And you can say println finally. And perhaps let's have something that we're supposed to execute after this. So we'd say println after check age. So we should not see check age execute, because if the user's age or the person's age is less than 18, then we're going to throw an illegal argument exception. But this is to show you that in a try catch or a try finally, the finally block will always execute. So even if an exception occurs inside of this try block, if an exception occurs anywhere in here, the finally block will always execute. So let's go ahead and execute that now. Let's run that. And what you're going to see is that finally, which is right here, finally is printed, but the exception is still happening, which is inside of check age, and then basically the program execution is stopping. How do we know that the program execution is stopping? It's pretty simple. The print line, which is called after try, is not executing at all. So what ends up happening is this block is executing, and now we're seeing the finally run here, and finally will be run regardless what happens inside of try. Now this is very useful. Let's say if you've opened a variable and it's perhaps reading a file stream, or maybe an audio source, or audio or something like that, that's going to take a lot of resources that you need to close to make sure there's no memory leak. Then maybe you would say, you would have some type of variable called file stream, and then inside of here you might say, regardless what happens, if I get an exception or I don't, I want to close down that stream so I can kind of clean up after myself and not have memory leaks. So it's a very common place to clean up for anything that you need that's resource intensive, or could possibly provide any type of memory leaks. You can put it inside of the finally area there, so if anything were to happen. Now you can also combine a try finally with a try catch, and so I could say catch exception with exception, and of course we can do this, so we can stack them, and this works. This is a very common pattern here. So again, you might want to use finally to clean up after something that you've maybe opened an audio source, video source, something that could leak memory. But you might want to do something inside of this exception and say, print ln, handled, or maybe you're going to handle it a certain way. So instead of, it's going to catch the illegal argument exception. So let's go ahead and do illegal. Let's do illegal state exception, and if we run this, what we're going to see is we're still going to get the finally that's called, but we had the illegal argument exception was thrown. So what ends up happening is check age called, the exception was thrown. Immediately this finally block realizes an exception was thrown, so finally is printed, and then finally the program says, hey, here's why we executed with this exception. Now, if we were to change this catch block to catch that illegal argument exception, the whole program execution changes. So we're going to see that it's going to execute this, but it's going to throw an exception. So we're not going to see this line of code. Remember, an illegal argument exception was called or thrown. The catch block sees that, says, yes, I can handle that. It then prints out handled, which is printed out handled here, and then as always the finally block will always be run. So we may need to clean up after some memory intensive stuff. We'll then go ahead and execute the code inside of finally, and then after that the program execution continues because the program didn't really crash. We handled it right here, and at that point it's executing after the try. So you can perform a try and a catch and a finally. You can stack them all on top of each other in Kotlin, and that's how you do it. The difference between try catch and try finally can be illustrated in a very simple example. Here we have a try block inside the check age method. We check the variable for the class person, and if they're under the age of 18, we throw in a legal argument exception with the value of boom. And if we run this, what we're going to see is a few things happen. We see the word finally is printed to the output, and then we see the reason why the application exited, which is the illegal argument exception which was thrown. So this is interesting because the print line was not executed, which we expect because it was short-circuited based upon the illegal argument exception that was thrown. Every time this code is called, finally is guaranteed to be called, so finally is going to be called, and we print finally to the screen. And of course, because the application exited, we are not going to see after the try here. Now, how does this differ from a catch? Well, a catch allows you to catch the exception and do something with it. Finally just executes at all point in time. So let's just go ahead and replace this. We'll comment this out right now. And let's go ahead and actually, I'm gonna go down here, we'll comment this out. And now we'll say catch, ex exception. So catch allows us to catch the exception. And we can print line the exception message. Actually, let's go ahead and we're gonna print caught just to be more clear. And once we execute this, we'll see the word caught, and we are then after the try. And so what this allows us to do is this whole program is now executed, though, except for this line of code here, because it was short-circuited via the check age because of the illegal argument exception that was thrown. So with a catch, you can actually catch either a particular exception, or you can say if it's not a particular exception, you can, or if it is a particular exception, it can also not get short-circuited and still blow up the application. However, anytime you're using a finally, which it also can be combined, a finally is executed all the time. So regardless if we have an exception that is caught, we have finally, this exception was not caught, so it terminated the program. Finally was printed. However, if this is an illegal argument exception, we're going to see that the program execution continues on. We didn't crash the application, however, finally was still called. So regardless of what happens inside of the try, finally is always called. While it's not guaranteed to always be called with the catch, because we could be filtering it based upon the type of the exception. Defining a type alias can be very useful in various different scenarios. It allows you to alias one particular type to another named type. So let's assume we have a user class here, and it has a username and perhaps an auth token. And perhaps the account class also has an auth token that is needed to request an account, to request the account details. And for whatever reason, there is a order class, and it also requires an auth token as well, and it's a string. Now eventually you start finding yourself having the word auth token all over your entire application and realize that could be a problem. Well, one thing you can do is actually type alias auth token into its own type, or maybe you can create your own type. So you could do that too. You could say something like this: data class auth token. And what it is it just contains a token that's a string. And then you could start replacing this with auth token. But then inside of your any of your providers or anything else that's inside of your system that's you want to treat it like a string, well, now you have to treat it like an object, and it's kind of a pain. But you would just love to be able to call it auth token, because it would just make much more sense when you're reasoning about your application. So I'm going to go ahead and put this back as string. So we're going to go ahead and get rid of that. What you can do is actually perform a type alias, and here's how you can do that. What you can do is, usually I prefer to type these at the top of a file or in some type of common extensions area inside of my application. So I might have a file called extensions.kt, and I'll say type alias, and then what I'm going to say is I want to type alias the word auth token to equal a string. And what that means now is I can use the word auth token anywhere. So this is also a string. This is also an auth token. But now it's much easier for me to reason about, because now if I'm going to use my user class user.auth token, I can see that it's an auth token type, and then it actually gives me a hint here saying, hey, that is actually a string behind the scenes. And so I can say auth token, and then again, I still have all the same operations that I would have on a string, like length and so forth. But now it allows me to have much more meaning directly inside of my application. So if I'm creating a new order, a new order is going to take an auth token. So instead of it taking a string, it's an auth token. And so I could do one thing. I could actually provide the auth token. I say user.auth token. That'll work. Or if I just have a string, because auth tokens are strings, I say my auth token. And this will also work too, because underneath the hood, Kotlin knows that an auth token is a string. However, just for usability and type systems inside of your application, it makes it a lot easier sometimes with various different values to use type aliasing, so you can actually get the actual types that you like without actually having to create a brand new one, because maybe that auth token is just a string, but you would just like to have it have its own type, and you can do that with type aliases, and it's very easy to do. Just set type alias, what you want to call the type alias equals whatever the type is. One of the coolest things about Kotlin is the ability to add functions to existing classes already inside of the standard library or other existing libraries. Now, for example, what I mean by that is it would be great if a string class, which is what this name is, if we were to specify it, it's string, but it's already through implicit nature, we already know it's a string. It'd be great if the string class had an initials method on it. And that would allow me to automatically just say name.initials, and for that name, it would automatically print the initials, so it would print df. Well, we can do that in Kotlin, and here's how we can do it. All right, so I've saved the time of actually typing the code for you, and I'll walk you through it here. Now what I've done is created a new function on this line here. And this function itself, we start off by saying the type that we want to extend. Here is string. And then we want to say here is the actual name of the method that we want to create. And then of course it's going to go ahead and it's going to return a string, which as we see here, return a string. And then at that point in time, we're going to go ahead and go through all of this here. So here we have the values. We're just going to split it on an empty string. And then we're going to grab the first initial using the substring. We'll grab the first character off the first part of the array, off the first item in the array. And then we're going to grab the first character off the second item in the array. And then at that point, we're just going to use some string interpolation and return them together. So now if I run this, what we're going to see is we're going to see df is printed. So now any string that I have, so if I say val equals, I could even have the something like a book that I'm reading, which is called, I read this book called The Daily Stoic. We say a Daily Stoic, I could say println book.initials, and what we would get back is ds. So of course ds is printed before they had the name in it printed, so if we move this up here it would make a little more sense. So now we see df and then ds is printed. So anything that has a string in it is going to be easily created. Now the string is not a class that we can control. This is not, if we look at string, this is part of the Kotlin standard library. It's part of Java. We can't do anything about that, but we're actually able to kind of slap on some additional methods for it using extension methods. So now what I usually prefer to do in this case is I like to have a file, and I'll call this extensions. And that's where I like to put my files, my extensions. And if I have a lot of them, I'll call string extensions, I'll have integer extensions, but in this case, I'll start off very simply with one file called extensions. It doesn't need to be inside of a package. It can be a top-level function as we're seeing here. Now at this point, I can call this from anywhere that I would like. So back in my main file, initials still works. So anywhere in my application now, I'm going to be able to use this dot initials. Now the same thing can happen over here in extensions. Let's say I wanted to extend the integer class is adult, and this could return a Boolean value. And all this is going to do, and we could actually single line this, and we'll say this. Now notice how we said this, because this is in regards to what type we are extending. So the extension function for string, we said this dot split. Here what this is for the integer, so this greater than or equal to 18, so is adult. So I can single line this one. This one's easy. Again, this could also be, if I wanted to do it the other way, which you may be more familiar with seeing to make more sense, we can do it this way here. It says convert to expression body, so there we go, is adult. And I can even probably get rid of that. And so I can now really make this succinct. At this point, we are looking at I don't know, 30 characters total from start to finish as adult. What this allows us to do is say val age equals 35, and I say print line age.is adult. And you see how the code completion found it automatically, and we see that true came back. So now I was able to extend the integer class, I've extended the string class, and furthermore, I could also do this with, let's say, another model. So I'm going to create another file here. Call this one models. Inside the models file, I'm going to have a data class. Oh, we'll go data class. Actually, let's do a regular class. Regular class person. It's going to have a val name, string, and a val age, and that's going to be int. And then what I can do is I might have my person, and I'll say today I'm going to be 89 years old. So Don, person, age 89. Now the cool thing about this is if I had my full name in here, I could do something like this. Say person dot, well, from here I could say initials. Person dot name dot initials. Now the problem that we're going to get here is that the name Don, if we run this here, we're going to get an exception, because the initials is splitting on a string, on a space. So you see here, this is what's happening here. Splitting on a space. And so there's actually only one item in the array. Therefore, it's going to be blowing up. So that's not going to work right now. But if for some reason I had my name listed as Don Felker, like that, I could then issue that, and I would then get back my correct initials. I would see DF again printed. So let's now go ahead and change this person class though, and let's kind of show how we can extend. Let's pretend that this class had a first name and then had a last name. This is a very common example that you're going to run into. This person could be a user, it could be anything else, and it's usually going to be a class that you do not control. So we'll say Felker would be my last name. And we'll see, again, and I've got a little bit older since the last time we spoke. I'm 90 now. And so a lot of times if I would want to print someone's name, I'm going to say, of course, we're going to do string interpolation because it makes more sense. I'll say person dot first name, and then I'll do a space, and then I'll do person dot last name. And that works great. The problem is I find myself repeating myself over and over and over in my application, and I'm doing this all over the place, but I can't come in and modify the person class because it's in a library somewhere. So what I could do is I could be in my extension class. I can come in here and I say fun person. So remember I have person, and I can say full name. Full name. And I'm going to go ahead and just inline this one as well. And all this is going to be is this dot first name. And I'm actually going to string interpolate this. So we'll do this dot first name space, this dot last name. Close that out. And now instead of doing this, I have extended a person. So I can say person dot full name. I don't even need the quotes there actually. I can just get rid of all that. Now person dot full name. And if we run this, we'll see the same thing. Don Felker comes here. So if we say, John Smith, first and last name, John Smith. So we've actually, again, we're assuming that this person class is in some other library somewhere. We don't have control over it, but we do want to use it, and we want to make it easier to use. We can create an extension function called full name. We can create any type of other function that we want to throw onto those types, such as we're building on top of the built-in primitive types that are inside of the type system, such as string and int, or even custom types that maybe we have control over or we don't have control over, and we would like to provide extension functions to them. A lot of times you might find an extension function very useful in a particular domain of your application, maybe in a couple of modules, and you might put that extension function over there. But that's how you can create extension functions in Kotlin. Let's say that you have a string in Kotlin and you want to print it out. But what happens if this string was from an expensive operation? What would you do then? You perhaps might want to use a lazy keyword inside of Kotlin. And so this allows lazy evaluation inside of Kotlin. So what this will do is this doesn't look any different than what we had before. Now if I run this, what we're going to see here is that we have Don is printed. Now however, something interesting happens here. Print line inside of here, and I'm going to say computed. And then what I'm going to do is I'm going to print this twice. And so what we're going to see is two different things. We should see Don printed twice, but we should also see computed. But we're only going to see computed is printed once. Yet the second Don is here as well. So I printed both the names as done here, but we only see computed showing up once. And the reason why is because the first time the call to this name has been called, Kotlin will then go ahead and evaluate and execute the code that's inside of here. And this could be a very long running operation. And then at that point, Kotlin will remember the computed value and will return it each subsequent time that it's called. So it will not actually execute it again. So if I run this, we'll see computed and then Don will be printed 3 times. So a good way to emulate this is actually if we just did a sleep function. And we'll do sleep, and I'm going to sleep for 3 seconds. And sleep is just part of the Java library, so not 3,000. There we go. This is simulating a long running operation. Maybe we had to go off into a background session, or we had to do some type of really complicated number crunching and to return this value. And this value here is dawn. So the first time it's going to happen, we're going to see print computed, and then it's going to wait 3,000 milliseconds, so 3 seconds, and then we're going to see dawn printed most likely 3 times really fast. So let's run this here. Down here in the output window, you're going to see computed, it's waiting, and then boom, all 3 of them were computed. So what ended up happening was the first time this executed, all this was being executed on this first line. So the first time this code was executed, it was executed right here. Now each subsequent call, which ended up happening here and here, it got the remembered value. So as soon as it came out, this came out and said, all right, well, the new calculated value is X. And then what ends up happening is each time the subsequent calls are made, that calculated value is remembered and it's not executed anymore. So on the first execution, when you're using by lazy, it'll execute this code and then drop it into here. So that's how you can use by lazy to remember computed values, so things are a little bit faster, and so you can have a little bit more performance, and if you want the value remembered inside of your application in the future. In Kotlin, you can have lazy property evaluation, and you can also just have a lazy block in which you can state some type of expensive operation needs to be lazily evaluated. And all you have to really do is provide some type of block in here. And you can either write your code inside of here, and you can put your code here, or maybe you need to call an actual method, as I'm doing here, to perform some expensive operation. And so what I have here is I have a method that returns an integer, and when it's the first time it's executed, or every time it's executed, this method is going to call and print out this word computed. And then it's going to sleep for 1 second, and then it's going to return a randomized integer, or somewhat random because that's just the nature of the random class, but it's going to randomize based upon the current time, milliseconds, and etc. So it's going to give us a different random number each time. So what we want to see here is what happens when we print this out. So all we're going to do is have a lazy result, which is an integer. We're going to print it, and then we actually want to see there's actually a property on this, and it's called is initialized. And so we're going to run this, and what we'll see here is that the first one, when we print the result, it says lazy value not initialized yet. And I said, is this initialized? And it's false. And so we have a couple of other options on here, result.initialized, or get value, or just value itself. So let's print this line here. So print line result.value. And then what we're going to see here is of course, we're going to see not initialized. It's going to be false. And it's going to say computed. And then it returned us a number here based upon the randomization. Now, to verify that the lazy evaluation is working, and lazily evaluating meaning it's going to remember its future values, let's execute this a few times to see what happens. If for some reason lazy is not doing its job, then we should see computed printed 3 times, and we should see every time 1,000 milliseconds sleep. So about a second in between each one of these values. So if we run this, what we'll see is, again, we'll see the top 2 values printed, computed, boom, and then all 3 of these came out almost at the exact same time, very quickly. And what that means is the first time that this value was computed inside of this lazy evaluation, Kotlin then remembered it. So for each subsequent time, we received the same value. And then of course, because we weren't sleeping, the milliseconds would have been different here, which means we would have got most likely a different number in one of these values. So we can tell here with a high level of certainty that Kotlin is returning basically a cached value that has been cached for this lazy operation. So if we know that we want that same value over and over, and we don't want to call a particular method or function or class because it's very expensive more than once, we can wrap it in a lazy block, and it will be only executed the first time. And then at that point, all future invocations of that operation will then return the cached value, which is cached via the Kotlin lazy operator, which we can see here creates a new lazy instance of the specified initialization function. So that's how you can use the lazy block in Kotlin to help speed up your application and be a little more performant. When creating files inside of your project, you'll want to think about organization and where to put these files. Files are usually organized into various different packages inside of your project. In the Project Explorer on the left-hand side, in the SRC directory, you can create a new package by going to New, Package, and then you can enter a package. So one common one that you see a lot used inside of example projects is com.example. And as we create com.example, we see we have kind of what looks like a new folder with a dot in it. And that signifies it as a package. And let's say we wanted to create another package inside of the example. We could say, we want to create another one. We could say com.example. And we see here that the directory already exists. And why does it say directory? We'll get to that in a second. Let's say we want to create a models package. We'll create a models package. And so we say com.example.models. And so it's kind of been prepended here. Now, as we see, these are dots, and it kind of looks like a backwards domain name, and that's kind of what it is. Now, the interesting part about how these files are stored in the disk is if we look at them inside of our file explorer, and I'm on a Mac, so I'm using Finder, you'll see we have models, then example, com, and if we go backwards, we basically come up here to our Caster Kotlin, our src folder, which kind of maps to this folder over here. We see our IO, our com, and see how we have an io.caster package over here. So com, example, models, each one of the items that are separated between the separators, which are dots, periods, is actually a new folder. So let's say that for whatever reason, I wanted to create a file inside of the models project. What I would do is say file, new. And inside of here, I might want to create let's call it a customer class. And it's customer. And notice how it automatically adds the value package at the top. And this is the package declaration that lets you know what package this file is in. So here, this is inside of the package com.example.models. And I could have my class, and maybe it would have, a regular name and a string for a customer. And those are all kind of common things we might have here. And then we might have another customer. We might have another value inside of there. And now let's go over here to our other file here. Let's say we have something else, and let's say we have in Caster, we have something known as a video file. And that's a video class. We'll say class video, and it has a URL that's a string that's associated with that URL. And then inside of there, we have some other things. But maybe it also has some customers that have watched it. So we might have a function, say something like fun, and it would be, customers who viewed this. And perhaps this goes to a database, right? And this database is going to return a list of customers. Now what we're going to see is we have a list of customers, and we see right here, IntelliJ has found, based upon us typing and code completion, that a customer class has been found. Now, if I hit tab, which I'm going to do, automatically what happens is something is imported. This import is basically saying, look, we want to use a customer from a different package. And we're going to use this from the com.example.models package. Now, of course, I could just hit return just to get the compiler to be happy. I could return an empty list. So we're returning a customer. So what we are using is inside of this video class on the side, we're using something from a different package over here. Now we could also have additional packages. For example, I want to show you another trick and go over here. And let's say, for example, in models, we happen to come to the file system and type in here, and we'll say util. Now, if we go back over here, look what happens. All of a sudden, IntelliJ recognizes we have another folder in there. Hey, there's actually some other stuff in here. And a lot of times people will actually create things in here that are perhaps, we call it model extension or something like that. They'll create some extensions files in here for, anything that's going to be like an extension function or anything like that. And then create extensions. And this is where they'll have all of their extensions, etc., or so forth. And it looks like it was misnamed there, so we'll say extensions.kt. Not a big deal. So we have multiple different packages inside of here. And so you can have multiple packages inside of your projects. Here we have a couple of them. You may import a different package from another library altogether. So if we're inside of our models here, and we wanted to import something else from a different project, as long as we have imported inside of whatever build tool we're using, we can go ahead and reference that just as we had referenced it inside of our video file over here. Now, if for whatever reason you just create a file and we don't put it inside of a package. So let's call this and say, we're want to call it a favorite, we'll call it a favorite class. Maybe you're going to favorite something, say class favorite. And maybe it has an ID that for whatever reason. This class is in this right here. It's in the src directory. It does not have at all. It does not have a package. So the default package has no name. So at this point, it's part of the default package of the application. And the default package of the application is nothing. There's no name for it. So here you're just kind of sitting at the top level of your application. This is not recommended to put files at the top level here. It's always good to have a place to put them inside of your application. So where should you put them? Maybe you don't have a good idea. A lot of times if you're just working with a sample app and you want some place to put them, I recommend just using com.example or org.example. And that puts them in kind of like an example namespace, just so it gives you a little bit a level of organization. Or maybe if you have your own website like I do, what I will do is I'll put them in my own package. And so you can see I have a caster one there, but I also have a Don Felker one. So I'll say Don Felker, which is my website. And I might say something like models. If it's something that has to do with models, if it has to do with, IO, it might have to do with, input, output. If it has to do with, I'm building some calculation stuff or math or anything like that, I might have it inside of there. Or if I'm going to build some services, I have, com.donfelker.services. And now I have some packages in here. And if you notice, com now has realized, hey, well, we have a couple of packages inside of here that also are from the same root TLD, which is the com. So let me create a file here. And inside of here, we'll have something like, a customer service. Maybe it does something special for customers, or let's just say it's a tweet service for whatever reason I'm connecting to Twitter. So there we go, a tweet service. And so this is just to illustrate that you can have multiple different packages inside of here. And the tweet service is inside of, com.donfelker.services. The example over here, we have the models. We have models in here. And packages give you a way to organize your code into logical groupings. So a lot of times you'll see a lot of code that's related. Maybe it's with file IO together. Database code will be together. You'll see, services together. And various different projects will have it different ways. So it depends on the project you're working on. Some will be kind of grouped together by function. Some will be grouped together by feature. Kind of depends on what it is. But packages allow you to group your various different pieces of your application and your classes into different locations. And again, if it's not part of a particular package and it's at the root level, perhaps just right here in the source directory, it's part of the default package, which has no name at all. And usually this isn't recommended when you're developing a real production application. And that's how you work with packages inside of Kotlin. Kotlin has type inference. Let's talk about exactly what that means. Now, at a real high level, what that really means is that Kotlin can infer a particular type of variable. Now, Kotlin is a strongly typed language that means that each variable has a particular type. The compiler is going to check those types, and we have a lot of compiler things that the compiler does that makes our life a lot easier. And one of those things is type checking. However, in traditional languages such as Java, you have to inform the compiler, here's the type that I'm going to use, and then you can start using the variable. Kotlin has type inference. So here we have a variable or value by the name of name. And it contains the value of Dawn, and we have another value here which contains the value of age, and this could also be a var. It doesn't matter if it's a val or a var. Kotlin will infer both. And then what we can see here, just through the help inside of IntelliJ, is that Kotlin has already inferred that the name variable here is a string. And the reason how it's doing that is it's looking on the right-hand side of the equal sign and saying, well, you want me to declare a variable, and you want me to call it name, okay, and then you want to assign the value Dawn, and I already know the value Dawn is a string, and so I'm going to put a string inside of the name. So that means that most likely that name is a string. So I'm going to infer the name is a string. Okay. And the same thing goes for over here. You want the value 33, and 33 is an integer, and you want to shove it into the into the age variable. Well, I'm going to assume that age variable is actually going to be an integer. And as we can see here from the help, that the compiler is actually getting this right. And this does us a few things. It allows us to not have to declare the variable. Now we could, of course, just say, hey, this is going to be a string. but we're actually kind of just writing a bunch of code that we don't really need to write. So we don't have to do this. Now, that's the really nice thing about us inside of Kotlin, that with variables, we can infer them automatically. Now, there is a caveat here. If you remember, late initialization, so we have a var, and we could say maybe your favorite food. You could say something like this. Well, I'm going to do this later. And again, late in it means, hey Kotlin, don't worry about this yet. I'm going to go ahead and populate the food variable. I'm just not going to do it yet. I'm going to do it somewhere later down the line, but don't worry, I got this covered. I'll handle it. So that's what we're telling Kotlin at this point in time. However, Kotlin says, well, I can infer the type of the variable if you give it to me during the initialization, which is what we're doing here. We're allowing the initialization of the variable to occur, and therefore type inference can take place. So names, like, okay, that's going to be a string because you're basically setting it equal to a string. And age is going to be equivalent to an integer because, well, you're setting it equal to 33. But late init food, I don't know what that's going to be yet, because somewhere further down the line here in our application, who knows if it's inside of an if statement, inside of a catch block, who knows where it's at. But you're going to set it somewhere, and I don't know what it is yet, so you're going to have to tell me. So in this instance, I actually have to define the type for the compiler to be happy. So I cannot infer a type with a late initialized variable. Now this also works too if you have, for example, let's say we want to use a name that's reversed, and we have a method, which we have down here at the bottom, and this method right here, we're just taking a string and it will reverse it. Now, of course, we could do that by hand, but this is just to illustrate the concept that you can have a function that also returns something. And so taking that, we'll take in the name. And what will happen is Kotlin will then go ahead and take a look at this function here. And it'll say, all right, well, you want to use name reversed. Okay, well, I'm going to go look at this function, name reversed. And then I'm going to see, oh, name reversed actually returns a string. Oh, okay. So in that case, I'm just going to go ahead and make reversed a string. So again, kind of as real quick, just kind of Kotlin says, I'm going to go look at this function here. I see it's a string, and then, okay, cool. Looks like I'm going to go ahead and make this reversed value a string. So pretty simple. And what it's doing behind the scenes, so you can do that. Kotlin will also do some inferring too. So let's say we have two prices. So price equals 10. Now this is going to be an integer, and I have price 2. And whoops, so this might be price 2, and these could be vowels as well. So 20.01. And then I say, all right, print line price 1. I say print line price 2. If we look at what the compiler is telling us here, is that, well, price is an integer and price 2 is a double. And then what happens if we initialize another one? And we say this is total, and the total is going to be the price plus price 2. Now what's going to happen here? We're combining two different types. Well, this is a double and this is an integer. Well, Kotlin's like, well, what am I going to do here? Well, Kotlin is smart enough to know, the compiler is, well, you're adding an integer and a double, so most likely you want the precision of this to be a double, because otherwise you would lose some precision if we just stuck with an integer, meaning that we would end up with, what would this be? It would be 30, most likely. So at this point in time, total is going to end up being a double, which we can see here from the IDE help. So Kotlin is then doing type inference based upon a calculation of an integer and a double. Now, in other languages, you might have to do particular types of casting to make sure that you don't lose any precision, because if you didn't do the casting, you might have precision problems, meaning you're losing decimals, etc. But Kotlin is smart enough to figure some of these things out here. So this is basically, in essence, what type inference is. And so you can get inference when you are initializing variables, and then different types that are returned, etc., are going to be inferred, such as the function name is here. And Kotlin will basically look throughout the execution path of the code, say, all right, what is being returned here? Okay, it's being set into this other value up here. Okay, that sounds good. So it looks like, reversed is that point is now going to be a string, and we can go ahead and infer that for you. For some reason though, if we are using, again, a late init, and we're going to go ahead and use a var and have our favorite food, we will have to actually declare the type when we declare it, because Kotlin's not smart enough to know, hey, I don't know what this is going to be, and because it's a strongly typed language, we can't just kind of let this type just kind of be floating around in nowhere, and we don't know what it is. So you do have to declare the type here if it's going to be late initialized. And that's how type inference works in Kotlin. Okay, let's talk about Lambda functions. Now, a Lambda in Kotlin is defined as the following, and these can look very confusing the first few times you see them. So if we're going to build our own Lambda function so you can understand what they are, and basically Lambda functions are functions that are, I'm not going to get really mathematical about you and higher order functions and everything like that, though I really advise you go read the documentation. Lambda functions are basically little functions that you can create and start passing around inside of your application. It allows you to be very functional in nature. So enough of that, let's get into a implementation. So a Lambda is defined as having a name of a Lambda, and then you have its input types, which are going to be the parameters that are passed in, and then it's going to have a return value, and then inside of that you're going to actually have some code, some arguments that you get to provide the names for, and you have to provide their types. Again, that's going to be the input type over here. So we can go ahead and change this to input type so it makes more sense. Input type, and then you're going to have the body of your actual Lambda function, which does its work. Now, a lot of type inference will happen with this, which we can get into in a second. But let's go ahead and create our first one. And the first one we're going to call is the end result is what we want to be able to do is say greeter. We want to be able to do this, and I want to be able to pass in my name. And what I want to happen is I want hello Don to come out somehow. So how are we going to do that? So this is a very rudimentary example in which you could normally write a regular function for, but this illustrates the Lambda functions. And so what we would say is we say val and say greeter, and we do colon, and then we need to provide the input type. So remember, let's look at our example again. We have greeter, and inside the greeter function, we want to be able to pass in the word Dawn. And so here what we need to do is say, hey, we need to pass in an input type. That input type is going to be a string. Okay, and then what do we expect the return type of greeter to be? Remember, what we wanted it to be Don Felker is what we want it to come out of it. So we expect the return type to be a string. Okay, now we need to start defining what our Lambda expression looks like, a Lambda function. And so in here, we actually are going to have the parameter. So our first parameter right here, which is passed in, is Don. That's a string. Let's go ahead and give it a name so we can work with it. So let's just call it name. And of course, we know it's going to be a string. So again, we have to provide it right here. That's one of the arguments, and provide its input type. And now we actually provide the code body. And so now this is the actual body of code in which we can do some stuff. So here, what we can say is hello, and then we can use string interpolation. We'll say name. And what ends up happening is the last value that's inside of this Lambda expression, of this block of code, is the return type. So whatever this type is going to be the return type. So if this was multiple lines, which it could be, watch, we can put these on different lines and we can have multiple lines. Whatever is the last one here, I could say val foo equals 0. It doesn't really do anything. And then we get this nice little Lambda notation here. It says, hey, this is the return value of our Lambda. So whatever this type is going to be the return value. So it's a string. So if I said, hey, I want the length of this string, we're going to get a compiler error because it's going to say we are requiring a string. Again, this is the return type of the Lambda, but you're actually giving us an integer because this is the last line on here. We're not saying return anywhere, but by default, the last value is the value returned. So since we can single line this, we'll do that now. It's pretty easy. We'll get everything back on one line. And then what we can do is we can go ahead and execute greeter. And we'll go ahead and pass the name Dawn in. And so it looks like a regular function. And we can see here, when we did that, we created the new greeter here. We could see that it's going to take in a string. Now let's go ahead and run it. And then what we're going to see is that nothing happens down here in the output window. We're expecting something to show up here, but nothing did. And the reason why is because greeter is a function that takes a string and returns a string. It doesn't do anything with it. So we actually have to do something with it. So let's go ahead and print that return value, which we could just do this too, just so you're aware. We could actually say greeting equals greeter like that. And then we could say print line greeting. And then when we run this, what we're going to see is the output finally of that function. It's going to say hello Don. So again, to kind of cover this here, we have the name of the Lambda, which is coming right here, the name of the Lambda. I'll do a little simple line here. So it's the name of the Lambda. Then we have the input type. Then we have the return type. Then we're having the arguments and their corresponding input and the corresponding type, which is string. And then this little section over here is the code body, which comes right here. That's the code body. So that's how all that's mapping right here. So now let's take this a little bit further though. Let's say for some reason we wanted to be able to say, like we said, we have Don Felker here, but instead it's saying hello Don. So we got that wrong. So there's a bug in our code. How are we going to fix this? Okay, this actually should say hello Don Felker. Okay, well that's easy enough. We could just say hello, we just put Don Felker in there and that would work. But what if we wanted to be able to accept two different names, because in our database everything is separated out, so we need to have this greeter needs to be able to take two values. So again, we need to come into our expression and say, all right, it's going to take an input type of string and another input type of string. So it's going to have two. Think of this like when you write a regular function like this, right? Function, my function, and then inside of this function you have some stuff, and it's going to be name, string, foo, whatever it is, last name, string. Well, notice how the way I like to think about it is these parentheses right here, they kind of just, it almost like maps directly to that parenthesis, kind of maps there, that parenthesis maps there, and it basically says, hey, look, there's a string here and there's a string here. And that's how I kind of visualize what these parentheses up here are. So this is going to take in some type of string as one parameter. The next type of, in that next parameter is going to be string. And the whole thing's still just, in the whole Lambda expression is still just going to return a string. Now we get a problem over here. It says, hey, we're expecting two parameters of type string and string. Remember, we're taking in two now, but over here, this is the list of arguments. Remember, this is where the list of arguments map in. And if there's more than one, then we need to put a comma here, just like we would traditionally in a regular function. So I'm going to rename this as first name, because I can name this anything I want. And then I'm going to say last name, string. And now I'm starting to run out of a little bit room here, so I could shrink this down a little bit. But what I have over here, I need to change this to first name, and then last name. And I'll do string interpolation again. And now we have a Lambda expression that's going to take in two values. So you see right here, it says, hey, we're waiting for the second value, P2, which can be the second parameter. So I'll take in Don Felker. There we go. And I'm going to go ahead and run this again. And what we're going to see on the greeting now is that Don Felker is returned because we're passing in a string here, Don, another string for Felker. These, basically, if you take a look at how this maps, this one is mapping to this one, and this one is mapping to this one. That's how they're mapping right there. And we can see that the first string, we're calling that one first name. The second string, we're calling that last name. And then at that point, since we're inside of this Lambda expression, we have access to those variables and we do whatever we want with them. Now, if for whatever reason we wanted to do some hokey pokiness, some hokey stuff in here, we could actually do some different things. So let's go val, modified first, f name, actually first name spelled out. And what we could just say is first name dot to uppercase for whatever reason. And then we can say val modified last name. We can say last name, not owner exception. Last name dot to lowercase for whatever reason. And then we can go ahead and replace this with the two modified ones. Modified first name, modified last name. And now if we run this now, what we're going to see is that we have a Lambda expression with multiple lines. Hello, Don Felker. So we've capitalized and done different things here. Okay, that's cool. So we see that, again, the last line here is the one that's returning the type here. And that's the type that's going to be, basically this Lambda is saying, all right, look, we have a return type of string and that's mapping to right here. So string, which is right here, is mapping to this. And the last line of the Lambda expression, whatever its type is, needs to match this up here. So let's go ahead and get rid of that. So let's just say for whatever reason, we wanted to say, greeter needs to return an integer value. And this could be the number of characters inside of this greeting. I don't know, for whatever reason. We've changed this to integer, which means now that this Lambda expression needs to return an integer. But down here, the last line is what's going to be returned, and last line is returning a string. So this is not going to work. So what we can do is we can just go over here and maybe just return the length of this name. If we run this, now what's going to be returned, it's still going to take in a first and a last name, and it's going to add it's going to concatenate hello on there. But then we're going to grab the length and we're going to print the length. That's what greeter is going to do at this point in time. Okay, that sounds cool, but maybe that's not what we really want. So let's take this back to string. Now, let's assume that we really like what it does, but we just want greeter to actually just to display the greeting. So we don't want to have to do this. We don't want to have to print this. We just want, as soon as we call a greeter, to automatically just print line, hello, Don Felker. So how can we do that? Well, this return value is what is going to be returned from the Lambda expression. So we can change that to unit. Unit is basically like void in Java, which means, hey, we're not going to return anything. We're just going to do something, but we're not going to return any value. So here we're just going to go ahead and return unit, which is nothing. And then what we can do here is we can say print line inside of here, and we can just do that. And then what's going to happen now when we run this, what we're going to see is we're going to call the first name and the last name. It's going to be passed in, and then we're just going to print line. There it goes. Hello, Don Felker. So we can do all different kinds of stuff. And this could be multiple lines, could be hundreds of lines. That we, of course, I don't recommend that for, you want to make your code easy to read and so forth. Because Kotlin has type inference, you can actually clean this up quite a bit. We don't need a lot of this stuff in here. So what we can tell Kotlin is, because Kotlin can look inside of this Lambda expression and say, well, we know we have one parameter, we know we have another parameter. Okay, so this first parameter is a string. We know the second parameter is a string. Okay, we can do that. Kotlin's figuring that out for us. And then it's looking at this last line down here, and then Kotlin's saying, well, this Lambda expression is not returning anything, so it's actually going to be, it's going to be unit. So it can infer the return type, and it can infer the parameter list. So what we can actually do due to type inferences, just go ahead and get rid of that. So now we have a very succinct, or much more succinct Lambda expression. So if we want to do the simple one, so we want to do just a simple one, greet, we could have done something like this. Could have said name, string, and then we could say this, print line, hello, name. And there we have our very simple little greet. So of course we have our greeter that does a bunch of different stuff, modifies some variables, which we'll move up here just so it's obvious. And then we have the very simple version right here, greet. And if we print these, of course we got the spelling wrong. And if we print these, what we're going to see here is we have both of these printing out values. Now, your Lambda expressions are not limited to one or two or three different types. You can pass in many different types into your Lambda expressions. If for some reason when you're writing your Lambda expressions and for some reason Kotlin cannot perform type inference, you will have to provide these hints. And sometimes you'll run into weird situations where based upon something that you're doing, you're going to have to tell Kotlin, hey, by the way, here's how we're going to go ahead and do all this stuff. It's going to be, it's going to be a unit or whatever, and so forth. So you'll have to provide all the information. And this is kind of this is the blueprint up here. This is the blueprint that you just need to remember, that you're going to have Lambda name, then you provide the input type, the return type, equals whatever this Lambda is, and it's going to have your arguments, if it's going to have one to many of them. You have the body of it, etc. And that's understanding Lambda expressions. Using Lambda expressions in your code can be very beneficial, especially if you decide to take Lambda expressions as a function parameter. So let's assume that you have a function and you want to make something repeat. Actually, let's call it line logger. And you want something to kind of log various different lines over and over and over. And so what you could do is you could take, a message that is a string, and then perhaps if you wanted some logs to very basically kind of look like this, you want a bunch of these kind of lines separating your logs. Just for maybe because you have really chatty logs, you could do something like this. You could say repeat 5 times, and then you pass in a little Lambda expression, so print line, and then let's go ahead and put in 1, 2, 3, 4, 5, 6, 7, 8 of these lines, and let's do that twice. And then what we'll do is do print line our message. Now this works pretty well. So anytime we want to use this, we can say line logger and say hello there. And then if we run this down in our output window, what we're going to see down here is we're going to see that hello there is printed out. Maybe this is useful to kind of help break up your logs for a visual aspect or whatever. But sometimes that can be not what we want to do, and there's a way we can actually make this much more in tune with being able to do anything we really want inside of here. What if we want to provide not one message, but we want to provide two messages? So let's go message two string. Now we're going to come in here, we're going to say print line message 2. We run this again, we get our message 1, message 2. And it looks like we're messaging message 2 up here. Of course, we forgot to add that to the parameter list. Hello again. And when we run this time, we're going to see hello again. Now the problem is, as we continue to grow this and our requirements improve and increase, what we're going to run into is a situation where we're just becoming overloaded here. And what we really want to do is be able to have a way for us to print this kind of this block at the top and the block in the bottom, and then whatever we want right here in the middle. And so, yeah, we could build our own string. So just leave it at one string. We could build our own string up here, and I could do this. I can maybe do this like a little weird, I could do this thing up here where I do like a new line thing, and I kind of got there. But then it starts getting really hacky as soon as I want to get anything else kind of done in there. But there's a way we can solve this with Lambda expressions. And so what we can do is I'm going to call this block. And this is the name of the variable. It's called block. And then what type of it's going to be a Lambda expression. It's not going to have any parameters, and it's just going to go return a unit. So again, remember, let's go ahead and take a brief review here. We have the input type, which is right here. That's going to be, there's nothing input type, so it's no parameters. And then the Lambda has a return type. And what is that return type? That return type is going to be unit, so it's not going to do anything. And again, the name of it is just called block. And the reason why we're calling it block here is because it's going to be a block of code. And so this is a block, and so I can get rid of this. Now what I can do is just invoke this block, since this is basically just a function. I'm saying, hey, this is a function I want to do. And so what I can do now is I can get rid of this code here, and I can actually just do this. Now, of course, you're wondering, where did the parentheses go? So I could just do exactly this, and then I need to put my code block in there. But what you're going to see here is this little squiggly, and it's going to say, hey, you can go ahead and move the Lambda argument out of the parentheses. It's just a convention that is allowed inside of Kotlin. So now I can just say anything I want here. I can say print line message 1. I could say 2. I could say 3. I could do something like this. I could run this. I could even put my own loop inside of here. I could say repeat, 5 times. I could do my own Lambda expression, because that repeat thing takes its own Lambda expression. Repeat is part of the Kotlin standard library, by the way. And if we run that again, what we'll see now is we'll see message 1, 2, 3, 4, 5 repeated right here in the middle, all separated by our top and our bottom parts of our line. So this, what this has allowed us to do is create a much more extensible function. So we now have a function called line logger that I can pass in whatever I want. I can do 20 different logs in here. I can do 10 different logs, and it'll help me be able to find perhaps my logs inside of a logger. That's a very naive and simple example, but it shows you the power of basically delegating the responsibility back to the caller. So I'm yielding this call. So right here, I'm going to be yielding whatever's happening here to execute what's going to happen here. So let's think about this for a second. First thing that happens is we call line logger. Line logger says, hey, no problem. Cool, I have a block. Then the first line of code executes. It says, all right, well, I'm going to print this thing 5 times. And then now after that, what I have now is I have this little block of code. And this little block of code right here, I need to run. And that little block of code is this stuff right here. It's whatever's in between these 2 brackets up here. And it's going to run that block of code. And then after that's done, it's going to go ahead and return back down. And it's going to run the next 5 iterations of this repeat loop. So it's basically going inside of here, running this, hopping back out, doing something out here, and then hopping back in and finishing up down here. And so that's a very simple way that you can actually implement a Lambda expression inside of a function. Now let's also create maybe another Lambda expression here. Let's call this one repeater. So repeater, we'll want to say, maybe you want to do something over and over, kind of like very similar to like a loop would have. So let's do the same thing. Let's create the same signature here, but this time we're going to say repeat 5 times, and then what we're going to do is we're just going to call the block 5 times over. All right. So then what we could do is we could do something like this. I'm just gonna comment this out for now because we don't want to see that inside of the output. So we'll say repeater, and then it's gonna take it in a block. And so inside of here, I can just say print ln hello. And what's gonna happen is when I run this, repeater is gonna run and it's gonna print it 5 times in a row. But now, of course, we're trying to make our application a lot more user-friendly. So we want to be able to provide how many times we think these things should repeat. And so what we can do is we can go ahead and say, all right, I want number 5 in here. And so I'm going to say number 5, but there's no way we can tell a repeater to do that. But we can. So we can go down here and say, how many times do we want you to repeat? And that's an integer value. And I can take the integer value and just drop it right into this repeat function. Again, we're kind of duplicating what's happening here, but I'm basically telling, hey, I want our little repeater to run 5 times. And then what's going to end up happening is it's going to run 5 times. Now, for whatever reason, later on, I decide I want this repeater to run, 3 times or 13 times. I'll run this here. Our little repeater thing will run 13 times. Now, as I start thinking about it, eventually I realize it would be really great if there was a way that I could understand, that I could get to what iteration I was on, because I realize that when I am going to repeat 5 times, I want to say hello 3 times. So hello 3 times. And then I want to say goodbye 2 times for whatever reason. So how would I do that? So I want to say print line. And I'll say goodbye. But how am I going to say that on the first couple of iterations? I don't know what that is. So what I need to do is expose that value to the block. So basically I need to tell the block, hey, you need to be able to get some value. Now remember, this value, this right here is the input type. There's no input types here. We didn't provide any parameters. It's still going to return a unit, so it's not going to do anything. But what I wanted to change this to is say, hey, you know what? I want this block, so again, this chunk of code, I want it to be able to accept a parameter. And this parameter is going to be an integer value. And now immediately what you'll notice, right, is right here, we have a squiggly error saying, hey, there's something wrong. And what that means is that we need to pass a value in there. Now, little did you know that the repeat function that is built into the standard library actually gives us an index. We just were not using it before. And so I'm just going to go ahead and use it now. And so I'm going to pass in the index. And every time the repeat function fires off, it's going to give us an index. I'm going to send that index directly back to our block. And it's going to get called inside of here. And so let's go ahead and use our index. There's our index. And now we can do something with it. So what we can do in here is we can say if index is less than 3, go ahead and do this. And else, we're going to go ahead and print this. And so now if we run this, what we're going to see here is hello, 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 goodbye, goodbye. Because what's happening is the index is being printed. So let's go ahead and print line on the index. For each iteration of this loop, we can see down here, each time, so remember we're calling repeat, which is built into the Kotlin standard library. It just tells, hey, repeat this little function however many times we tell it the time. We told it 5, and each time it iterates, it's going to call this block. And this block, all this block is this chunk of code here. This is the block. And then what it's going to do is it's going to pass its current index in here, which is what we decided to do here. And now we can decide to start iterating inside of here and perhaps perform some logic. And if it's less than 3, of course, we're just going to print hello. Otherwise, we're going to print goodbye. Now, this could be done for any number of things. We could decide to use the index. We decide not to use the index or whatever. And again, if we don't want to use it, we don't have to. We can just kind of get rid of it. Again, we'd have to make sure we're not using the variable, but here we are. So this is how you can go ahead and pass a variable into a Lambda function and basically receive that variable back into the block itself. So we've created a function called repeater. We're going to tell it how many times it needs to do something. And then we're going to say, hey, every time you do something, we want you to call a particular function. This function, we're going to call it block. It's going to take in an integer. I don't care what the integer is, but it's going to take in an integer, and it's not going to return anything. And then inside of our function, we say, hey, we're going to use the built-in function called repeat. It's going to repeat, and then every time it's going to give an index, and we're going to pass that index into here. Now, I could pass any number I want here. If I wanted to the whole time, I could just pass the number 3. It doesn't matter. It doesn't have to be the index. It could be 3 times 1,000. It doesn't matter. All this block, all this function signature is saying is this block is expecting its first parameter to be an integer, and it's not going to return anything. That's all it's saying. So it doesn't matter if this value right here is the index or if it's a random number. That's up for you to decide. Here, we're passing in the index because we want to know when we're using a repeater function what index we are when we're repeating. Are we the 5th iteration, etc., the 20th iteration? What are we doing at that point in time? Okay, so there, now we have that repeater. So let's go ahead and comment this out. So let's assume we wanted to do something a little bit different. So let's say we had, let's call it a function called Derby Announcer. And this Derby Announcer function is going to take in a lambda expression. This lambda expression will look like this. It'll be a block of code. It's going to take in a string. So this first parameter is going to be a string, and then it's actually going to return a string. So this lambda expression is going to return a string. And this announcer is spelled wrong. And so what we'll do here is let me fill this out. Okay, we're back, so you didn't have to see me type. So the Derby Announcer function does a few things. It has a lambda expression. It's a block. That block takes in a string as a parameter, and then it returns a string. And then what we're going to do here is it's going to be like a home run derby announcer. And these are different names of perhaps some baseball players. So you have McGuire, Canseco, Honeycutt, Davis, Dolly, Weiss, etc. And then what we're going to do is we're going to randomly choose a player's name, and then to the screen we're going to put the next player's name. The next player is whatever this random word is. No, it's going to be, we can change this to random player. At that point, this will print to the screen, and then what we want to do is maybe we want to have some type of log that we want to print to the screen, but we don't know what that's going to be, or we might not want to, print some other type of thing. We could call it a log, could call it, something from the announcer. Announcer topic, announcer message. Do that. But we don't know what that's going to be because it could vary between announcer, and so each announcer could be a little bit different. And so what we want to do is allow the announcer to say what they want to say. And so we're going to delegate that back up to the block. Remember, we're going to pass in the random player that we chose, we're going to pass back up to them. But this block also returns a string, remember? So if we look at this block, it takes in a string. Right here, it takes in a string, and then it returns a string. So if we were to implement this, what we could do is we would say Derby Announcer. And we're just going to pass in a lambda expression. Again, it's going to take in a player. This is what's going to be sent in. So it's going to take a string. We could say this is a string, or we could use type inference, and then we can go ahead and do something. And now we need to return something out of here, and we can say something like this: player is a great asset to the team. And this is the value that's going to be returned. Remember, because it's the last value in the lambda expression, it's what's going to be returned inside of here. Now if I did length, we're going to run into a problem. Why? Because we're expecting a string, but we're giving it back an integer. So okay, now we have this. So the Derby Announcer is going to say something. The Derby Announcer is going to say this player is a great asset to the team. So now what's going to happen if we run this is that the Derby Announcer, we don't know what player we're going to get, but here we get the next player is Canseco. Canseco is a great asset to the team. And again, the way this happens is Derby Announcer gets called. We have a list of players. We grab a random player off of that list. We then print something to the screen. We then take that random player. We send it to the block, which is this player here. We then do something with it. So this could be any string. So it depends on the Derby Announcer, whoever's using the Derby Announcer lambda expression. It could be a number of things. I mean, it could be going out to a database, could be going to a web service, it could be going to a big, a Megatron at a big ballpark to generate stuff. And then once that happens, we go ahead and take that value and we send that value of whatever message we have. We're going to send it back to, through the lambda expression saying, well, here's what we want to return. The lambda expression takes that and then does something with it. And here it's just going to print it to the screen. So we're basically coming in here, hopping back out, doing something, grabbing the value outside of this external function of this lambda expression inside of here, bringing it back inside of this function, and then doing something with it again. So we're allowing it to yield some control at this line right here. Is allowing us to yield some control to some outside caller, which is really powerful. And this enables you to do some really powerful things. And it doesn't have to be a string. It could be any types of things. It doesn't have to return a string. It could be returning all different kinds of things. And so this is how you can use lambda expressions by passing them as parameters as, arguments into other functions. You can create your own Lambda expressions to pass around. You can create your own functions that require Lambda expressions, and then you can delegate behavior back to the caller. You may be developing an API, and you know that you wanted to get something from the end user, but you don't know what, but you want to give them a little bit of data. Here I'm saying, this is my announcer. Perhaps I'm creating some code for a baseball field, and this announcer is going to be, get a random player for whatever reason. Maybe it's a home run derby. And so we're going to get the random player. Who knows what they're going to say from there, but I need to get that information back because maybe I need to take this information and give it to a teleprompter. Maybe it needs to show up on a teleprompter. I don't know. So all different kinds of things you can do, but you can delegate this stuff pretty easily using Lambda expressions. Let's assume that you're creating a lorem ipsum generator, which is Latin text. It's typically used in a lot of copywriting when you're not sure what you want to write and you're designing some text. And when you're doing this, here's, for example, the code. We have a bunch of Latin words here, and we want to randomly get a bunch of words. And we have a function here that basically says lorem ipsum. It takes in the number of times we want, the number of basically words or loops we want to do, and then basically does a repeat. And what happens is we'll do something a number of times. So if it's 5 times, it'll repeat this 5 times, giving us the index of each time. And then what we do is we look at the list of Latin words, get a random word, and then we send that back to whatever the block is here. In that case, it's going to be this caller here, and you're going to get back the index. So basically the current iteration. So if it's the first one, it'd be number 1. If it's the 5th iteration, it'd be 5, and then whatever the random word is. And then at that point, you can do whatever you want to do with this random words from this lorem ipsum text. So let's say you do that and you run this now, and then you have this text here. And of course, this is going to change each time because everything is kind of random. Now, notice one thing here is that we're not really using this index parameter. And so we do need the word parameter. So what we can actually do in this case is a couple of things to clean this up. First of all, due to type inference in Kotlin, we can get rid of the types. So already, Kotlin's going to know, sounds good. We already know that the first type here is going to be an integer because that's declared right here. And the second type is going to be a string because that's declared there. So we don't need you to define the types for us. We can do that for us. Next, by default, there is a kind of a standard that when a parameter is not used, but we do need to declare it here for the purposes of the compiler, you can use a underscore. And that basically tells Kotlin, hey, we know that there's a variable here, but just go ahead and ignore that. And so if we run this again, we can execute it and that would work just fine. Now, another interesting thing is if for some reason we didn't want to do anything with it here, say we didn't want to use word either. Now we also get this here. We can rename both of these to underscore, and that's kind of the default mechanism and the default nomenclature for variables, inside of a Lambda expression that are not used. So basically this means unused. So anytime you see an underscore inside of a Lambda expression that you're using or in code somewhere, it means whatever this variable is, it's not being used, so therefore it's been turned into an underscore. It's very common that a Kotlin Lambda expression only has one parameter, as the repeat function does here, which is built into the Kotlin standard library as shown here. It has one value, and that's the index that is currently iterating upon. So if we were to run this right now and we told it to repeat 10 times, we would see that this is iteration 0 through 9. Again, this is 0 based indexing. So we have 10 iterations here. So this is printed 10 times. Now, anytime you're working with a Lambda expression that has one parameter, the compiler is usually smart enough to figure out, in almost all of the instances, the types. So we can remove the type. That's one improvement here. But you can actually improve this a little bit further by actually completely removing the parameter altogether. And on a Lambda expression with one parameter, by default, Kotlin will call it it. So it can infer the type of the actual parameter. So if it's a single parameter, in this case, repeat only has a single parameter, it'll show as it. Now the same thing happens for many other things like the map inside of the collections. You have map, you're going to have filter, you're going to have a bunch of other things of that nature. And if it only has one parameter, you can reference it with the word it, and Kotlin will automatically map it to that. So now if we run this again, we'll get the same exact result, but we save ourselves a number of characters when we're coding, and over the course of a long, weeks and months of times, it's a lot of code and it's less cognitive load for you to read in the future, and you can just replace all the extra code with the word it. And make sure you include the $sign if you're using anything in regards to string interpolation. Otherwise, if you didn't want to use string interpolation and you were going to use something like this, you could then go say it plus maybe 1. Let's say you wanted to do that. And you're going to print that line. So it, again, is just a variable. And now we get 1 through 10 because we added 1 to the index. And that's how you can use the it keyword in Kotlin in Lambda expressions. Let's talk about how you can call Kotlin classes from within Java. So we'll talk about the JVM interop here. So let's assume we have a couple of files here. One, on the left-hand side, we have a customer model. All it is a Kotlin data class that contains a customer and it has a function in it. And basically the function checks if the customer has a long name. We have maybe some type of service. So we have a couple of packages here. And inside of this application, we have some Kotlin, some Java for whatever reason. It has to be Java, or it's just maybe a very large file that we haven't converted to Kotlin yet. And you need to call into some Kotlin maybe that was written. Now you can actually do that. So here we're in a Java file, and let's say that we need to interact with the customer. And so let's have a method called process customer. So we'll say public void process customer. And then what we need to do is we need to work with the customer. So we need to take a parameter here. So I say customer, and I say customer. So we'll do it just like Java has it, open, close brackets. We need to import this. Now again, this is a Kotlin class. So if we go to the definition, we're going to see that now we're back in Kotlin. And that's it. Now we are able to work with this customer. If we want to do something with the customer, we can say customer dot, and then we have all of the methods that are available to us. So customer has long name. That's a Boolean value. That's over here. That's this method right here. If we want to get the customer's name, we now have get name. Now this is interesting. So get name actually goes to name, but we never defined a get name method. Now Kotlin takes care of that for us underneath the hood, basically creates a get name and set name for us. But if we look, there is no set name. And the reason why is because this is a val. So this is a read only. So we cannot reassign this value. It's a read only type. If for whatever reason this needed to be writable, it needed to be mutated, we could then change this if we had access to the Kotlin code. And then we could actually, then at that point, Kotlin will give us the set name and we can pass in the value, whatever the new name is. Now, at this point, you can call into Kotlin very easily. You can say customer has long name, and you can do anything that you would really like to do at this point in time. The only thing you really have to really worry about with these classes is the different types, and you can know that the getters and setters are generated for you automatically through Kotlin, because inside of Kotlin we don't need to actually generate the getters and setters because we just will access it directly off of the name properties. We can just set the name equal to something, and that's how you can call very simple objects in Kotlin. Let's assume that we have this Java class and we need to call it from Kotlin. Well, that's pretty easy to do. This class has a couple of options. One is we can get a customer from a social profile. So this would assume that this was going out to some social media, API, and it would get the customer and then return customer back. Maybe we would look it up by their social media handle. And this method basically returns a list of processed customers that's doing some processing in the background. The implementation is not important, but what is the types and how it's being called. And then we have a Kotlin file called customer facade, following a very common facade pattern where it maybe is interacting with a bunch of different services to perform some work on some customer objects. And lastly, of course, we have the customer object, which just has customer's name and some other methods in here, which are negligible at this point. So inside of customer facade, let's assume that we needed to call into the customer service, which is Java. How would we do that? Well, let's assume we wanted to do it, pass it in via the constructor. So what we can say is customer service, And now we are working directly with the customer service. We can say something like this. We want to get the customer, and then we can say equals customer service dot customer from social, and then maybe we'll pass in, username. So just example username. Here we are now calling into Java from Kotlin, but there's something interesting to note here is if you look at this right here, you'll see customer has an exclamation point at the end. And what that means is that it is a platform type. And this means right here that T could be null or it could not be null. So we're not sure. You have to decide for yourself because you're calling into Kotlin. So there's a couple of things you could do here. Now, of course, if I were to just type inside of my application, I would just type, customer dot name. I could do this. I could say print line customer.name, and that should work as long as the customer is not null. But however, there is a chance that this customer object could be null. And if it does come back null, I am going to get a null pointer exception. So a couple of ways to handle this inside of our Kotlin code. We could, of course, just go ahead and use the double bang operator. That will force it to not be null. However, that is a little bit of a code smell. We could use require not null. That will work as well. But again, this will crash the application. Sometimes that's the only thing you can do when you're calling into a library you don't have control over. Then at this point, you're saying, well, I know the customer's not going to be null because I'm requiring it not to be null. You could wrap this in a try catch. If you have access, though, to the actual Java code, you can go to this implementation and you can slap on an annotation. You can slap on the not null annotation, and there's various different ones from the JSR to, I'm using JetBrains version here. There's one for Android as well. And what this will do is tell Kotlin that, hey, trust us, we know what we're doing. If we return from this, it's not going to be null. So now, if you notice, the exclamation point went away. Kotlin saying, well, you are telling me via this annotation that whoever calls into customer from social will get back a customer object, and that customer object will not be null. So we're going to go ahead and trust you, and then we can go ahead and execute accordingly. And at that point in time, I can do whatever I want. Now, this also can be a little bit further here. Let's take a look at the other method. The other method is processed customers. So process customers here. Let's say val customers. You can say customer service dot processed customers. Maybe you're processing them to update account details or whatever. Now notice the same thing. Again, it's being a platform type is being returned here. We have the exclamation points that are returned, but now we have two of them. We have a list and we have the customers. Now what this is saying is like, hey, Kotlin folks, we're not sure if this is a read-only list. We're not sure if this is a mutable list. We're not sure if this is null, and we're not sure if this is or nullable. We don't really know yet because you're calling into a platform type. We're not sure what it is. And so you can start slapping on additional annotations on here. But for example, you can also put a not null annotation here. And this not null annotation, then again, we'll remove that saying, hey, this is at this point, this is a list that's not going to be null. So therefore, if we do perform some operations on the list, which we can, at this point, which is nice, we can actually map over this list, which is interesting because we're calling into Kotlin, we're getting back an array list, and then in that array list, we're getting it back inside of Kotlin, and now we can start performing using our Kotlin standard library collection utilities. Now this makes life a lot easier. I can perform filtering, I can perform all different types of things directly inside of Kotlin after I've called into Java. So a bunch of different stuff you can do. One thing you just want to be aware of is when you are calling into these various platform types that you check for nullables and make sure that you don't have null pointer exceptions. Let's assume that we have this extension function inside of a string extensions.kt file. And this extension function extends the string class and allows us to grab the initials. So if we were to have something like this, have a string that says Don Felker, the output would then equal df. It would just grab those initials. So it's not a very robust function. Actually, it could be quite error prone, but for simplicity's sake, this is what it does. If you pass in a string with separated by space, you'll get back the initials, and let's just assume it's a name. Okay, now if you want to call this from Kotlin, of course, we're very easy, we can do that. So let's assume we have a customer here, and the customer has a name property. So again, if we go look at what a customer is, we have a customer class. So it's a very simple data class Now, if we have a name is a string, as we can see here, and we can just get the initials off of the name. So that's, pretty easy in Kotlin. So now we have the initials, we can do whatever we want. It makes sense. However, there are times when you would like to call these extension functions from a Java file. The question is, can you do it? So let's assume that we have this Java file that processes customers, and in this method, customer from social, assume we are retrieving a customer profile from a social API. And here we have the customer object. Now we want to use the user's name. So of course we have get name, which is generated for us. Now if we were to type initials, we're going to see that it doesn't exist because extension functions don't exist in Java. But we can still use that code that we wrote in Kotlin as an extension function. And previously, if you've worked inside of Java, you've probably written a lot of helper functions, and they've been inside of basically static classes. And so what we'll go ahead and do is the string extensions file actually generates a file for you. So this is a top level function. It's not inside of a class at all, but it does generate a file for you. And so if we type string extensions, you'll see string extensions and then KT at the end. String extensions KT, and then there's a static method called initials, and you pass in a string, and now you can get your initials. So you can say string initials equals, and this will call into, if I go to the definition, calls into this extension function. So this is how you can call into an extension function inside of Kotlin. So any extension function you have, you'll want to look at the actual file name. Now there is a way to modify the file name using the JVM name annotation, and I'll show you that in another video. But if you want to call into any of your extensions, so if this was just called extensions.kt, then in that case it would just be extensions KT. So it basically slaps the 2-letter KT at the end, and then at that point in time you can access it just as if you did with a regular helper function that you may have traditionally built inside of Java. And that's how you call an extension function from Java. Calling an extension function from Java works, but let's be honest, it looks a little bit clunky here. There's this weird KT thing that we have at the end, which we didn't specify there. Inside of the string extensions file, it just looks like this. We never specified a KT in here. So having KT riddled throughout your code base can be kind of a weird feeling and kind of a code smell. Thankfully, the folks over who developed Kotlin thought of this. And what you can do is actually change the name of the actual file that's generated. And what you can do is add this annotation called file, JVM, name, and provide the name of the file. So here I would want to say string extensions, or I could say string util. So I'm say string extensions. Let's save that, and I'm going to go back to where I'm calling it from Java. And then immediately we notice that our previous call into here is not working anymore. So if we were just type string extensions, now we just see string extensions dot initials. So I can go ahead and fix this by just removing the KT. Now I don't even really know that I'm using Kotlin at all. It's not basically polluting my code base inside of my Java files. Now there may be various reasons why you can't move this to Kotlin, and if that's the case, this might be of very good use to you. Or if you're exposing your extension functions to outside callers in other JVM languages, you may want to go ahead and provide a JVM name so it's nice and extensible and readable and doesn't pollute their code as well. Now you can name this anything you want. It doesn't have to be whatever the file name is. If I want this to be happy clown file, happy clown stuff, I'm going to go over to customer service and we're going to see that this doesn't work. I'm going to have to replace this with happy clown stuff. And so I can give that JVM file name whatever I want. That's what that's going to be. And so that wouldn't work anymore. So of course we would never want to name something like that, but we can go ahead and take it back to string extensions. We'll save that. Again, that's not going to work. String extensions. So anytime you are working with something like a Kotlin file that has a lot of top level functions, which this is a top level function, it's not inside of a class, it's just basically sitting inside of a file somewhere. It's a top level function, and you need to expose those to other JVM languages such as Java, and you want it to have a nice pretty name. Go ahead and slap the JVM name annotation on there at the top of the file, and that will change the name. So therefore when you call it from another language, it'll look nice and won't pollute the code. Quick little hack I want to show you. Inside of any file, you can put a top level function called main. And inside of this main function, anywhere you want, you can print line or do whatever you want. And what you can do is type code here. Now I can actually run this directly here inside of the IDE and it will execute this code. Now I do have another main file down here, which is where my main application would normally start. However, if I'm buried somewhere in my application and I would like to test out a quick idea, maybe I'm kind of working with a regex I want to play with, I can just run this directly right here, and I can hit run, I can do debugging, everything, and if I hit run, down in the output window, we'll see foo. So this can be anywhere. I can take this here, I can go over to a customer class, I can put a function over here, and I can do something here, and I can run something from here. So anywhere you put a top level main function, you can execute it with inside of the IDE for a quick feedback loop inside of IntelliJ. Sometimes you want to interact with your code in a session where you can kind of play with it. One way you can do that is with the Kotlin REPL, which is the read eval print loop. And to do that, again, that's through tools, Kotlin REPL. And once everything is loaded, then you can start typing code into here. So for example, let's assume that we wanted to go ahead and build a string. So we say val name equals Don. And then I use command enter to enter it into a new line. I can say name.length. Command line, it'll tell me it's a integer, it's 4 characters long. I can do other things such as name.substring. And I'll get the nice IntelliSense in here, or code completion. And we go with the first character there is D. I can also use, for example, some of the classes I have. I have a customer class here, which is a data class. I can use that inside of my REPL because it was loaded. So I can say customer. So I can go down, tab. And what will happen is you'll see it actually imported customer there for me. And so I'm going to say val customer equals customer Don, enter. And so I had to import it because if I don't import it, it won't know about it inside of the REPL. So I can say customer, and if I hit enter on a customer, it'll tell me the type of the customer and then what the toString value is. And so I can say customer.name. I can also do customer.name.initials. Now notice this, I'm actually calling in a extension function that I have. It's called initials, and we have an exception there. And the reason why we got an exception is because the string value of customer, it does not have a space in it. So if I were to redefine my customer, so we'd do another customer 2 equals, I were to provide my full name with a space, then the initials function would work. And I didn't tell it to execute yet. I just pressed the enter, and then I can say customer2.name.initials. Now if I enter here, we'll see that it does execute properly. So you can actually interact and do all different types of things inside of the Kotlin REPL. And again, that's accessed via the tools, Kotlin REPL. So it's a good place to come around and play around with some code that you're maybe testing, trying to figure out if it's going to work or not. Maybe you're trying to understand a certain interaction with the library and you don't want to fire up an application. The REPL is a great place where you can do that. And when you're done, you can go ahead and over here and hit the close button, and then you're out of the REPL. So let's go ahead and create a actual Kotlin simple calculator. To do that, you'll open IntelliJ. You'll click create new project. You're going to want to select Kotlin from the left-hand side, then JVM IDEA. You want to give it a name. I want to say simple calculator. You can leave these default settings enabled. Or hit finish. This is going to go ahead and create a new project for us. On the left hand side, if the project window is not open, go ahead and click the project window to open it, the Project Explorer. Inside of SRC, we're just going to create a new file. So you can right click or Command M. So right click, new, Kotlin file class. We're going to call it main.kt. Now it's an empty file here. Now at this point in time, we need to go ahead and fill this out. So we can say fun. Main, that's going to be the main function, open and close. And now we have a main function. Now typically a main function will have some type of parameters that can be passed to it from a command line. So that's going to be var arg string, which means that there could be many variable amount of arguments that are passed in. It's been basically grayed out because they're not used right now. So then at this point in time, we're ready to start building our application. And the first thing we can do is provide some type of basic output, and we'll say, please enter an arithmetic problem. And if we save this and then we click this little run button now and hit run main KT, we'll notice it's going to build down here, and then down at the bottom, the run window will open and it'll say, please enter an arithmetic problem. And at this point in time, you've actually created your first Kotlin program, though all it does really is write some text to a console and exit. And we can see that the program is exited. So basically, the execution of the program started the main function, it printed this, had nothing left to do, and it exited. So that is the beginning of our application. Okay, so we've built the first version of our application, but we need to receive some input from the user. And to do that, we can use the readline function that's built into Kotlin.io. This is built into the platform. And this will allow us to read some input from the user on the command line. And then what we can do is say print line, and we'll say you entered the value that you entered using string interpolation. And if we go ahead and run this now, in the output window down below, what you're going to see down here is that please enter your arithmetic problem. We'll see 1 plus 2. Then we'll see over here that you entered 1 plus 2. And then of course the application exited at that point in time. So this works great. We can now get some values from the user, but just like a regular calculator, a calculator is not going to stop after you enter one problem. So we need to enter multiple problems. And this is a perfect opportunity to use a while loop. So what we can say is while is not null, then we can go ahead and grab some values. And so what we'll say here is we need to get the input again. And then let's go ahead and print this here. So we did val, we need to make this a var now because we're going to be resetting it every time. And let's go ahead and print line what we said, you entered input. Now we're going to run into a problem here because we haven't told a way for the while line to exit. And if we know anything about the read line, what read line says is it will return a read or null if the input stream is redirected to the file. We're not redirecting to a file, so we're not going to get null back. So if I press enter, we're probably going to get a line feed inside of here. So what we need to do is have a way to short circuit out of the while loop. Otherwise, this chunk of code will just continually run on forever. There's no way for us to get out of it. So if we were to run this now, let's go ahead and see what that looks like. Let's run it. And let's enter a problem, 1 plus 2, okay, 2 plus 3, 5 divided by 10. And if I enter, we can't get out of this, we're stuck. So we need a way to short circuit out. So I'm gonna stop the program. So we do need to actually figure out a way to get out of this. So what we can do is we can check to see if the input is null. So if the input does not equal null, that's what we're doing, but let's also check to see if it's empty. So, and the input is not blank. So if we go look at the implementation of that, returns true if it's not empty and contains some characters except the white space characters. So we want to make sure it's not blank, it just contains something. So if that's the case, then this piece of code will just continue executing. And this will be the main, in a moment, this will be the main section of our calculator app. So let's go ahead and run this again to see what this looks like. And once we run this, we'll see, okay, 1 plus 2, there we go. We got 2 plus 3, we got 5 divided by 10. So we can keep entering things over and over. However, now, if I press enter, what we're gonna see is that the process finished right there. So it exited out of the application because what it made it exit out is basically, it is blank. So therefore, it only continues if it's not blank. And therefore, the application said, well, it's blank, and at that point, it exited. So now you could do a couple of things here. So if you wanted to say goodbye, you could pretty much do that right here. You could say print ln goodbye. And then you would know that the program exited. So we could do this very easily. You just hit run here. And now we can enter the arithmetic problems. 1 plus 2, 3, 33 plus 2, and then enter. And it'll say goodbye, and then it exits. So we know that the actual program is exiting. Of course, we do know that already from here, but when we compile it later, it would be nice to have some user feedback to say, hey, we're done with the program. So now we can actually create our calculator inside of this piece here, because we can now process many different problems one after another. Each time we're going to get some new input via this readline method, which then will change, and then we can process it, which we'll end up doing right in here. Now that we have the user input, we need to decide what to do with that user input. So we kind of need to break it apart into a couple of sections. If we have a problem that's entered like this, we need 3 different components. We need the first number, we need the operator, and we need the second number. So we're gonna need 3 different types of variables from that one string. And we can do that very easily. So let's go ahead and get rid of this. We can do that very easily by declaring another variable called values. And then what we're going to do is we're going to split the string on a space. And what that will do is it'll give us a list of strings that we can go ahead and check on. So let's go ahead and take a look at each one of these strings. So we'll say values, 0. I'm going to duplicate this line a few times, 1 and 2. Now, of course, this is not going to be error proof. If for some reason we do not get enough values in here, we could, crash the program, which we'll see here in a second. If we run this main program, what we'll see here, please enter arithmetic problem 1 plus 2. We'll then see that we have all of the operators now separated. So we have the number 1, number 2. If we were to do 5 plus 4, we would get those broken apart. But if I only put 5 in here, we're going to get an index out of bounds exception right here on the 10th line, because I'm just pressing, I pressed 5 in there, it's split on a string, so it's not finding this and it's saying, hey, there is nothing inside of here. Looks like I probably found a string or a new line or something there. So we can't find anything in that regard, so we're going to go ahead and throw an exception. So this isn't really foolproof, but it does give us the ability to actually start performing our operation. Now, the one that's really important to us right now is actually this first one. And this is because this is what's going to give us our plus, our minus, our multiplication, or our divide operator. And then at that point, we can decide how we want to progress in our application. And so based upon if this is a, if this value is, a plus sign, well, then at that point, I want to add something together. And so it's going to say, we're actually doing print line. There we go. If the value is a plus sign, then we're going to want to go ahead and add it together. Otherwise, we can say else if values is, values 1 equals minus, then we can do something else. So we could continue this path down of else if, and this will work. There's nothing wrong with this. We could do this. This will work. However, it does get a little clunky. This is a perfect opportunity for us to use a when statement. So we can say when values 1, so check that value 1, and we can say is plus I want to do something. So I can say print line add. When is, and is not going to be needed here because we're actually just using it directly against the value. So we'll say plus, and we can say minus, say print line, subtract. I'm going to go ahead and duplicate these real quick, and then we can go ahead and, of course, we'll say multiply and divide. It'll be pretty easy. And divide. And then for whatever reason, if we don't have something that matches, we might want to say throw legal argument exception. I'm going to say invalid operator, and we'll just go ahead and pass in whatever that value is. So we'll pass in values 1. And then that's going to allow us, we'll go ahead and get rid of this down here. This will allow us to actually see and do something different based upon each one of these input types. So let's go ahead and run this program, and we'll put a few of the arithmetic problems in here. So 1 plus 1. So it looks like we have add. So we have 1 minus 4. Subtract, we have 6 times 7. Multiply, 42 divided by 10 is divide. And let's go ahead and just throw something crazy in there. Let's do like, for example, maybe we want to do powers of, but we haven't implemented it. We could do 10 to the power of 5. Boom, we have an exception, invalid operator. And we have the to the power of operator, which is normally used in math inside of programs. So here, our calculator is a simple calculator. It's only going to process these different types of inputs. So now let's go ahead and implement each one of these, and I'll be right back while I do that so you don't have to see me type. Okay, now we're back. So I've done this very easily. I've taken the first value, I convert it to a double, and take the second value and I convert it to a double. I've converted everything to doubles here so we don't lose any precision. Now there's one thing I would like to do, that I would like to clean this up a little bit. And so what I'm going to do here is I'm going to go ahead and say, I'm going to refactor this. And I'm just going to say extract this into a variable. And it's going to ask me to replace two occurrences because it's occurring two places. So sure. And I'm going to call this operator, just so it reads a little bit better. And it's actually saying we can move it into the declaration of the when. And if we were to do that, here's what it would look like. I could just move that into the declaration there. I don't like the way that looks. It looks a little bit, it's too much for me to read. This is a lot easier for me to read, so I'm going to leave it like that. So I have my operator. And then what I could also say is something like this. I could go ahead and extract this. I could refactor it. I could extract this into a variable. And it does occur 4 times. So we're repeating ourselves, which could be problematic for updating our code later. So I'm going to call this LHS for left-hand side. I'm going to do the same thing over here. I'm going to go ahead and extract a variable. We're going to call this right-hand side, RHS, for all 4 occurrences. So now we have our input, and we've got our operator, our left-hand side, and our right-hand side, and then this is pretty easy to see. So when the operator is a plus sign, we're going to go ahead and print out we're going to convert all these to doubles and say, all right, so we don't lose any precision, which can happen sometimes in multiplication and division, depending upon what you're doing. And then we're going to go ahead and actually perform the operation. And then what we're going to do at that point in time is we're going to go and print that value, and then we're going to go ahead and do a read line. So let's go ahead and run this to see what happens. So I've entered arithmetic problem, 1 plus 1. We got 2. 2 times 5. And we see we got an index right out of array exception. And that's because we didn't put a space there. So we do have some input problems that we possibly do need to process. So let's go ahead and see if we can get each one of these to run accordingly. So we already did a plus. Let's go ahead and do a subtraction. 1 minus 6. Okay, that makes sense. 8 times 7. 56. Let's do 60 divided by 10, 6. So all that makes sense. So our application does work now. We now have a application which is a simple calculator that shows us how to do adding, subtracting, multiplying, dividing. Our application works fine at this point, but we do need to provide some type of validation. For example, let's go ahead and run our application. And let's assume that we make a mistake during typing, which could be very common. We say 1 plus, and we forget to enter, let's say 1 plus 1 works. But we do 1 plus, and we forget to enter the additional value, and we hit enter, we receive an index out of bounds exception. So what we need to do is check that we have the proper number of arguments. So what we can do is say if values.size is less than 3, because we need at least 3 parameters, then we're going to throw an illegal argument exception and say invalid input, expected value plus value, received, and then whatever the input was. So now if we run this, what will happen is we're not going to get index out of bounds exception. What will happen is we can still enter 1 plus 1, we'll still get that. But if we enter 1 plus something, when we forget to enter the additional value, we'll now get an illegal argument exception that was thrown, saying invalid input, expected value, blah, 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 it was this particular value. Now, you could decide to crash the program if that's what you'd like to do, or you can decide to skip this completely. So we could change this. So instead of having it throw an exception, we could actually just have it say print line. We print line if values are less than 3, else. And then we can wrap everything else inside of an else here. And what will happen now when we run the application, we'll run this and we'll go 1 plus 1 is 2. If we do 1, what is it today? It's 2 plus something, we make a mistake, enter, invalid input, expected value plus value, receive 2 plus. Okay, let's try it again, 2 plus 3. Okay, well, it works. So now our application isn't crashing. We've performed some level of validation. We're providing the feedback to the user, and we can continue using the app, and it works as we would expect. Now, but we also have another problem. The other problem is going to be, let's go ahead and run this. What happens if, for whatever reason, a user enters 1 plus 2, and then the next time they say 1 plus dog. What's going to happen there? Well, we get another exception from the program and the program crashes. And a calculator doesn't know how to handle the word string dog. And so it says number format exception for input string dog. And if we take a look at line number 18, it's happening right here. And the reason why it's happening is on the right hand side, we're trying to convert that value, the RHS value, which came from here, which is the third item in the list. We're trying to convert it to a double. And that's where the problem occurs. So we need to do something here. So one quick thing that we can easily do, which works very well, because at this point, this isn't an illegal argument. We shouldn't be able to handle this inside of our application. What you could do is you would say to double or null, and then what we're going to do here is we're going to do the Elvis operator. And the Elvis operator says, hey, if something happens here and this is null, then I want you to return another value. And so this is going to say throw legal argument exception, invalid input, and then we'll go ahead and actually just go ahead and render that input values 0. Now what's going to happen here is if this value right here can be converted to a double, it will be converted to a double and it will be returned here. Otherwise, if it cannot be returned to a double, a null will be returned. At that point, the Elvis operator will interrupt and say, hey, this is on the left hand side over here, this is null, so we need to do something on the right hand side. And then we're telling it, hey, if you encounter a null, throw an illegal argument exception. So basically we're trying to parse it. We couldn't parse it as a double, so therefore it was returned as a null, and at that point it then short circuited to the right hand side over here. So we'll do the same thing over here, to double or null, and then I'm just going to copy this to save some typing. There we go, and then this will be value 1. Now if you can see over here, all these are grayed out because we're already casting these to a double. I can actually remove these redundant calls. So boom, we'll just go ahead and remove these real fast. I'll be right back. Okay, now I'm back. We have our very succinct and clean version of our calculation. And so very nice here, very, very succinct at what's happening. And we can actually print things directly to the screen. So if we were to run it now, say 1 plus 2, we're gonna get back 3. If I say 1 plus dog, we're gonna get an illegal argument exception and valid input. Now, of course, this is crashing the application. So there's a couple of things that you could do here, and in which I would challenge you that we're not going to do, that you could do on your own to challenge yourself, is remove the illegal argument exception. And you can either decide to make it a 0. So you could just do something like this. That would make it a 0, so that it would be a double or 0, which wouldn't work. So because as you see here, the type inference is giving you an example. Or you can go ahead and say double or null. At that point in time, it could be a double, and the same thing down here, and then check to see if you have nulls for either one of them. And if you do, perhaps provide a message to the user, and then let the application continue to keep going. Here though, we're just going to keep this where it's going to continue to short circuit. So at this point in time, we now have an application that tells the user that their invalid input is occurring for their first or their second value. Otherwise, it's going to continue on. Now there's one last little thing that I would like to do here in this program to clean it up just a little bit. We have a little bit of duplication here with this print line. And what we can do is we can actually return a value from a when clause. So I'm going to say val result equals when, and then we're just going to get rid of these print line statements and get rid of the other parenthesis on the other end. And now we have a double that we can use. And then what we can use is just go ahead and print line the result. And this really cleans up our when clause. Now we can actually see it's really easy to read, and it's very easy to follow that we have an operator, we have a left-hand side, a right-hand side. Based upon the operator, if it's plus, minus, multiplication, or divide, we're going to perform those operations with the left-hand side and the right-hand side. Otherwise, we don't support whatever operation is thrown, and we'll basically throw an exception. And then finally, once that result is returned, we'll go ahead and print the result. So let's go ahead and run the application again just to see what it looks like. So 1 plus 2, there's 3, 3 plus 5, 10 times 7, 70, 90 divided by 6, 15. So now our application works. We've added some validation in here to accept only valid chunks of input. We've made sure that we can only accept certain parameters, and we're providing feedback to the user. And then of course, when we're done, we can just hit enter, and the application will say goodbye, that we're completely done, and then the process exits. And you've now written your first calculator app. Now the next thing is how to deploy it so other people can use it. You've built your first application and it runs within the IDE. However, you would like to share it with others. To do that, you can build a jar file. What you'll need to do is go to File, Project Structure. You want to make sure that you have the artifacts item selected on the left-hand side. You'll hit the plus icon, select Jar from Modules with Dependencies. You'll make sure your module is selected. In our case, Simple Calculator is the one that I want. Then I'm going to select the main file, which is main KT in our case. We'll click OK. And then at this point, you can press Apply and OK. You're now ready to build your jar file. To do so, you'll go to Build menu and then Build Artifacts. And you'll get the pop-up and just click Build. And you'll notice the build is happening down here in the bottom. And actually, it's already done. And what will happen is some files will be placed into the out folder. So let's go ahead and expand those out. You'll see Artifacts, Simple Calculator jar. And there is our jar file that can be executed on the command line. So you'd be able to actually send this to someone else and they could execute it. So let's do that. I'm going to right click and open this area in the terminal down here. And this is going to open up a terminal directly in this folder path here. So you can see out artifacts, simple calculator jar. So what we see here is this exact folder that's right here. So we are now in the terminal of this location. We can see ls. And I can run this jar file by typing java jar simplecalculator.jar. I'll hit enter, and now our program is executing. Please enter our arithmetic problem. 1 plus 2 is 3. 4 plus 5 is this. 40 divided by 7 is that value. 8 times 22 is this value. We'll hit enter, and of course we get it to exit. So now you have built your first Java application, compiled it down to a jar file, which then you can take and send to anybody else, and they can execute this program on their computer. Now, be aware if you do send a jar file over email, most likely most email providers are probably going to strip that file out, as it can be considered an executable. So you'll need to get it to them a different way, maybe through a file sharing service of some sorts. So that's how you can build a jar file, simply through IntelliJ, and then you'll get your jar file. Congratulations on creating your first application. Playing with Kotlin inside of an IDE is going to be the best way for you to learn. However, sometimes you can also learn directly on the web. And to do that, the folks over at JetBrains have set up play.kotlinlang.org. And here you can log in for free, not even log in, just access play.kotlinlang.org and start writing code right here in the browser. So now what we can do is we'll say hello from Don, for example, and I can run this code. And what we'll see, it'll run and compile, and we'll see the output. Now, one of the coolest things we can do inside of here, we can write a bunch of code, and then you can also share it. So you can click share, and you can copy this link, or you can directly embed it, send it to Medium. And so let's say I've taken this and I've sent it to somebody else. So I have a new incognito window open here. If I paste this, what we'll see here is we have play.kotlinlang.org, and it automatically loads the code that I'd written. So hello from Don has been pasted inside of here. So actually, if you actually take that URL that you saw here in the video and pasted it in, you should see this directly from me right here in your browser. Now this is a great place to play around. There's also the hands-on, and there's some examples, and koans. Now Kotlin koans are great. Koans are a series of set of exercises that allow you to get familiar with the actual Kotlin programming language. And the nice thing about it is they actually give you a test that you can actually have to basically make pass. So you have to actually fix the code and make these things pass in real time. And you can do it right here on your browser. They give you progress that you can follow along the way. So if you've learned Kotlin from me and you're watching these videos and you've picked up quite a bit and you want to take your exercises a little bit further and challenge yourself, I advise you go to Kotlin. Go to play.kotlinlang.org. You can play around the playground, and you can also visit the Kotlin koans and explore other examples as well. I hope you enjoy. Woo! You made it! Congratulations on finishing the Kotlin programming language course. It was over 9 hours of content you just watched. You should feel Proud of yourself for finishing this. This is quite the accomplishment. You now should have a solid fundamental understanding of the Kotlin programming language, and you should be able to go start providing value at your company's project, your own personal project. It doesn't matter if you're a developer, engineer, scientist, doctor, or whatever. I hope you have received a lot of value from this course. I hope you have learned Kotlin, and I hope it produces a ton of value in your career moving forward, and I wish you nothing but the best going forward. Thanks again for watching the video, and I'll catch you next time.